side effects, and functional purity. What does that mean? Well, let's go back to my diagram here. You might remember this from the first part where we said a input is, well, we give a function input of some sort. It could be an empty input or it could have parameters like 5 and 10. A function does something that we define. It has its own scope. Remember, it's its own universe. It could have console log. It could do a bunch of stuff. And then it asks, am I returning anything? You can, this should be undefined. So you can return a value, or if it doesn't return anything, it just does undefined. Now, the two words that I just said, side effects and functional purity. Well, side effects are any of these things. Any of actions that happen inside of the function that we don't really know anything about. If it interacts or reads or writes to an external variable, for example, or console logs, well, that's a side effect. If we change here a variable 1, a equals 1, and then I have a function that changes a, well, that's a side effect. That's something that the function's doing to affect the outside world. Remember, we want to think of functions as its own universe. And if it starts affecting the outside world, I mean, it's not the end of the world. We've done console log before. We've done this before. But it is good practice to avoid these side effects. And by avoiding these side effects, we have something called functional purity. And functional purity is a concept where we say, in order for us to write really, really good programs, we want to avoid side effects. And we always want to return so that this and this are gone. And we always return something. And what's the power in this? By avoiding side effects and always returning, we create something that we call deterministic. And deterministic is a word that you may have heard. It means that no matter what, if my inputs, let's say 5 and 10, go through this function, this little universe, the return value will be always the same. Let me say that again. The input, whatever we put in the parameters, whether it's empty or it has certain parameters, it always returns. If we run this 1,000 times, it always returns the same value. That's determinism. It's a very important concept, and that's a key principle in avoiding bugs. Because if this function always does the same thing, well, then you know exactly what it does and you won't have random errors popping out here and there. That's what I want to leave you with. Although this is not the law, and you'll find code bases that will have a lot of side effects, there's going to be a lot of things happening inside functions that maybe even affect variables that live outside of a function. It is really, really good practice to be a top performing developer to have this in mind of creating functions that minimize side effects and have functional purity, what we call determinism, where anything you put into the function, it always returns the same thing. All right, that's it for now. Go try out some exercises. I'll see you in the next one. Bye-bye. And we're back to talk about arrays again. In the first section, when we talked about arrays, we said that they looked something like this. Square brackets, and we can put whatever we want. We'll just put in a few numbers here. So these are arrays, and we talked about the fact that we can do for loops with them. We can do for each with them, which was new in ECMAScript 5. And today we're going to learn a few more. But before we do that, let's remember how the for each works. Let's say we wanted to multiply every single number in the array. We can just do const, remember. Now we can just use our new ES6 syntax. And we can say that new array equals array dot for each, and it reads nicely, right? For each array, we are going to use a number, and we're going to use arrow function. Again, no more function word. Everything looks nicer this way with the fat arrow. And for each number in the array, we'll say number times 2. So multiply everything by 2. Now let's see what that gives us. Console.log new array. Undefined. Well, because that's not how for each works, right? For each just says, I'm going to loop over these elements and I'm going to multiply number by 2. But we're not changing the array. If we look at the array right now, well, it's still the same thing. 1, 2, 10, 16. We're just randomly multiplying the numbers by 2, but we're not really storing it anywhere. If we want to do what we're doing, then we have to say const double, and we'll say that double is an array, and then double dot push. So we're pushing onto the array as we loop through it, number times 2. Now let's see what double gives us. I save, I'm going to refresh, and look at that. I get 2, 4, 20, 32. Okay, now the ones we're going to talk about today is map, filter, and reduce. I would say that these 3 are probably the most important methods that you'll use in your day-to-day JavaScript. They're super useful, so really start to become familiar with them. And anytime you think of doing some sort of a loop, most likely you want to do one of these 3. Let's start off with map. The above way of doubling each thing in the array and creating a new array, well, with map, we can do const map array dot map number is number times 2. And the way map works is that you always need to return something. Because what's different for map than it is for each, well, for each just loops over something and it just does whatever the function says. Versus with the array, we can do what we couldn't with for each, which is loop over each element, each number, and return a new array. Let me show you what I mean. Every time the array loops, so let's say over here, the first one is number 1, we return 1 times 2. That gets put into map array, which is now 2, and then we go to the next number, 2. 2 times 2 now gets added to the array. 10 times 2 gets added to the array, and 16 times 2 gets added to the array. So that's why we return it. And by doing this, if we console.log map array, and let's refresh here. Oh, and forgot a closing bracket here. Let's try that again. You see that map array, so the first one is double, and the second one is map array. We'll name these just so we know the difference. And let's just redo that all over again. By the way, you're wondering why I'm refreshing instead of just copy and pasting it down here. Well, that's because we're using const, it's saying array has already been declared. So have to refresh. But there you go, for each and map. Looking at these two, they seem to both be doing the same thing. But there's a critical difference between map and for each. And I'm here to tell you that whenever you want to loop, do a simple loop and take some action on something like an array, you want to use map over for each. With for each, the operation may do nothing. You can just leave this completely blank or do console log, because all for each cares about is to iterate, which is going one by one, to iterate over a collection of elements like 1, 2, 10, and 16, and apply whatever operation we tell it to on each element. Now, map, on the other hand, has a restriction on the operation. It expects the operation to return an element. So with map, with for each, you can have multiple lines of code doing all these crazy things, versus map. With map, you always have a return element. The map iterates, again, loops through over a collection of elements, applying the operation on each element. And then finally, storing the result of each invocation of the operation, that's this, into another collection, which is map array. In other words, map transforms the array. It creates a new array, which is map array, versus for each, which just does a whole bunch of actions based on the array. And what those actions aren't really that limited. If we want to return a new array, we have to create our own array and then push. And you might notice here something that we spoke about in the last section when we talked about advanced functions. And that is the idea of side effects. If we go back, with for each, you can do a whole bunch of side effects within the function. You can console log, you can create a new array, you can push to that array, you can return undefined. You saw that when we first did the for each, or even now, we're not really returning anything. So we're returning undefined. Versus with a map, all these side effects are theoretically gone. And because with a map, we have to return, let me just show you. If I don't return here, let's see what happens. I get map, undefined, 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 undefined. Right away, we know that we're doing something wrong that we need to return. And as we mentioned in the previous section, we've now created a pure function where there's no question about whether we return or not. We have inputs, a function with no side effects that just simply returns a value. Again, a very important concept. We want to keep things acting in an expected way. We don't want to have a piece of code that lives on a website, let's say for 4 years, and somebody comes along who doesn't know it intimately, and all of a sudden have all these side effects happen that they don't know about. Again, we want to write pure, simple functions, and that is what map allows us to do. And the other important thing is that we're not changing the array. This array stays the exact same with map because we're always just making a new copy of the array. We're never mutating the data. All right, so that was map. Let's bring back the return here, and let's bring back the console. I also want to show you that when you only have a single parameter with an arrow function, you can actually avoid the brackets. And again, because we're returning, and we're just returning a single line here, we can do shorthand, which is just this. How much cleaner does that look? Let's again test it out. There you go, everything's looking nice. Look at that difference between the map and the for each. The next one I'm going to show you is filter. Now with filter, we can say filter array. And as the name suggests, we can filter our array with a condition. In our case, we can say, let's return all the elements in the array that are above 5. So we can say number is greater than 5. And as with map, this returns a new array. So we have to return something because filter array is going to contain that information. So the way you read this is filter this array, which is up here. As you're going one by one, so number will be first 1. Return is 1 greater than 5. In this case, it's going to say that's false. So we're not going to add this into the filter array. Then it iterates to 2. Is 2 greater than 5? Nope, that's false. So it's not going to go into the filter array. Is 10 greater than 5? Yes, it is. Good. 10 is going to go into the filter array. And is 16 greater than 5? Yep. Then 16 is going to go into the array. And again, because it's just a single line, we can do short form here. And now if we console.log and we'll say filter array, and refresh, we get the filter containing 10 and 16. If we do equals to 5, well, in that case, we get an empty array because nothing equals 5. So you can put any condition you want in here. If you had string and you want to see if it contains the word hello, well, you can do that as well. All you have to do is return true or false. If it returns false, it won't go into the array. If it returns true, well, it will go into the array. Very cool, very useful. What else do we have? Well, the last one I want to show you is reduce. And this is really, really powerful. You can do a lot with reduce. You can actually do filtering and mapping with reduce. So it's a really, really powerful method, but I'm going to show you one easy way to get you started. What we're going to do is we're going to say const reduce array equals, and again, this returns a new array. We say reduce, and reduce takes something called an accumulator and the number. Now, obviously, this can be any name. Sometimes you'll see ACC for accumulator. We'll just leave it like that for now so you can see. We know what number is. Number is 1, 2, 10, then 16. But what is accumulator? Well, accumulator is something where we can store the information that happens in the body of the function. Let me explain. Accumulator plus number. And again, because with reduce, we're returning an array, we have to return a value. And what we're saying here is that every time you iterate, so let's say the first go around, you have number 1. Accumulator plus number 1 equals, let's say if the accumulator is 0, then it'll equal 1 now. 0 plus 1 equals 1. When 2 comes around, we do 1 plus 2 because the accumulator remembers what was there previously. And then 10 comes around and you go 3 plus 10. Now, what is the accumulator? We haven't defined it anywhere. In reduce, after the function, you have a second parameter. And here we can specify what we want our accumulator to start with, the default value. In our case, let's say 0. Now, if I do console.log reduce and do reduce array, let's see what happens. We get reduce 29 because 10 plus 16 is 26 plus 3 is 29. If I change this to 5 and I copy and try this again, we get 34 because the starting number is now 5. Very cool. So that's it. I want you to remember these 3 methods because you're going to be using them a lot in your career. They're very, very useful. They're pure, which means every time we do an operation, whatever inputs we get in, it always returns a value and there are no side effects. And as you can see, they're very easy and simple to read. So get used to them and good luck with the exercises after this video. I'll see you in the next one. Bye-bye. Welcome back. We're going to talk about some advanced objects concepts. Now, as I said, with both arrays and functions, these are advanced concepts. You're probably not going to just get it 100% the first time around, but use these videos as a reference to come back as you progress through your career. Now, in this video, I'm going to talk about 3 things that are important with objects. We're going to talk about reference type. We're going to talk about context. And finally, we're going to talk about instantiation. So let's get started with the first one, reference type. What do I mean when I say reference type? Well, I want you to see if you can guess what's going to happen when I do array equals array. What do you think the answer is going to be? Let's see. Interesting. Okay, what if I do array1 equals array1? Interesting. Okay, one more question. What about something like this? Object1 equals a value of 10. And we'll say object 2 equals object 1. And we'll finally say variable object 3 equals value 10. So looking at these, and I'm actually going to copy it on here so you can see it as well. Looking at this, what happens if I do object 1 equals object 2? What do you think will happen? True. Okay, that makes sense. I mean, object 2 is object 1. But what if I do object 1 equals object 3? Here I get false. But why is that? We have value 10, they're both the same thing, right? Let's check something else. What if I do object 1.value equals 15? Okay, and now I do object 2.value. It equals 15, but if I do object 3.value, I get 10. Well, that was confusing, right? Let's look at what's actually going on. And this is the first topic we're talking about, which is reference type. Let's look at a diagram. Objects are what's called the reference types in JavaScript. Up until this point, all the other JavaScript types that we've learned, including numbers, null, we have undefined, booleans, strings, even symbols, they're all defined by the programming language. So JavaScript, the person who wrote JavaScript and ECMAScript, the standard, says these are primitive types. We tell you what they are. Now, a reference type, which is a non-primitive type, are not defined by the programming languages. What that means is that they're created by the programmer. So let's look over here as an example. When I say variable number1 equals 1, JavaScript knows what 1 is. It's a number, and it's a primitive type. It's always the same thing. It's immutable. Every time it uses a 1, that's the same one that JavaScript knows about. When I do variable number2, it's using the same number1 that JavaScript knows about. However, when we created object1 equals value 10, and object2 equals object1, and object3 equals value 10, well, those were created by the programmer. They're reference types. So what we said was, I want object1, create a new object. We'll say this box over here, this filing cabinet, and in it, put value 10 into this box. Object2 says, I want you to just reference, and that's where the word comes from, reference object1, saying, hey, I want whatever's inside this box. When object3 gets created, it's a new object because we have the new brackets, and it's saying put value 10 in this box. Essentially what we're doing is saying, when we create variable object1, we're storing just a reference, an address to where we're storing the value 10, which is box 1. So we're saying object1, I'm just letting you know that this is the address of all the contents that you want. And that's in box 1. Object2 is saying, I want whatever is in object1, and we look in object1, and object1 just has the information of box 1. So it references that. And object3 creates a new object, so it's saying, I'm going to put my contents in box 3, and I'm just going to have the address of the box saying box 3. That's right over here. So going back to our example, this makes sense. When we changed object1 value to 15, we changed the contents of box 1. So when we do object2.value, which is referencing the same box as object1, that's 15. But object3.value doesn't change because that's interested in a completely different box. It's box 3. And going back to the first example, arrays, well, as I mentioned in previous videos, arrays are just objects at the end of the day. So when you create an array, it's the same thing, creating a box, a data structure, and this is creating a second data structure. All right, so that is reference type. A very important concept, but I think you get it, right? Let's get to the next one. This gets a little trickier. This one's called context. And context gets confused a lot with scope. If you remember, we said that scope is created when it sees curly brackets, right? We said that if we create a function, as soon as we create that function, there's a new scope that's created. So we can have let A equals A, and that lives within this universe. It doesn't know anything about the root scope, which is over here. So if I do console.log A, well, it's not going to work. Oh, and we need to actually assign something, and we need to name it. So let's just say B. So if I do this, well, console.log A will just return reference error because it doesn't exist. So that's scope. Now, how is context different? Context tells you where we are within the object. Let me explain. If we say console.log this, well, you see, I get some highlighting. And this is the first time we're seeing this. And it's a special word in JavaScript, probably the most confusing word that a lot of people have trouble in. Even people that have been in the industry for years still have a difficult time with this. But let's see what it is. This is, as you can see, the window object. So just to double check, if I do console.log this equals window, I get true. And I can access this dot alert hello. So what this means is, what is the object environment that we're in right now? The best way to think about it is, what is to the left of the dot? So right now I'm able to do alert because I'm inside the window object. So doing window or doing this is the same thing. Now, why is that important? Well, when we get to instantiation, I'll show you why it is. But it's a very important concept that you'll see again and again. But remember, this just refers to what object it's inside of. Two more examples to demonstrate this. One is if I do function A, within function A, we'll say console.log this. So if I call A, what do you think happens? Let's see. Still the window object. This still refers to the function. And if you remember, that's because I said it has to be what object we're inside of right now. Technically, function A, I can go window.a and run the function. So to the left of the dot, well, that's the window. In order to create a new value for this, you have to do something like this. Object A, function A. Now if I do function, and within here I do console.log this, well, in that case, if I copy this and run object for.a, well, now this is the object, which is object 4. So why is that important to us? Well, first of all, you'll see it in other code bases, so it's good to know. But it's really important when we do instantiation. Instantiation is when you make a copy of an object and reuse the code. Imagine you're building a big multiplayer game online. And this game's going to have many, many players. You can have wizards, you can have trolls, warlocks, elves. Now, if you had to create an object for every single player, that's a lot of repeated code, that's a lot of hassle, and well, that's a lot of your time, and it's not very efficient. To solve that, you can do something called instantiation. You're making instances or multiple copies of an object. So let me show you how we do instantiation in JavaScript. Again, this is going to look a little bit weird at first, just like for loops did, just like functions did at the beginning, but it's just the syntax and you'll get used to it. So let's say we have a player class. Now you see the new syntax already, and I capitalize a class. Now think of a class as something that I want to make a copy of. If I ever want to make a copy of an object, it's a good idea to do something like this so that, well, you'll see how easy it is to copy this now. So we do class player, and within here, we'll say constructor. And I know this looks weird, but again, it's just syntax. Let's give it, this player can have a name and a type. And within the constructor, this.name equals name, and this.type equals type. Oh boy, what just happened here? Constructor, when you create a class, a player class, says every time I'm making a copy of a player, the first thing that gets run is the constructor function. And this constructor function is going to create these properties on the player object. So a name and a type. And now I can create anything that I want for the player. Let's say we want to create a method such as introduce that console.logs with backticks. Hi, I am. And again, we remember the syntax template strings. This.name, I'm a this.type. Awesome. So now I'm saying this player class, any player that I create will always be able to introduce themselves. And they'll also have this name and this.type. And the reason we use this here is that when we create a player, we can access the name and type property. I'll show you later on how that works, but this is just a syntax you're going to get used to. In order to access the player and make copies of it, you'll have to run a constructor, which is all the properties and methods that you want the player to have. You can also create methods that players can have. And anytime you want to access a property within the constructor, we'll use this.name. If I want to use introduce, I'll have to do this.introduce. Okay, so we have a player, but when we're building our multiplayer game, we want to now copy this, but add on to it. Let's say we want to create a wizard player, a player that's a wizard. In that case, we would do class wizard, again, capital letter, extends, and again, it's just the JavaScript keyword player. So what is this saying? I'm saying I want wizard to extend whatever player has. So I want to add on top of whatever player has. Again, because it's a class, we'll have to do a constructor. And this wizard is going to accept name and type. And within here, this is the tricky part. Anytime we extend something, we need to also call the constructor function of the player. We have to do something called super with the properties that we want to pass to the constructor. In this case, name and type. I know this is confusing. It's just something you have to do. Whenever you extend a class, you want to use super so that you essentially have access to these. Okay, so let's say that with the wizard, we also want to have a play function. And the play function will just console.log I'm a this type. And now that we have our wizard, what's the power? What's the reason that we just did this? Now we can do this. Instead of constantly creating players and then saying that they are wizards and they can play, now I can say wizard1 equals new wizard, and we'll call the first wizard, again, we get name and type. So we'll say Shelly, and she'll be a healer. And if I want to create a new wizard, I'll just say wizard2 equals new wizard, Sean, and he is dark magic. Whew, that was a lot of new syntax. So let's go through it and make sure we understand everything. As we've learned, let's use console log to really understand what we're doing. I'm going to add a console log right at the top over here. And we'll say this. What is this? I'm going to save. And actually, I'm going to copy this into the console. Let's copy it and see what the console log gives us. We see that we get wizard. All right, let's go through everything here. I say we have a class player, then a class wizard that extends player, and then we have two variables that we created, wizard1 and wizard2. Now, the program is going to see the new keyword, and anytime it sees the new keyword, it says, oh, we're creating a new wizard. And this wizard is going to have two parameters, Shelly and Healer. So it's going to go to the wizard class. Again, because it has this new word, it goes to the wizard class and it says, hey, wizard, I want you to extend player. So it's going to go to the constructor and it's going to see this super. And what this does is it takes us up to the constructor of the player and it runs this. And now it attaches this as the wizard. And then it introduces the new function and then adds the play function. Now, if I go to wizard1 and I say play, I get I'm a healer because Shelly's a healer. But I also have access to wizard1 dot introduce. Hi, I am Shelly. I'm a healer. And we also have access to wizard2. Oh, I have to run this again. Let's run this again. And I don't think I copied the second wizard last time. So now I have wizard2 introduce. Hi, I'm Sean. I'm a dark magic. That sentence doesn't make sense, Sean, but that's okay for now. Let's just try something. If I do console log here, and we'll just say wizard, and here we'll say player just so we can distinguish between them. And I'm only going to copy the first wizard so that we don't get two of these running. Again, because we're creating two wizards, we're going to have this run twice. But just for our sanity, we'll run Shelly. So I'm going to refresh and add here. Oh, I forgot to add a comma. And let's refresh. And I get an error. Reference error, must call super constructor in derived class before accessing this. What that's saying is that in order for me to access this and get this.type, I have to call super, which runs a construction function in player. So that's what super is doing. It sounds kind of weird, but it's just something that you need. I'm just going to put this at the bottom after we call super. And now it should work. Let's see. I get the first player, wizard. So we call super. As soon as we say new wizard, Shelly healer, I go to the wizard, extends player. I run the constructor function, which says super. Hey, run the constructor function in the player. And I run that. And that's why we log console log player first. And then we go to console.log wizard and then run the rest of the class. Very cool. Now, just to show you something, this is actually new syntax that you'll see in React, and it was part of ES6. But back in the day, this is how we used to do it. The exact same code I have up there is right here. It's called classical inheritance, and it doesn't look too bad, but you see that there's prototype, which it's another thing that you'll see in JavaScript, and to be honest with you, you shouldn't really use it. It doesn't look very nice. And you see that we have to attach play to both wizard1 and wizard2, and it just doesn't look as nice as this. And once you get used to everything, it's not too bad. All we're saying is, as soon as we say class, we say, hey, we're probably going to make a copy of this object. So we want to make copies of player, we want to make copies of wizard, and that's called instantiation. When I do the new keyword, I say, make an instance of wizard. And wizard uses some functionality from the player and adds its own little play function as well. Holy moly, that was a lot. Like I said, this is something that you'll have to come back to and you won't get it right away. It's really, really hard to fully understand the topic without actually having to use it in real life. Just keep this in mind. Every time you hear somebody talk about reference type or context or even scope or instantiating something, well, these are the things that they're talking about. Objects are really, really complicated. They're really hard, but with that, it gives us a lot of power. So with that, good luck with the exercises. I'll see you in the next one. Bye-bye. Welcome back. Let's talk about passed by reference versus passed by value to finish our discussion about JavaScript types. Now, in the previous video, I said that primitive types are immutable. What does that mean? Well, it means that we can't really change them. In order to change them, we need to completely remove the primitive type. And let's say if variable a equals 5, well, in order for me to change what that 5 value is, I have to literally move it from memory and create something new, like a equals 10. I can't really modify it, just something new gets created. And primitive types are exactly like that. When I assign variable a to 5, somewhere in memory, variable a is going to contain and reference the value 5. If I do variable b equals to, let's say 10, again, same thing. And they don't really know of each other's existence. This is what we call pass by value. Objects, on the other hand, are what we call pass by reference. Let's write some code to figure out what this really means. If I do variable a equals to 5, and then I do variable b equals to 10, well, a now has an address of where this primitive value 5 sits in memory. And same with b. b has an address of where the primitive value 10 sits in memory. What if I do variable b equals to a? What happens then? Remember, primitive types, they're passed by value. When we do pass by value, well, what if I do something like b++ here? So that is add 1 to b. If I console.log a, I have 5. And if I console.log b, I have 6. And this is because of pass by value. All I did, or all the JavaScript engine did, was copy the primitive type value 5 as if I was doing b equals 5, so that now b has a reference to the value primitive type 5. All we did was copy the value. So looking at this diagram should make sense. Anytime, even though we did b equals to a, we simply copied the value and put it into a new memory space in our machine. Remember our memory heap or our stack where we store information? We just simply made a copy. They don't really have any connection whatsoever. And that's what pass by value means. Pass by value simply means we copy the value and we create that value somewhere else in memory. Now let's see how objects are different. Unlike what we had before, or let's keep this here for now, just so you can see. If I create an object, let's say object 1, and object 1 has name of Yao, and let's say this is a user that also has a password. with 123 as the password. Super secure, I know. And we're also going to create another object, let object2. And this is going to be, well, we can just copy the first object. So object2 and object1 should be the same, right? But what if I go ahead and with object2, I change password to equal easy peasy? What will happen then? If I console.log object1, and I also console log object2, and I run, whoa, what just happened? Password has been changed. Both object1's password and object2's password were updated by doing this. And this is due to pass by reference. You see, objects in JavaScript are stored in memory and are passed by reference, which means that we don't copy the values like we did with primitive types. We simply, when we assigned object 1 to object 2, we simply said, hey, this is where the object is in memory. If we go back to the code, object 1 and object 2 are both pointing somewhere in memory, we don't know where, somewhere in the memory heap, to a shelf that contains this information. So all I did by saying object2 equals object1 is, hey, this is, let's say, the address in memory of wherever this is located. So that what that means is when I change object.password like this, I'm saying, well, change password on this object in memory that also object1 is pointing to. It's referencing. That's where pass by reference comes from. Now, why do you think that's a good idea? Let's think about this. Why is this good? I mean, it's kind of nice, right? Because by just having one object here, we're saving space in memory. We're not copying and cloning the object, creating multiple versions. We can simply save memory, reference just one location, instead of just loading up our memory heap. But why might this also be bad? Well, because unlike a primitive type, we might have this issue where by mistake, somebody else changes a property on that referenced object. So this is something that we need to be careful of. Let's do another example. And just to prove, like I said before, that arrays are simply objects, let's try this with an array. If I do variable c, and this variable c has 1, 2, 3, 4, 5, and then variable d is equal to c, and then finally we'll say d.push some giant number. I want to make sure it's a number, not a string. If I console log c, or let's console log d first, and I run this, I see that, yep, we modified the array. But because arrays are objects, they're passed by reference, c should also have changed, right? If I console log c and I run, yep, c has also changed as well. We notice something here, right? This is good. We're saving memory. We're not just constantly copying things. Imagine if C was a massive, massive object. If we're copying to different parts of the code every time, well, this would create a lot of memory. But then there are times where maybe we do want to clone an object, copy it, so that we don't modify it like this. How can we do that? Well, with something like an array, there's different ways of doing it, but I can simply do array, an empty array, and then do the concat method which pushes whatever I have in C into this empty array. So that when I run here, you see that C is still the same, but if I go to D, I have a new array. It's cloned an array. Objects are a little bit more difficult. Let's say we had an object that equals A1, let's say B is 2. That's a little confusing. Let's do AA, and then B, B, and then finally C equals to C. And this object, I want to copy. I want to have this piece of code, this object, in a different location in memory. How can we do that? Well, I can't do another object like this because it's simply going to pass by reference, and we're still going to be referencing the same object. Instead, we can clone an object by doing something like this. Object.assign. And in here, the first parameter is the object to copy to, which is an empty object. And then what is the source? So that is from which to copy the properties. So in my case, it'll be the object. So that now, if I change, let's say object A, or let's do object C to equal 5. If I console.log the clone object and I run, oh, I made a little bit of a mistake. Let's see here. Oh, I've had a semicolon instead of a comma. There we go. If I run this, look at that. The cloned object was not affected at all, even though we changed C to be 5. Remember, if we didn't do this, we didn't clone it, and we just did object, that would have been passed by reference, and we would see the change that we saw in the original object. But because of object.assign, we are able to clone the object. Very cool. There's also another way of doing it, and that is using the spread operator. I can do let clone 2 equal object, or not really, we just create an object and then do ... and then the object. Nice and clean. And this is a new feature that we got in the JavaScript language, which is really, really nice. And once again, if I run this code, I see that clone hasn't been modified. And if I do clone 2, that hasn't been modified either. Just for reference, I'll add the original object as well to see that indeed it is different than what we had before. Awesome. So cloning is great. But let me ask you this. What do you think will happen with the code that we have if we have an object inside an object? For example, if C, instead of just being a string, is another pass-by reference object that, let's say, has deep as a property. And this deep is going to equal try and copy me. I hope that makes sense. Let me adjust the indentation here so you see it better as to what is happening. So what happens here? We have an object that is referenced somewhere in memory. And inside of that object, there's, again, another pointer to another place in memory that references this object. Let's run this code. Well, nothing has changed, right? I mean, C has obviously changed, and well, that's something that we already saw before. But what if I change D this time around instead of C? What if I do object.c.deep? And deep is now going to say, ha ha ha. What do you think will happen here? Let's run this code. And oh no, We cloned everything, but it got overwritten. I thought we cloned everything. What happened here? Remember, each object gets passed by reference. So although we cloned the object, the initial object, this is what we call a shallow clone. It cloned the first level. So that is the memory address in this object. But within this object, there was another address to another object. So again, remember, this is just another address that we had someplace in memory. And this address, well, it never changed. It always referenced this object. So this is shallow cloning, where we can only clone the first layer. That's a big problem, right? How can we do deep cloning? And the way we can do this is, well, a little funky. We use JSON. We say let superclone. And we're going to use the JSON.parse method. And this is beyond the scope of the course. You can read up on what JSON parse does. But this JSON object is going to say JSON.stringify. Let's make this a little bit bigger. There you go. We're going to stringify, that is, turn everything in here into a string. And then once we turn everything into a string, we're going to parse it and turn that string back into an object. So that if I do superclone now, at the bottom here, let's do superclone, and I run. Look at that. Try and copy me. Superclone, let's make this a little bit smaller. There you go. Superclone version did a deep clone of the object. Very, very cool. Now, before I end this video, I hope pass by reference and pass by value makes sense to you. Now, I do want to give you a bit of a warning. However, if you're doing a deep clone, well, you should be careful because this can have some performance implications. If this object was extremely deep, a massive object, it's going to take a long time to clone everything, right? So you won't see this out in the wild too much. If you're cloning objects like this, there's most likely some other ways that you should be doing things. But I wanted to show you the idea of pass by reference, the idea of shallow cloning, deep cloning, and some of the ways that we can use objects to get the desired output. All right. I hope that was fun. I'll see you in the next video. Bye-bye. Type coercion. If there's one thing that's going to make you pull out all your hair out of frustration, it's type coercion. If you Googled type coercion in JavaScript and looked at some of the posts, you're going to see a lot of people angry at some of the funky things that JavaScript does. And we're going to talk about that. And I'm going to just give you a brief overview of it because it does get really convoluted, complex, and it's something that you should understand and know what it is, but you don't have to know every single detail because most of the tricky parts, well, you shouldn't be using it in your code because it's confusing. So what is type coercion? It's something like this. 1 equals to string 1, and that equals to true. You see, type coercion means that when the operands, that is, the things to the left and to the right of the operator, are different types, that is, number and string type, one of them will be converted into an equivalent value by the JavaScript engine. So the JavaScript engine is going to say 1 equals to string 1. I think you mean number 1. So it's going to do this for us and compare number 1 to number 1. Now, based on that definition, type coercion means the language converting a certain type to another type. Let me ask you a question. Do all languages have type coercion? What do you think? Yes, they do. Because we always need to convert types between programs to do things. In memory, different types look completely different than what we type, right? The number 5 in actual physical memory on my computer is represented in ones and 0. And all languages do this. So there is some sort of type coercion at different levels of the stack. It just so happens that JavaScript has an especially heavy type coercion nature to it because it's dynamically typed, which is why it does this. Let's go back to the example. In JavaScript, type coercion happens when you use the double equal. Double equal sign simply means compare the two values, and if they have different types, try to, coerce one into the same type. If we go back and do a string here, and I do 3 equals, and I run, I get false. Because 3 equals in JavaScript means compare two values, but don't try and coerce the values. Be explicit with your comparison and do exactly what I tell you. So, is there ever a time you should just use 2 equals instead of 3 equals? I would say that no, there isn't. Some people may argue that double equal can actually have some interesting applications where we coerce something and we do some sort of checking really quickly. But it's not predictable code, right? It can be confusing. It could really be a gotcha and trick some people. So always use 3 equals instead of 2. Now, type coercion doesn't happen just with the equal sign. You can also do an if statement. So if 1, then return 5. And if I run this, there's no function in here. Let's do console.log. I've been recording for a long day today, all right? So give me a break, everybody. All right. If I run this, 5 is logged. Why is that? Because JavaScript coerces 1 to equal true. What if I do 0 here? If I do 0, nope. JavaScript coerces this and says, well, I want a Boolean here. So I'm going to take your 0 and turn that into a false. Now, this sort of type coercion, there's a lot of interesting specifics to it. And as a matter of fact, there's a nice little website that shows you some of the comparisons that JavaScript does. With 3 equals, that is, with no type coercion, things make sense. You see that false equals to false, and that's it. You can see that string false only triple equals and returns true with string false again. But if we do double equals, well, oh boy, that's just a mess, isn't it? For example, string 1 is the same as true. An array that contains 1 is also true when it's compared to string of 1. And there's so many weird little edge cases here. If you want to play around with this, go for it, but I like to stick with triple equals. You can also see some of the if statements here and some of the if cases that can really be tricky. Now, if we go to this MDN page, which I will link to in this video, we see that we have the double equals, the triple equals, but then also something called object.is. That's fairly new to JavaScript. And this is an interesting one that you most likely won't see very often, but I think it's interesting, so we're going to talk about it just quickly. You see, in JavaScript, there's a concept of -0 and +0. Strange, I know. So if I do -0, triple equals +0, and I run, I get true. But they're technically different things in JavaScript. So I can actually do object.is and give it the 2 parameters and run, and I get false. Now, why is this useful? If we go back to this page, we see that object.is works pretty much the same as the triple equals, except for a few cases. That is the plus and -0. And if we scroll all the way down to this funky little NaN, not a number. And we can do a whole course on how weird this not a number is. But if I did not a number, which represents not a number in JavaScript, and I do triple equals not a number, I get false. But why is that? This should be equal, right? So if we use object.is, this turns into true. Again, most likely in your day-to-day programming life, you're never going to encounter this problem. But I wanted to demonstrate for you how confusing type coercion can be. And if you're the type of person that just loves type coercion and wants to read all about it and understand all these intricacies, I'll link to the actual spec that talks about how the equality comparison algorithm works. For me, if I read this, it'll be a good bedtime reading to make me fall asleep. If you're interested in it, you can have a look. The main takeaway from here is that, well, you should use triple equals because type coercion in JavaScript can be really tricky. By the way, as a fun little side note, this is a screen capture I took from Netflix watching this great, hilarious documentary, and you see that bugs in the code are unavoidable. Even the mighty Netflix, every once in a while, has an issue somewhere, not a number. All right, that's it for now. I'll see you in the next one. Bye-bye. ES7, which was introduced in 2016, is very, very easy to grasp. Why? Well, because unlike ES6, which had a lot of changes, ES7 only has 2 additions to the language. In this video, I'll go through both of them. The first one we're going to talk about is the includes method that was added on strings and arrays. Let me show you. I can do something like hello.includes, and I can say O. And if it includes O, I'll get a true. We can also use it on arrays. So for example, if I had an array, let's call it pets, and in the pets, I have cat, dog, and a bat. I know that's a weird pet, but I'm sure there's some bat pets out there. All right, and now in here, if I do pets includes dog, well, if I run this in the console, I get true. If I do pets.includes bird, I'll get false because it doesn't include bird. Very simple. That's it. That's one of them. And then the second one is the exponential operator. So if I wanted to have a function that, let's say, squares something, I can do function x is x star star 2. And that means x to the power of 2. So again, if I run this, and then I do square of 2. Oh, and I cannot spell. Let's try that again. Square of 2, I get 4. If I do square of 5, I get 25. If I wanted to expand on this and do a cube, well, I can do cube will have 3, exponential 3. So again, if I clear this just to make a bit of space, and I do cube of 3, I get 27. Cube of 4 is 64. And that's it. Isn't that nice? ECMAScript is going to be releasing small incremental changes every year, so it is easy to stay on top of language and avoid scenarios like ES6 where all of these changes were made and people had a hard time learning all of them. Now, with these simple 2 things in your tool belt, go and practice them and see you in the next video. Bye-bye. ES8 has a few more new features that were introduced in 2017 compared to ES7. In this video, we'll just go over the important ones. So the very first one is string padding. We have new functions that we can add to strings, which is pad start and pad end. Now, to demonstrate this, let's go into the console and let's just do a turtle, and we'll do a pad start of 10. If I do this, I get turtle with 10 spaces in front of it. If I do pad end, I get turtle with 10 spaces after it. And this is useful just for aligning characters of strings if you want specific padding for them. Again, very, very simple, easy to pick up, just another string method that we received. All right, let's go into the second one. The second one that we got is something called trailing commas in functions, parameter lists, and calls. What does that mean? Well, now I can do something like const fun A, B, C, D, and add a comma at the end. And if I do a function, let's just say console.logs A, just a silly, simple function, I can now run this function like 1, 2, 3, 4, and then a comma at the end. And this is still valid JavaScript. If I run this, you see that it works. Console log A, which is 1, gets logged. Now, why would this be useful at all? The main reason is when you start getting really, really big parameter lists, you'll see a lot of people doing things similar to this, just to make things a little bit cleaner. And when you start doing this, every time you add a new parameter, it's a lot easier. But also in GitHub, when you make changes, it actually makes the difference, the green and the red differences, a lot cleaner. So it's just syntactic and just make things look a little bit nicer. Again, you normally wouldn't want to do something like this, but maybe when you have long parameter lists like that, the ending comma is now valid and it won't give out an error. All right, let's look at the next one. The next one is we have object.values and object.entries. And these are very, very useful because before these, we had something called object.keys. And object.keys allowed us to do something similar to arrays, but on objects. So for example, if we had an object that, let's say, we'll have an object, and this object will have username 0 Santa, we have username 1 Rudolph, and we also have username 2 Mr. Grinch. Now, looking at this object, because it's not an array, we can't do the map or filter or reduce, but this is kind of an ugly object. And this illustrates a good point. Sometimes when you're working with servers, you'll get objects that you don't really like or you don't want to work with, but you still want to iterate over them. And before, we could do something like this with object.keys. Let me make a little bit more space over here so we can see. I could do object.keys, and in here we'll throw the object. And now I can use it like an array. It'll go one by one like an array. So it's as if it's an array, but except it has property and values. So let's say we wanted to do a for each loop, and for each key, that is, for each key in the array, so for each username, we also have the index, so that is 0, 1, 2. Let's wrap this in brackets. And now within here, we can say console.log key, and then object key. So now we're grabbing the object with the key username. So if I console.log this, let's copy and paste this, clean this up a bit, and I see that I have username Santa, username 1 Rudolph, username 2 Mr. Grinch. And that's one way for us to iterate or loop through objects. But with object.entries, things become a little bit easier. For example, we can do object, let's make more space. We can do object.values, and the object.values, if I do a for each here, I simply grab the value, and from the value, I can just console.log value. And now I get the value of each object. That is, it loops through Santa, Rudolph, and Mr. Grinch. With the entries, if I do object.entries, well, let's see what happens. Let's clear this. I get an array of username Santa, username 1 Rudolph, and username 2 Mr. Grinch. So this gives you a lot of control. You get both property and value, or key and value, and you can do whatever you want with it and use for each, map, reduce, filter, all those array functions. So let's use a real life scenario here. Let's say we just received this from the backend. The backend just sent us a bunch of users that they had in the database, and we want to generate usernames for them because we don't like the username 0, username 1, username 2. We want a display name that displays the Santa with the ID number. That is 0, for Rudolph will be 1, for Mr. Grinch will be 2. How can we do that using our newfound powers? Well, I can just simply do something with object.entries. And object.entries will have an object that I can map over. And this will give us a value. Again, remember that this will return arrays. And here we just want to return, let's do a value of 1 because we want to grab Santa, Rudolph, and Mr. Grinch. So that is the second item in the array. And then we want to add to that, like a string, value 0, which is the first item. So username 0, username 1, username 2. And here we want to replace, this is just a function that we can use on strings, and we want to replace username with an empty string. So what we're doing here is we're creating a new string with Santa 0 because we don't need the username in here. So now, even though we have an object, we can loop through it like an array. And look at that. We have new usernames, Santa 0, Rudolph 1, and Mr. Grinch 2. How cool is that? So these are really, really useful additions to the language, especially object values and object.entries. You can do a lot with it. But there's one big ES8 feature that has arrived that everybody's excited about, and they're called async await. Now, it's brand new and everybody in the community is really excited about it. However, in order to fully grasp the benefit and understand it, we need an entire video on its own. So I'll see you in that one. Bye-bye. Hey there, everyone. We're now ready for ES10, or ECMAScript 2019. That's right, every year they're constantly trying to improve the language, that is JavaScript, and now ES10 is the latest. So what new features did we get in this new version of JavaScript? Well, luckily for you, there aren't too many. So let's start off with my favorite one, and it's called flat. And flat is a method that we can use on arrays. Let me show you what I mean. Let's say I have a array variable that contains a very exciting array of 1, 2, 3, 4, 5. If I now run array.flat, let's copy this code and run it here. What do you think will happen? Well, absolutely nothing. We returned a new array, it looks like, but it looks the exact same. But this is where flat gets exciting. Imagine if this had nested arrays. So for example, 2 and 3 were its own array, and then 4 and 5 were also an array nested inside of a bigger array. If I now copy this, and let's call this array 2. If I now copy this and paste it in here, hey, check that out. We get a new array that is flattened. That is, there's no nested arrays anymore. All right, let's keep going then. What happens if we have array 3? And array 3 is even more nested than we had before. Let's say we have 1, 2, 3, like this. And then maybe we'll have 5 that is, well, nested pretty deep, like that. So now we have an array, there's another array, and inside of that there's another array. What do you think will happen here? I'm going to copy and paste, run this code. All right. So I get a new array back, but we see that there's actually not a completely flat array. Instead, we have 1, 2, 3, 4, but then 5 was only flattened one level. So we essentially just removed these brackets. Now, the interesting thing with flat is that we can tell it how many layers to flatten the array. So if we go back to our example, and in here, the default was 1. But if we change this to 2 now, well, let's copy and paste. Let's refresh this and run it again. Hey, look at that. We have a completely flattened array. So in here, I can tell it how many times I want to flatten or how many layers I want to flatten the array. All right, but I have a really exciting example for you. Get ready for this. Congratulations. You just became the owner of Jurassic Park. You have a park with all these ancient creatures. And the T-Rex over here is extremely dangerous. That's why, well, it's in its own contained area of the park with a lot of barricades around because we don't want the T-Rex going wild. But here's the problem. You're a bad guy at Jurassic Park. If I asked you, hey, how can you completely flatten this array? How would you go about doing it? Pause the video, think about it. Ready for the answer? Well, we can do Jurassic Park dot flat, and then you might want to actually count how many arrays are nested in here. But there is a trick here. I could maybe just do 50. Let's see what happens. If I copy this, let's make this a little bit bigger. I refresh here, copy and paste this. Let's see what happens. Oop, and Jurassic Park should be Jurassic Park. Let's copy this again. Let's refresh. All right. All the barricades are down and the animals are now going wild. And I just randomly picked 50 because I knew that 50 wasn't, well, how many nested arrays we have. Now, in the exercise after this video, I'm going to show you a cool little trick of making sure that we can flatten to the utmost level. But that's for the exercise. Another really useful thing that you can do with flat is, let's say you get a bunch of entries. And these entries from your users come in, and maybe we get Bob, we get Sally entering their name, but then we also get a bunch of entries that are completely empty with maybe Cindy at the end here. Using flat, we can actually flatten the entries and clean up our data. So I can say entries.flat like this, and if I copy and paste this, look at that. It cleans up the data for me, which is really, really nice. All right, the next feature of ES10 is flat map. And flat map, as the name suggests, allows us to use flat function and the map function or method on an array. So let's do something fun here. Let's say we have the Jurassic Park again. And this time around, we're going to use flat map. So let's say Jurassic Park, and we'll call this new variable. Let's do const Jurassic Park chaos. And this chaos will have, well, the Jurassic Park array that we had above. Let's make this a little bit bigger. And now we can use a flat map to do something interesting. I can say for each item that we're going to flatten, we're going to get a creature. And this creature, using arrow functions, is going to get creature plus the T-Rex. So I'm going to copy the T-Rex over here. So each creature is going to get a T-Rex as a neighbor, which is, well, not good. They're all going to get eaten by the T-Rex. Is the T-Rex a carnivore? I'm not sure. You'll have to Google that on your own. All right, so we have the Jurassic Park flat map. So I'm flattening the Jurassic Park and then mapping over this flattened array and doing some sort of a map function to it. So let's see what happens. If I now copy this and I paste this in, if I now check out what Jurassic Park chaos is and I hit enter, oh boy, look at that. We have T-Rex, neighbors with all the creatures, and, well, it's absolute chaos in Jurassic Park. Flat map allows us to use the basic map function and then flattens the result to a depth of 1. All right, let's keep going. Next is a very, very simple one. Let's say you get a user email. And user email, well, gets entered a little incorrectly. So we get a bunch of spaces, and then we have eddietheeagle@gmail.com that we receive from the user. Or maybe we have user email 2. And this time around, johnnydangerous@gmail.com enters their information, but we have, again, some blank spaces. What can we do? Well, with the new ES10 feature, we can simply say user email.trim start on a string, and it will trim the beginning. And user email 2 can say trim end and trim the end of the string. So let's console.log this and see what happens. If I copy this, and make sure we declare these variables, so it'll be const, and make sure that I can spell email right. If I copy this now and enter it in here, I don't know if you can see, but now my strings don't have any blank spaces in them. If I check out user email here, you see that the blank space is still there, but the new generated string, user email start, won't have any blank spaces. Nice and easy. All right, we're flying through these. What's next? We only have a few more left. Actually, 2 more left. The next one is called form entries. It transforms a list of key value pairs into an object. Let me show you what I mean. Let's clear this, and let's just comment all of this. Maybe bring it down to the bottom and focus on this one. So imagine we had some user profiles that we receive. But these user profiles are formatted in the wrong way. So we have, let's say, an array, and inside of an array we have the user profiles of a game. So we have, let's call him Commander Tom as the player name, and Commander Tom is 23 years old. Next we have, let's say, an array of Derek Zealander, and Derek Zealander is, let's say, 40. Let's make this a little bit bigger. And then finally we have an array, Hansel, and Hansel is 18. So we have these user profiles, but as arrays, they're not really useful right now. Wouldn't it be great if we can convert them into an object where each username is associated with an age? Well, this is exactly what entries is used for. We simply do object.form or from entries. So from entries. And from entries is going to receive an array like this. So let's do user profiles here and see what happens. If I copy this code, paste it in here, hey, look at that. We get an object now with Commander Tom, 23, Derek Zealander has a key and a value of 40, and Hansel has a key of Hansel and value of 18. Now, the name might trigger something while you're watching this, because in ES8, we talked about something called entries, right? Object.entries allowed us to do, well, the exact opposite thing. So, for example, if this was now an object, if I do object entries on this object now, so let's copy and paste, refresh this, I get exactly what I had originally back. So from entries, the name from entries simply comes from, well, object.entries. All right. One last one, I promise, and then we're done. The last part is an update to a feature that we have in JavaScript, which is the try-catch block. Like this. Now, this try-catch block is something we're going to talk about a lot more when we get into the asynchronous JavaScript part of the course. But essentially, the try and catch block in JavaScript allow us to try a piece of code, and if there's any errors, to catch them. So, for example, if I do here, let's say 4 plus 5, and I run this piece of code, if I click run, I get 9. It's the exact same thing as us writing 4 plus 5. The only difference is that within this try block, we're telling JavaScript, hey, try this, and if there's any errors on line 3 here, then do something within the catch block. So I could, for example, say console.log, you messed up. And now, if I do, let's say, true or true plus hi, if I copy and paste this and run this code, I get true hi because of something we've seen before, that is type coercion. So it tried this. In JavaScript, that is valid JavaScript because it turns true into a string and combines it with hi. But if we, let's say, do a variable that we haven't seen before. So instead of true, let's say we have a Bob variable. If I run this, I get the catch block, which says you messed up. Because, well, this threw an error, and as soon as it throws an error, it catches. And here's the thing. You actually saw a new feature here in ES10. Because back in the day, before ES10, in order for this code to actually catch, you had to pass it an error object or parameter. So I could have called this whatever I want. So I had to do error like this so that I could perhaps say error. So if I copy this, refresh, and let's give Bob here so that we error out, I get you messed up, but then I also catch the error, which is a reference error. Bob is not defined. So before we had to pass it a parameter, otherwise this whole block of code, even if it was working properly, would actually error because we didn't pass it the parameter. With ES10, we have an update where you're not forced to use that parameter if you don't want to. Again, this is something we'll cover later on in the course when we talk about asynchronous JavaScript. Oh boy, that looked like a lot, but I mean, it wasn't that much, right? Nice and easy, nice and simple. I'll see you in the next video. Bye-bye. Welcome back. I wanted to talk to you a bit about JavaScript looping. You see, I actually left out a few other ways that we can loop in JavaScript. We've talked about our for loops, our while loops, our do while loops, and we also talked about for each. But there's actually two other ways that we can loop in JavaScript, and I'm going to show you how to do that in this video. Now, let's imagine we have a basket. And this basket is an array that, well, has our grocery list. Let's say we want to buy apples, we want to buy oranges, and we also want to buy grapes because grapes are nature's candy. They're delicious. Now, in order for us to loop through this basket, we know how to do this, right? We've learned about the for loops where we can just do let I equals 0, as long as I is less than the basket.length. We increment I 1 by 1. And let's just console.log basket at index of I. So that's the first type of loop that we saw. If we run this in the browser and hit enter, we see that we get apples, oranges, and grapes. All right, so that's the first way. We already know how to do that. We could also use the for each loop that came new in ES5. And there we can just say item. We'll use arrow functions, which we've learned about. And in this arrow function, I'll just console.log item. And that looks a lot cleaner than it was before. If I run this function now, I get the same thing. We're looping over items. And I'm not going to show you how to do the while loop and the do while loop because we've talked about it. But there's two other ways that we can loop through things in JavaScript. The first one is called the for of loop. And the other one is for in loop. I know the naming is a little bit confusing, but stick with me here. The first one, the for of loop, works in a way that's very similar to these two. It's almost as if we're combining these two together. And this is a new specification with ES6, so this is a new feature of JavaScript. The way it works is we start with a for loop, and we say item of basket. You see that the syntax caught it nicely for me. It's all blue. And in here, we simply say console.log item. Not too bad, right? we're using the for keyword here, but we're saying of, and we're just creating a variable. We can name this whatever we want, of basket, which is our array, and that's going to loop through it. So that if I copy and paste this here and hit enter, I get the exact same thing. And as we know, in programming, there's many ways of doing things. And these are just some of the ways that we can loop through this array. But I want to mention a key term here. What we're doing here is something called iterating over this array. And this wording, let's make this a little bit bigger. This wording is really confusing at first when you first hear it. But iterating simply means we're able to go one by one through an item, like let's say a basket, which is an array, go one by one and look at these items. And iterating is able to be done in JavaScript on what we call iterables. And these iterables is something that JavaScript provides us that says, hey, you can iterate over this thing. And what is this thing? Well, in JavaScript, you can iterate over arrays, and we've already seen that, and also strings. Instead of basket, if I just turn this into a string and I run the for of loop here, I see that I'm iterating over the string one by one. So both arrays and strings are iterable in JavaScript because we're able to iterate over individual items. And for of allows us to iterate over these iterables. I know the wording is really confusing, but in a lot of tutorials, books, and even workplace, you're going to hear this word and you want to know what it means. But let's talk about the next thing, the for in loop. The for in loop looks something like this. And actually, let's bring this back to the way it was. So not strings, it's the array. And I'm going to comment out or delete the looping that we're already familiar with, just so we have better spacing here. Now the for in loop works with objects. So let's create an object here, and we'll call this object detailed basket. And this detailed basket will be an object that contains apples, and actually the quantity of apples that we want. We want 5 apples. And we'll have oranges as well. And we can just maybe say have 10 oranges, lots of vitamin C, and then finally grapes, and they're delicious, so 1,000 grapes for everybody. Now, with this detailed basket now, I can use a for in loop. And I can say for item in, instead of this time, detailed basket. And I can console.log here the item. So that if I clear this, let's copy detailed basket. So that's our object. And we run the for in loop here. Notice what happens. I get apples, oranges, grapes. The for in loop allows us to loop over and see the object properties so that I can check what I need to go grocery shopping for: apples, oranges, and grapes. Now, here's the tricky part. And you'll hear this word mentioned a lot when you talk to your programming friends, and it can get really confusing. What we're doing here is not iterating, because iterating is something that we can do with arrays and strings. With an object in JavaScript, we're doing something called enumerating. I hope I spelled that right. Because properties of an object are what we call enumerable. And an object in JavaScript is enumerable if it allows us to see the properties. So apples, oranges, and grapes are enumerable. That is, we can use it in a for in loop to check them out. So enumerating is for objects. Now, enumerable and iterable. What happens if I switch these around? What if I have basket in here and the detailed basket in here? So we're using a for of loop with an object. What do you think will happen? Let's check it out. I'm going to copy and paste this into our console, hit run, and I get an error. Detailed basket is not iterable. And why is that? Well, we know that, right? I said that in JavaScript, we have arrays and strings that are iterable. And objects, in most of the cases, are not iterable. You see, for of loop doesn't work with objects because simply the JavaScript language needs to provide this property that is called iterable. And this property is only given by arrays and strings. And because for of loops only works with iterables, it's going to give us this error. But what about here? What if I do a for in loop on the basket, which is the array? If I copy and paste this and run this code, look at that. It's working. I get 0, 1, 2. And that is because underneath the hood, you can think of JavaScript arrays like objects, right? Because an array has an index of 0, 1, and 2. So we can think of basket as an object that has property 0 equal to apples. We have oranges that has index of 2 or index of 1. And then index of 2, we have grapes. So the for in loop is enumerating over the properties 0, 1, and 2, which lists it out for us. Let's make this a little smaller. But I wanted to make this video for you because a lot of people get confused between these two. And although you can go a long time without ever using for in loops, we can use something like object.keys that we've seen before, or values or entries, or we can use for each loops or for loops instead of for of. It's good to know these differences because if you see them in a code base, you want to understand what's happening. And also, if you ever hear somebody saying iterable or enumerable, you kind of have an idea of the difference now. To review, a for in loop loops over enumerable properties and enumerable property names of an object. The for of loop doesn't work with objects because they are not iterable. Now, there are small caveats and exceptions to these rules, but 99% of the time, you should consider this. You're using the for in loop for objects and for of loop for arrays and strings. I'll see you in the next one. Bye-bye. Hello! Welcome back to another latest feature of ECMAScript. They keep adding new things, but this is a really, really good one. So the latest one, ES 2020, has some really neat features, and I want to show you some of my favorite ones. You can see them right here. Now, in this video, I'm going to talk about these three over here, and then later on, we'll have separate lectures for ES 2020 Promise, All Settled, and also Global This. So those lectures will be titled ES 2020 with the respective names because these last two are better understood once we go over a few different new topics. So let's just focus on these three for now. Let's get started with Big Int. And Big Int is a really, really exciting new feature. It's a new type in JavaScript. What do I mean by that? Well, now in JavaScript, we have a type of big int. That's a new type, just like we have number, just like we have Boolean. We have different types in JavaScript. Well, let's test out that theory. Let's say we want to find out in our console over here, if I do type of, it gives me the type of something. So if I do type of 4, it's a number. If I do type of, let's say, true, it's a Boolean. But what if I do a type of a really, really large number? Well, that's still number. You see, big int stands for big integer. But Andre, you just told me that big int is a new type, and how come I don't see it here? Well, to get the big int type, let's clear this. You simply add the letter n after a number. So for example, I can do 1n. So if I do type of 1n, I get big int. But what does that really mean? Here's a fun little JavaScript trick, or a gotcha. JavaScript has something called max safe integer. And I'm going to link to some resources in this video that if you want to dive deep, you can read about. You see, JavaScript has something called a safe number. And it can go up to a certain safe integer, which is this number right here. But as soon as you go a little bit higher, the calculations start breaking down. So if we scroll all the way down here, we find out that the max safe integer has a value of this number. The reason behind that number is that JavaScript uses double precision floating point format numbers. Whew, that's a mouthful. Essentially, there's a limit to how much information we can store in memory. Well, kind of. And because of the way JavaScript is built, and this is actually common with other programming languages as well, there's only a certain number that it can hold. And big int solves this problem. So let's experiment here, because I always love when learning a new thing to experiment and make sure that we truly understand this. So I'm going to open up the console once again, and I'm going to try something. I'm going to say number.max safe integer, which gives me the number that we have here. So this is the max that we can do in JavaScript. So what if I do this number plus 1? Does that work? Yep, it works. What if I do this number plus 10? Does that work? No, it doesn't, does it? This number plus 10 shouldn't equal that. You see how we just broke something? What if I do this? What if I do this number right over here minus 1? Oh boy, it's messed up again. Again, that doesn't make sense, does it? So big int is used when we want to use a number that's larger than this max safe integer, and we want to do some calculations with it. So instead, if I do this n minus 1, n, well, I get an operation between these two big ints, and you see here that it's working. It's minus 1. Again, if we try and do our max integer over here, and we do plus 10, we see that this doesn't work. As soon as we add n to both of these, there you go, our operations work. So we're able to use big int as a new type. Remember, if I clear this and I do, let's say 1n plus 2n, well, I get a big int, a type of big int that we can do calculations on, especially for big numbers. But as you can see, we can also just do regular numbers as well, as long as we enter n. Pretty cool. Most of the time, you're not going to use this feature, but it's nice to know, and it's interesting to know that there are these limitations with JavaScript, and big int solves them. All right, let's learn something even more fun. Next one is nullish coalescing operator. Actually, you know what? Let's start with this one first, the optional chaining operator, and then we'll go into the nullish coalescing operator. So let's pretend that we're playing Pokemon. Hopefully everybody knows Pokemon, greatest game as I was growing up. I think it's still popular though. All right, getting sidetracked. Let's focus here. Let's imagine that we have a user and we'll say Will is a Pokemon trainer. And this user has, let's say, the Pokemon Pikachu, and Pikachu is, let's say, a species that is a mouse Pokemon. It's got a height of 0.4 and let's say a weight of 6 pounds. So height 0.4 centimeters and 6 kilograms weight. Now let's imagine that we want to find out the weight of Pikachu and hold it in a variable. What we would usually do is say let weight, and we'll say within here we'll do will Pokemon dot Pikachu dot weight. So if we console, let's make this a little bit bigger, and we'll do weight here. Let's copy this. Oh, and we forgot a comma over here, so let's try that again. Let's copy this. And we get a weight of 6. Just to be clear here, I can just say weight like that. All right, so this is working. But here's a problem. Let's say we have a different user. And this time, the new user, his name is Andre. And Andre doesn't have Pikachu. Instead, Andre has Raichu. Again, a different kind of Pokemon. It's still a mouse Pokemon, but some of the details are different. Say the height is 0.8 and the weight is 30 kilograms. So now, if I wanted to find out the weight, let's say Raichu, and I run this command, so let's say now, instead of Raichu, let's just do weight 2 here. And this time, from Andre's Pokemon, we'll do this. If I run this, I get an error. Cannot read property weight of undefined. And why is that? Well, because Andre doesn't have Pikachu, right? We don't have that Pokemon. Instead, we have Raichu. So when we try to grab the Pikachu from the Andre Pokemon object, it's going to say error. So in the past, the way we would solve this is we would do an if statement, right? So let me just remove will from now. And in here, I'm also going to minimize this. So it's just Andre Pokemon object. And in here, instead of doing what we've done here, we would do if and say Andre Pokemon dot Pikachu, and if Andre Pokemon dot Pikachu dot weight, let's make this a little bit smaller so we can see. Then we want to create weight 2 variable. Otherwise, let weight 2 equals undefined. So by doing this, we won't get that error. So we can check to see if Andre has Pikachu. So if I copy this over, let me just remove this from now. If I copy this over, hit enter, I get no errors. And if I add console logs in here, run this again, you see that I get undefined because, well, it will realize that Andre Pokemon object doesn't contain Pikachu. So this is actually pretty annoying to do. And you'll see often code bases have something like this and then do Andre Pokemon, and they keep checking. Does this exist? Does this object exist? Does this object exist? So on and so forth. So the cool thing about optional chaining is that, well, it avoids this complication. So I can change this to say let weight 3 equal Andre Pokemon. I can say, is there an object? And then do Pikachu. Is there an object or a property of Andre Pokemon that is Pikachu? And then do dot weight. So by doing this, check this out. If I do console log weight and I copy this, I get the same thing. I get undefined because it checks all of these, and eventually, because Pikachu cannot be found in this object, it's going to assign undefined to weight 3 without throwing any errors. But if I did have Pikachu and I try this again, you'll see that I get 30. So everything is working. So instead of having those long if statements, I can just check for properties with this question mark. Very, very cool. Now, this video is getting long, so let's take a pause, and then we're going to visit nullish coalescing in the next video. Bye-bye. Welcome back. Let's talk about nullish coalescing operator, and it's this double question mark. So remember, we learned about the big int, and we also learned about the optional chaining with the question mark and the period, just like this. So what's this double question mark? And this double question mark can often be used instead of what we've seen before, the OR operator. So let me show you what I mean. Let's imagine that we have a new property here, and we'll call it power. And power for Pikachu is lightning. Now, if I wanted to get the power of my Pokemon, then I can simply do this and grab the power or the property power lightning. But let's say we weren't sure that we have this property for the Pokemon. So we can't really do question mark period because, well, that doesn't really make sense. Remember, the optional chaining operator works on objects and checking their properties, but power is the end of the chain. We can't really do anything. So most of the time what we would do is do an OR operator. So if, let's say, Pikachu doesn't have a power, we can just say no power. So let's imagine here that we have an empty string, or maybe not even the property. And if I copy this over and run this, I get no power. That makes sense, right? But what if we had power in here, but it's an empty string? What would happen then? Well, if I run this again, I get no power again. And that is because this OR operator works by checking if this is truthy. If it's not truthy, then it resorts to no power. That's how JavaScript works. So this empty string evaluates as false, and I get no power. What if the power was false? once again, this will result to false and you'll get no power. But what if we wanted this to be an empty string instead of no power? We want to check if this is null or undefined. Only then do we want to give no power. Otherwise, maybe this Pikachu just is still evolving and doesn't have any power, but we don't necessarily want to say no power. Well, in that case, we can do the nullish coalescing. And this, instead of the OR operator, doesn't check if a value is falsy. Instead, it checks if it's null or undefined. So things like 0, for example, if we do that, well, let's find out. If I copy this, I get power of 0. If this was an OR, in that case, the result would be different. The result would be no power, even though we actually have a value. So again, nullish coalescing is really, really useful for those occasions that you might use the OR operator. Pretty cool. All right, I think that's enough. There's a few more to cover with ES 2020, but again, we're gonna encounter those throughout the rest of the sections because they require a bit of other knowledge that we're gonna accumulate. So let's take a break and I'll see you in the next one. Welcome back, everyone. Now I have some good news and some bad news. Let's start off with the bad news. The bad news is that in ES 2021, which is the latest version of JavaScript, the changes to the language, there aren't that many. There aren't that many new exciting features. You can Google ES 2021 features, and a lot of them are obscure features that most likely you won't encounter in your day-to-day. Now, the good news is that, well, you don't have to learn a whole lot of new features. As a matter of fact, there's one important one that I'm going to show you in this video, but that's it. Nice and easy. Isn't that nice? Nice quick video. So let's see how quickly we can do this. Let's say I have a string here. I'll call it str for string. And oh, I like this one. ZTM is the best of the best. So let's make that into a string. So our string says ZTM is the best of the best. I'm a little bit biased here, but let's go along with it. So with a new feature in ES 2021, we have something that we can use on all strings. It's a method that we can use on all strings. So if I do the string dot replace, oh, look at that, it already pops up. Replace all. What it does, it allows me to replace something inside the string. So let's say I want to change best in the string. So let's say best, and I want to change that to worst. So if I replace that string like that, I get ZTM is the worst of the worst. Well, that's a little bit rude, but that's what we got with replace all. If I do string here, ZTM is the best of the best. And that's because we didn't really assign this to anything. The original string remains, but the new string, so I could have done something like this. I could have assigned it. And I could have said const b equals this, and now b is ZTM is the worst of the worst. I definitely don't like this one. I like the other one better. Now, that's it. ES 2021, this is all we really got. I mean, it's pretty nice to have. As a fun little side fact, JavaScript actually used to have something called replace already. So we could have done const c string.replace. That used to be part of all JavaScript. So it's not anything new. But with this one, the problem with this one is it only changed the first instance of the word. So you can see here, ZTM is the worst of the best. A little bit better, but definitely not best of the best. So anyway, final little fact, final little tidbit, ES 2021, we have this replace all. Okay, I managed to make this video way too long for what this really is. Pretty easy, right? All right, go grab a coffee and I'll see you in the next one. Bye-bye. Welcome back. Let's talk about ES 2022. And there's a couple of fun features that were introduced to JavaScript for this version. And you're gonna love this one. Ready? Let's open up our console. Now, this new feature is the @ method. And it's gonna be very useful for you for arrays or strings in JavaScript. Let me show you. Let's imagine that we had an array. So let's declare an array that equals, let's see, what should we have here? Let's do 100, 200, 400, 5,000. That's 50,000. And let's say 10. All right. We have a nice, beautiful array of numbers. Now, if I asked you to get the array that is not last, but second last, what would you do? Well, in the past, what you would have done array, and then you would have said array.length minus 2 to go backwards. So 2 places. So what's the array length? The array length was 1, 2, 3, 4, 5. So 5 minus 2, that's 3. So you go 0, 1, 2, 3. So there it is, 50,000. But with the new @ in ES 2022, instead of doing all this calculation, it's a lot prettier. I can say array @ and this is the cool part, minus 2. So if I do minus 2, that means I go, well, exactly what we've done here. I can also say, what's the array at 0? It's 100. So again, if we go over here, that's array index of 0. Array index of 1 is 200. 3 is 50,000. 4 is 10. And as default, minus 1 is the last place. So whatever the array is, minus 1 will be the end of the array, the last item in the array. So naturally, minus 2 is 50,000 because it's, well, one place away from minus 1. It can be a little confusing, but you can just play around with it. And I don't know, that's pretty cool. This is actually a feature that's common in languages like Python. So now, well, JavaScript has it too. Very, very cool. So ES 2022, is that it? Not really. There's actually a really nice feature that was brought in ES 2022, and it's called top level await. But for us to learn about that, we still need to learn about asynchronous JavaScript, which we're going to do later on in the course. So we're going to come back to ES 2022 in those lectures and in the Node lectures. I know, cliffhanger, but I promise you it's going to be exciting. I'll see you in the next one. Bye-bye. Welcome back. I wanted to talk to you quickly about a very important topic for a developer, and that is debugging. Debugging is the act of looking over code, understanding what it's doing, and figuring out why it's not acting as expected, or maybe it's not even running. Maybe you're getting errors, or maybe something that the user does on a website is triggering a weird behavior. That's what debugging is, figuring out why the program isn't acting the way it is. And when you work as a developer, a lot of your time is spent debugging. So it's a very important topic, and I want to talk about some of the strategies that we can use for debugging. I have over here a pretty complex function. And frankly, unless you've had a lot of experience with JavaScript, this is a pretty hard function to understand. Let's say that you get into work and somebody says, hey, I don't know what's going on with this function. Can you look into it? And you have to figure out what it does and whether it's working fine or not. So I'm going to take you through the steps that I would use to debug this code. Maybe it's working fine, maybe it's not, but I want to understand what this piece of code does. So the first thing I would do is just read it. I say, okay, we're assigning a variable, and it looks like we have an array. It is a nested array, so there's an array inside of an array. And it looks like this code wants to do something called flattened. Okay, we know that reduce, from what we've learned before, A is the accumulator. I can change the name so it makes more sense to me. Okay, accumulator, perfect. And B is, well, what is B? B is this, right? Because we're iterating, looping over the first array, so it gives us 3 arrays. So I can just say array here. Okay. Now, I also see that within this reduce, I have the accumulator, I have the array, and I want the accumulator to start off with an empty array. That makes sense so far. So the accumulator is going to be an empty array when we start off. And what we're going to do is we're going to do empty array dot concat. And if you remember, concat attaches the contents of an array into whatever is being concated. One thing I can do is open up this function so that now, instead of just having one line, I can say console.log array, and we'll find out what array is. And we'll also say console.log accumulator. We'll say accumulator. All right, so we have the console opened, and we also want to make sure that we're returning this because we removed it from a single line, which already implicitly means return, to making it 2 lines. Okay, so let's just refresh and add this function and see if we can get some console logs to figure out what it's doing. There's going to be 3 loopings that we see. And in the first looping, it looks like it says the array is 0 and 1, and the accumulator is the empty array. Okay, that makes sense. And then we see the second loop around, the 2 and 3 array, which is here, gets looped around. And the accumulator now has 0 and 1. So it looks like after the first loop through, I've added the 0 and 1 of the array into the empty array, which is the accumulator. Okay, and then the last pass through, which is 4 and 5, I now attach the array of 4 and 5 into the accumulator, which has 0, 1, 2, 3. So it looks like what we're doing is we're grabbing each array and we're adding it into the accumulator. And because it looks something like this, so this is what it would look like in the first path through, we're just using the concat function to join the arrays, 0 and 1, so that we are flattening the array. So that means instead of having an array inside of an array, we can just completely flatten everything. That means that with flattened, if I look at what it does, well, it just flattens the array, 0, 1, 2, 3, 4, 5. Awesome. There's one other trick I want to show you, and that is instead of using console log, you can use something called debugger. And you notice that the color turned red, which means, yep, it's a JavaScript keyword. And what this allows you to do, well, let's see what happens when I run this function. I'm going to refresh here, and I'm going to run it. Whoa, what just happened? When the JavaScript engine in the browser runs into the word debugger, it stops. It's a word that tells whatever is reading this file to, hey, stop, whatever you're doing, just freeze. And it opens up the window for us exactly where it stopped. So let me make this full screen and show you. It stops in the middle of its execution. So we see that here, accumulator is an empty array because, well, we started it. And the array is 0 and 1. Now I have a couple options. I can hit play, which resumes the entire thing, or I can hit step over. And let's see what happens with step over. It goes to the next line. And if I click again, it goes to the next line. And now I see that the accumulator is 0 and 1, and the array is now 2 and 3. So I know that in the next line, the accumulator well, I changed this to an array by mistake, but this will be the accumulator, will be 0 and 1 dot concat 2 and 3. And I can keep stepping through this and see how the parameters change. And literally go through the entire function. Let's close that down. If I bring this back to the way it was, which is the accumulator, make this full screen. All right, so array is 0, 1, accumulator is an empty array. I'm going to step through. That changed. Accumulator is now 0, 1, array 2, 3. And I keep stepping through and I notice exactly what's happening in the code. And when it's done executing, it returns. And look at that. We have our console back. Isn't that cool? Debugger allows us to literally go into the function and see what happens step by step. As I return this to the way it was, I want you to take this with you and understand that although when you first see something like this, it's overwhelming, with enough time and using console and debugger, you're able to understand what a function does. And if it's doing something that you don't expect it to or is doing something wrong, you can use these techniques to fix it. It's a very useful skill that you're going to use a lot of. So good luck. Have fun out there. Bye-bye. How does JavaScript actually work? Imagine getting this question during an interview. Or how about this? Explain the difference between asynchronous and synchronous in JavaScript. Or maybe they ask you to explain the statement, JavaScript is a single-threaded language that can be non-blocking. Oh boy. In this video, we're going to help you answer those questions. This is a video you may need to visit a few times as you progress to really get it. So don't feel discouraged if you don't feel 100% confident. Just keep watching it and you'll get it. Now, we don't need to know how JavaScript works internally to write a program, but it is important to learn. I see a lot of people who have been developers for years and not know this. It's like being a pilot and not knowing how an airplane can fly. Okay, that's a little bit dramatic there, but you get my point. So let's start. First, what is a program? Well, a program has to do some simple things. It has to allocate memory, otherwise we wouldn't be able to have variables or even have a file on our computer. It also has to parse and execute scripts, which means read and run commands. Okay, now we also know that from our previous discussion, there's the JavaScript engine that each browser implements. In Chrome, it's the V8. And the V8 engine reads the JavaScript that we write and changes into machine executable instructions for the browser. Now, the engine consists of two parts, a memory heap and a call stack. Now, the memory heap, this is where the memory allocation happens. And don't worry, we're going to talk about this. And then the call stack, this is where your code is read and executed. It tells you where you are in the program. So let's simplify this and show you what I mean. I have Sublime Text over here. And for us to allocate memory in the memory heap, well, it's as simple as doing const a equals to 1. We've just allocated memory. Now, when we assign this, the JavaScript engine is going to remember that, oh yeah, a has a value of 1. We've just used up the memory heap. And I can keep going on and on like this, right? I can keep copying and pasting and changing these variables to B and C, and I can change the values to 100, and maybe here will be 10. Cool. Now, what's an issue that we see with this? There's something called a memory leak that you're going to hear as you become a developer. And what we've done here is we've created all these variables, these global variables that are in the memory heap. But you see this box, right? And with all memory, we have a limited amount that we can actually have. So by increasing the number of variables that we have, imagine if I had just this page full of variables, and instead of just numbers, they're like very, very big arrays. Well, memory leaks happen when you have unused memory, such as, let's say we're not using the variable a, but it's still there. Well, by having unused memory just laying around, it fills up this memory heap. And that's why you might hear why global variables are bad. Global variables are bad because if we don't forget to clean up after ourselves, we fill up this memory heap, and eventually the browser will not be able to work. All right, so that's memory. Let's talk about the call stack. What is that? Well, again, with a call stack, we can have something like this. Console log, we'll go 1, console log 2, and then finally console log 3. If I run this code in my browser terminal, well, I get 1, 2, 3. So the call stack, if you remember, that's what reads and executes our scripts. So what the call stack does, it reads the first line, console.log, it gets put in this call stack. So the JavaScript engine says, ooh, console.log has been added. Let's pop it onto this call stack. And then it runs it and creates one. Then it says, okay, I'm removing the first console log because I just finished running it. I'm going to place the second console log into my call stack, adds it on here, and says, yep, execute 2. And then it removes that, it pops it, and then gets console log 3, and logs console log 3, and then finally removes it. But let's have a bit more of a complex example here to demonstrate this point. Imagine I have something like this. I have a function, const1, and inside this function we have another function, const2. And for now it's not really going to do much. It's going to console.log 4. And then in here, we'll just say we run the to function. So if I copy and paste this and place it into our console, and I run 1, I get 4. And ignore this error here, it just related to my app in the browser. But you see that we get 4. So what happened here according to the call stack? Well, if we have the call stack here, we first ran the one function. So on top of the call stack, the one function gets run. And as we enter into this call stack, we see that we run another function, 2. So 2 goes on top of the call stack. And now we run the to function, which is console.log. So we have console.log 4 that's run inside of the to function. So now that we've read this, the call stack is going to say, okay, there's nothing else inside of this. I'm going to run console.log 4. So it's going to print out number 4 here. It's going to remove that from the call stack and then remove the 2 and then remove the 1 because it's just been called. And the call stack is now empty. All right, awesome. Now let's revisit the statement from the beginning of the video. JavaScript is a single-threaded language that can be non-blocking. Single-threaded means that it has only one call stack and one call stack only. It can only do one thing at a time. And as you saw, call stack is first in, last out. So whatever's at the top of the call stack gets run first, then below that, below that, below that, until the call stack is empty. Now, other languages can have multiple call stacks, and these are called multi-threaded. You can also see how that might be beneficial to have multiple call stacks so that we don't keep waiting around for stuff. Why was JavaScript designed to be single-threaded? Well, running code on a single thread can be quite easy since you don't have to deal with complicated scenarios that arise in multi-threaded environment. You just have one thing to worry about. And when I say issues with multi-threaded environment, you can have such thing as deadlocks. Now, guess what? You just learned what synchronous programming means. Synchronous programming simply means line 1 gets executed, then line 2 gets executed, and then line 3 gets executed. The latter can start before the first finishes. So this console log 2 doesn't start until console log finishes. And console log 3 doesn't start until these above 2 finish because, well, we've looked at the call stack because of the call stack. Now, you may have heard of the site Stack Overflow. If you're a developer, you use it on a daily. And have you ever wondered what Stack Overflow means? Well, Stack Overflow is this, when a stack is overflowing. Kind of like we talked about memory leaks and how the memory heap of a JavaScript engine can overflow. Well, with Stack Overflow, this happens when the call stack just gets bigger and bigger and bigger until it just doesn't have enough space anymore. How can we do that? Can we recreate a Stack Overflow? Yeah, I can show you quickly that to create a Stack Overflow, all you have to do is function foo, like we have in here, and this function will just have foo. And we're just going to run our foo function. All right, that looks confusing. What is happening here? This is something called recursion. And recursion means a function that calls itself. So if you look at what this function does, we run foo and foo gets executed. What foo does is, well, we run foo again. So it just keeps looping over and over and over, having a recursion, but there's no end in sight, right? We keep adding foo to the call stack. We keep adding it over and 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 over. And we have a Stack Overflow. So if you want to have fun, go into your browser, go into your console, and run something like this and see what happens. You're going to get a Stack Overflow. All right, so hopefully this now makes sense. The JavaScript engine, which is the V8 engine in Chrome, has a memory heap and a call stack. Now, JavaScript is single-threaded. Only one statement is executed at a time. But there is a problem now, isn't it? What if line 2 was a big task we needed to do? Maybe loop through an array that had millions of items. What would happen there? Well, we would have this console log execute, then the second line that is a massive job will just work there. And console log 3 will take a really long time to get logged. And in our small example, that doesn't mean much, but if you had this on a website, well, the user wouldn't be able to do anything. The website would pretty much freeze until that task is done and the user just waits there. That's not very good, is it? Well, with synchronous task, if we have one function that takes up a lot of time, it's going to hold up the line. Imagine a buffet restaurant, right? If all the people want to eat, but Bobby says, hold on guys, I have to keep eating and putting bacon on my plate, well, everybody has to wait in line. So it sounds like we need something non-blocking. Remember our first statement that we made in this video. JavaScript is a single-threaded language that can be non-blocking. Ideally, we don't wait around for things that take time. So how do we do this? Well, asynchronous to the rescue. Think of asynchronous like a behavior. Synchronous execution is great because it's predictable. We know what happens first, then what happens next, what happens third. But it can get slow. So when we have to do things like image processing or making requests over the network like API calls, and don't worry, we're going to talk about this in future videos, we need something more than just synchronous tasks. All right, so you're thinking to yourself, Andre, how do we do asynchronous programming then? Well, let me remove some of this clutter. We can do asynchronous programming by doing something like this. Set timeout, which we're going to talk about, is a function that comes within our browsers, and it allows us to create a timeout. And we can just give it the first parameter is the function that we want to run, and then the second parameter is how many seconds we want to wait. So let's say I want to wait 2 seconds, so 2000 milliseconds. If I do this now, let's run it into the console and see what happens. Whoa, what just happened? We have console log 1, then console log 3, and then console log 2 seconds later. It looks like we just skipped this whole step and then put this at the very end. Well, you've just witnessed asynchronous programming. In order to understand this and what just happened, I need to take you to the next part. And that is, in order for JavaScript as we know it to run, for the JavaScript engine with memory heap and call stack to run, we need more than just the JavaScript engine. We need what we call a JavaScript runtime environment. And JavaScript runtime environment is, again, part of the browser. It's included in the browsers. They have extra things. On top of the engine, they have something called web APIs, callback queue, and an event loop. And as you can see here, set timeout is part of the web API. It's not technically part of JavaScript, is it? It's what the browsers give us to use so we can do asynchronous programming. Okay, so looking at this diagram, let's see if we can figure out what our code was doing. We can create here our own call stack. We'll have web API, and then we'll have a callback queue and an event loop, just like we have in our JavaScript runtime environment. So what's happening here? Well, first we have console log that goes into the call stack, and that gets run. So we log console log to the browser. We then get set timeout into our call stack. Because we finished this first task, we're going to the second one. And with set timeout, what's going to happen is, well, the call stack is going to say, okay, I have set timeout. And because set timeout is not part of JavaScript, but part of the web API, it has this special characteristic. What's going to happen is it triggers the web API and says, hey, set timeout has just been called. And because we notified a web API, we can pop it out of the call stack. Now, the web API starts a timer here, a timer of 2 seconds. It's going to know that in 2 seconds, you have to do something. And because the call stack is empty, the JavaScript engine now goes to console log 3 and executes this. So that makes sense, right? Now we've done 1 and 3, but we still have set timeout 2 seconds in the web API. Now, after 2 seconds, when our time limit is up, the web API is going to say, okay, set timeout should be run. Let's see what's inside of it. Well, we have console log 2. So what's going to happen is it's going to say, hey, set timeout is done. We have a callback. And this callback of set timeout, we added to the callback queue, saying that, hey, we have to run something, we're ready to run it. Now, the last part, the event loop. The event loop over here checks and says, hey, is the call stack empty? And it keeps checking all the time if the stack is empty. And if the call stack is empty and there's nothing running right now on the JavaScript engine, it's going to say, hey, do we have any callbacks? It's going to check the callback queue and say, is anything in there? Because the call stack is empty, we can throw something in there and make it do some work. In our case, we say, oh yeah, I do. Let me put this into the call stack. So now we move the callback into the call stack. And then the callback, we run it. And by running it, we see that we have console log 2. So it's going to say console.log 2. It's going to run this function, and once it's done, it's going to pop it out of the call stack. And again, we're done with the callback, so we remove it. And there you go. We're done. Everything is empty, and we've just run this 1, 3. It's going to go through the entire web API, callback queue, event loop, and then it's going to run console log 2. Whew, that was a lot of information. So you might need to watch that a few times, but hopefully that makes sense to you of why we notice this behavior. And I want to challenge your understanding here. Knowing what you know and what I just taught you, what happens if I change this to 0? That means 0 seconds. I'm going to give you a second to think about what will happen, and then we're going to try this out. I'm going to clear the console, copy and paste this, and run it. Whoa. 1, 3, and 2. Did you guess right? Now, think about why that happened. Even though this is 0 seconds, it still went through the process. It still got entered into the web APIs, and then the callback queue, and then the event loop. And by the time that was happening, the call stack had already moved on to the console log 3. And only after console log 3 was done and the call stack was empty, the event loop said, oh yeah, we can call console log 2. Hopefully that makes sense for you. And if you're able to understand that, you'll actually have a lot of people that hire for JavaScript roles ask questions like this on an interview, and you have to explain why that is. So I hope that made sense to you and you can use that to your advantage at the next interview. So let's recap. If you wanted to load your latest tweets onto a web page and you do this synchronously, then visitors to your site won't be able to do anything until those tweets are loaded. This could cause a long delay before they even get to see the content of your site. They may not be able to click anywhere and the page will feel like it's frozen. Not a very good user experience, is it? Another way to think about this is calling your teacher with a question. Synchronous way is you call the teacher, you wait on the phone until the teacher answers the phone and ask him the question. And hopefully you get an answer. So you let the phone ring until he picks up, but you're not doing anything else in the meantime. Asynchronous means you send a text to a teacher with a question. And then when the teacher, he or she has the time, will respond to you and call you with the answer. So you can do other stuff in between. So JavaScript is asynchronous when you can leave it a message. And a callback tells you, hey, Mr. Teacher has a message for you when you're not too busy. And that's why we call it a callback function and a callback queue. We're calling back to let them know that, hey, there's some stuff waiting for you. Now, we see over here that we have DOM, AJAX, and timeout. And there's a few other things. But you also see in the callback queue that we have onClick, onload, onDone. Do you remember the event listeners? Well, with an event listener, we had something like an element, and we added event listener. And in this event listener, we could say listen for a click, and it will have a function that perhaps just console.log click. Well, similar to an asynchronous way of programming, we've created this click function, and now we're just listening to it. And every time a click happens on the web page, so on the DOM, well, we run the callback function, which console logs click. All right, so to finish things off, when is asynchronous happening? It happens a lot when you try and talk between machines,
like speaking to a database, making network requests, image processing, reading files. And don't worry, we'll go through this in future videos. But to recap what we just learned, JavaScript is a single-threaded language that can be non-blocking. It has one call stack, and it does one thing at a time. In order to not block the single thread, it can be asynchronous with callback functions. And these callback functions gets run in the background through the callback queue and then the event loop to bring it back into the call stack. So, next time you get asked, what is the difference between asynchronous or a synchronous program? Or how does JavaScript work? You should have a little bit more confidence to answer that question. And I hope that this was helpful. I'll see you in the next video. Bye-bye.
When I first started learning JavaScript, modules and that topic was the most confusing thing ever for me. I had a really tough time getting a grasp of the concept. It took me a year to actually get it. But I've created a mental image in my head to understand it better. And as we do in this course, we first start with the problem, then go to the solution that we have now to see where we were and where we are now. This is the mental model that I've created, and I call it climbing the mountain of modules. Let me explain. When we first started writing JavaScript and creating websites with JavaScript, well, we had an HTML file, and the very first time people were using JavaScript, you used a script tag and what we called an inline script. An inline script is exactly that. We just inline all of our JavaScript within the HTML file. Now, there's problems that I see with this. Imagine this getting massive. A massive JavaScript file, hundreds and thousands of lines of code. One is the lack of code reusability. And you'll hear this term a lot. If we need to add another page, maybe an about.html page, well, we have to copy this code and put it into the other HTML file. And the second was the pollution of the global namespace. And that is, once I use up A as a variable, in this case in the window object, well, I can never use A again. And maybe hundreds of lines down, by mistake, I assign a variable A and I erase my A function. Well, that's a huge problem. And that's a big problem in general. You want to make sure that you don't pollute the global namespace, that is the window object, with all these names, because then you'll have collisions. You have different team members working on different pieces of the code, and all of a sudden, we both come up with the same name. It's a big problem. The next attempt was script tags, and this is something we've been familiar with. Instead of having inline, we had script tags. And when we played around with Bootstrap and jQuery, this is what we did. We had our jQuery file loaded first, then our JavaScript file loaded second. And as you can see, we can have one script file, then the second one, then the third one, then the fourth one. This way, you have everything outside of the HTML. Solves the problem, right? Well, the problem with script tags, as far as I can see, are three things. If we need to add another page, like an about page, well, we still have to copy and paste this script tags. And again, we don't really want to do that. The second one is the lack of dependency resolution. And that is, you're responsible to make sure that the scripts are added in proper order. For example, if this script accesses a function from the number4.js file, well, it's going to fail because the number4.js file hasn't loaded yet. So that's lack of dependency resolution. And finally, the third, this doesn't really solve the global namespace problem, right? It's polluting the global namespace. All the functions and variables that are declared in each of these files will be on the window object. Okay, so what about the third attempt? The IIFE. That stands for Immediately Invoked Function Execution. I know that's a mouthful, but it looks something like this. An IFE it actually wraps a function in brackets so that JavaScript reads this and says, oh, I have to evaluate this and execute this. And then these brackets at the end says run the function. So after you evaluate this, run this function. And it was a confusing way to make sure of one thing, and that is by using this method, you don't pollute the global namespace. Now, if in the first file you have variable myapp, that'll be on the window object, but everything else that's inside a function, as we know, creates a new scope. So all the files, because they were wrapped in this IFE, had their own scope, and if you wanted to add to myapp, you just added everything as a property or a method. So awesome, that reduced our global namespace to just one. I mean, it's not 0, but 1. That's a lot better, right? But there is still one issue with this. The order of the files are still important. And I've worked on apps before where we're using so many scripts that this was close to 100 script tags. And every time you added a file, you had to make sure that you added it in the right place because that file might be dependent on another file loading before it. So as we know, that's lack of dependency resolution. And frankly, this doesn't look very pretty. So then we had Browserify, this nice looking logo. Now, what did Browserify do? It actually used something called CommonJS. So I'm going to comment the IFE out and show you what Browserify did. It used CommonJS, which allowed us to use a certain syntax, and it looks something like this. If I wanted to have on my first JavaScript file a function add, I can say module.exports, and now in the second JavaScript file, I could require the add. Let's fix the strings here. And now I can add function into my JavaScript 2 file. Now, Browserify used this CommonJS syntax, but it's actually a module bundler. And what does that mean? Well, it runs before you put the website online. What that means is it reads through all the JavaScript files, reads through all the syntax, and it bundles everything into a single file. Once you run all the files through Browserify, and again, is just a simple tool that allowed us to just dump all our script files, all of these, into Browserify. And as long as we use the CommonJS syntax like this, it will know what to do and automatically create one file. It will usually be called something like bundle.js. So all our scripts will just be on one massive file. And yeah, that might be bad when we're actually developing, but when it's out on the internet in real world, we don't really care how it looks because we're just doing this to send it somewhere to a server so that the web app can be viewed by users. This is not what it's actually going to look when developers are working on it. When developers are working on it, we just have our own separate files. We just run it through Browserify right before we deploy, that is, put it out to the public. All right, so that was pretty cool. And we're getting closer to the top of the mountain here. Now, all of these problems here, it was all because JavaScript didn't have what we call a module system built into the language. And think of modules as building blocks, as different pieces of code. So instead of having one giant thing, you have modules. Each piece is really, really good at doing one thing. And because JavaScript didn't have this module system, it's the reason we have so many different ways of importing and exporting modules. And there's actually quite a few more that I didn't show because, well, frankly, it'll just be too much. But things have recently changed. With the introduction of ES6, we can now do something a lot nicer. And it looks something like this. With ES6, we have two new things, export and import. For example, in JavaScript 1 file, I can have a function, and you can see that I'm using arrow functions here, an add function, and I simply export it. Or I can even do export default. In the second file, if I wanted to use the add function, all I say is import, and then we see here the destructuring. You might remember this from the ES5, ES6 video. And we're simply just grabbing add. Or if the export was default, which means with this, you can export multiple functions in the same file, versus here, you can only export one thing. So the file only exports one thing. Well, in that case, we don't need the little brackets. We can just do add from add file. Very cool. So that's nice. That reads pretty nicely. We just put the imports at the top. So each file, we know exactly what each file needs, and everything is clean. Everything works, and we don't have to worry about any of this stuff, right? Well, yeah, kind of. As you know by now, and I feel like a broken record, browsers aren't supporting everything yet because it's a new feature. Again, we're still waiting on browsers to implement them. But this is what this blue thing is for. It's called the Webpack. And Webpack, just like Browserify, is a module bundler. That is, it bundles modules, which is bundles JavaScript files. And just like Browserify, it traverses the dependency tree, which is these export and import tags, into a single file, or it can even have multiple files based on your needs. And with Webpack, we can actually use ES6 in all browsers. Isn't that awesome? This is where we are now. We've climbed the mountain of modules, and we have a really, really good system right now in JavaScript. It was really hard getting there, but we're in a good place right now. So this is what we're going to be using, and this is what the industry is using. Get used to the syntax. I'll leave a link at the end of this video so you can check out more. But when we get to React, we're going to be using this a lot. And it's going to be a ton of fun. It's going to make things really nice and clean for us. One thing I wanted to show you. You might think, hey, this Webpack thing seems like it's kind of hard. Like, how does it do it? It's very simple. It just has a config file, just like this. As you can see, we just have an output that is bundle.js. And we don't need to worry too much about it. Usually when somebody's starting a project, it's one person on the team that configures this file and everything is done. The rest, you just build on top of. It's very, very simple to get started. I don't think it's super important for us to tackle right now. But again, a very, very useful tool. And it creates a nice bundle.js file. So now all our HTMLs look nice and simple. And you know what? That's it. We've covered some of the most important topics in JavaScript and some really, really hard topics. And I know your brain is hurting from all this information, but you've done it. We've finished this section and previous sections, and now we can actually build amazing apps with the tools that we have. Can't wait to show you how all these pieces come together to build something amazing. I'll see you in the next video. Bye-bye. Hey everybody, I want to take a quick break here. Go grab a coffee, grab a tea, just take a break from all the learning that you just did. And I want to talk to you quickly about imposter syndrome. It's this idea that you're not good enough, that things are too complicated for you to ever achieve what you want to achieve. You look at other people, at other industry experts, and you say, I will never get there. But it's just a symptom of learning. This idea of you not being good enough simply means that, well, you're just not there yet. Things take time. If you want to learn a valuable skill, Well, it's hard work. That's why it's valuable. Remember how you felt on the first day of going to school, first day on a job. It's the same experience. But over time, with repetition, with practice, you get comfortable, you get experience, and you slowly start to lose that imposter syndrome. Now, this idea of an imposter syndrome is great. It means you're doing something worthwhile. So don't use it as a negative. Use it as an encouragement that you're doing something good, that you're learning and you're stretching your limits. So with this break, I want to propose that we do a quick exercise. I want you to stop the lectures. Again, grab a coffee, grab a tea, and head on over to our Discord. Now, in our Discord server, if you've used it up until now, that's great. If you haven't, head on over to this server, and I want you to do something that I think it's super important to learning. And that is using what you've learned up until now to actually teach someone or help someone. So you can go all the way to, let's say, the coding and courses section and pick a topic that you want to help somebody in. So let's say you go to the Python channel. And in here, you'll have other students that are asking Python related questions. Now you can scroll through here and see if you're able to help someone. Even though you may not have the experience or the knowledge yet, this idea of practicing and explaining what you've just learned to other people, even if you're not 100% certain, actually is beneficial to your learning. Because if you're never teaching, if you're never explaining and vocalizing and showing what you've learned, you'll always be a beginner. This idea of teaching what you learn is a very important concept. So moving forward, as you go through the lectures, anytime you feel like taking a break, hop on over to Discord and help somebody. Our motto here is that we're always kind. We don't judge anybody. We're all just beginners here. We're all learning. So don't be afraid to answer things, because you got to remember, nobody's perfect except for Yoda. Yoda is pretty perfect. All right, I'll see you in the next one. Bye-bye. A big part of being a developer is being able to use the terminal or the command line. Well, what is it? In this video, we're going to tackle this question and teach you a couple of very useful commands. Now, on a Mac, you simply do command space and type in terminal, press enter, and then the terminal will open for you. It's one of your applications and it's on every computer. If you're on a Windows machine, then it is the command prompt. And I'll leave instructions at the end of this video of how you can access them, but you might remember this from the traceroute video earlier on in the course. But what is it? Well, it's how humans originally communicated with computers. Up until the 1980s, it was the main way humans gave instructions to computers and computers gave output to the humans. We didn't have something called the GUI or the graphical user interface, such as me opening up a new folder and changing the name of this folder or opening up Google Chrome. I don't really need to know how this is done behind the scenes. I just click on an icon and it opens it up magically for me. But command lines are really useful because you can do the exact same thing that you do visually on a graphical user interface, like I have here, on the command line. But they tend to be much, much faster to do, as I'm going to show you in this video. And there are also common ways to access different computers around the world. Like if you need to access a server in another country where your web app is hosted, well, you would use the command line. And I'll show you how to do that later on in the course. Now, in your day-to-day job, you'll be using the terminal a lot because you'll have to access servers, the database, your front-end application, but you can do all of that in one from the terminal. You can also download scripts that other people have written from the internet so you can use in your projects. Now, these are all things I'm going to show you in the later sections. The commands that I'm about to show you work on a Mac or a Linux. For Windows, I'll have the Windows version command at the bottom of the video as we progress. Most of them are the same, but there are a few differences. So let's get started. The first command I'm going to show you is the ls command. I simply type in and press enter, and it lists everything that is in my current directory. What is my current directory? Well, I do pwd for present working directory, and I see that I'm in the users That's my username. So I'm in my username folder, and these are all the things available to me. If I do cd, then I can go into this. If I wanted to go to, let's say, desktop, I do cd desktop. And now, if I do ls, I see that I have untitled folder because that's the only thing on my desktop right now. I can also do cd ... and this brings me back to one directory up. I can also do clear to clear up my terminal and have a nice fresh slate. There's a short command cd/, and this takes me to the root directory. If I do ls, I see that I have applications, library, system, users. That's the root directory of my Mac, essentially my Macintosh HD. I can also do cd squiggly line, and this takes me to the user directory. Let's clear this again. And if we check where we are, all right, let's change this untitled folder to something like test. Okay, let's say I'm in the user directory right now. I wanted to access desktop and then the test folder. I would simply do cd desktop and then test. And now I'm in the test folder, but there's nothing in there. So one thing we can do is I can say open dot, and it opens the folder that we're currently in. Okay, we're in the test folder. Now, if I just put this to the side over here so you can see, I can say make directory, which is make a folder, name. So name here will be whatever I want the folder to be titled. Let's just say this folder would be called web app. Did you see that? Now web app shows up in my folder. Let's change the view here so you can see it better. There you go. If I do ls now, I see that we have the web app folder, and as we know, we can go into it. And let's double click here to see what we have. We have absolutely nothing. Well, we can create a file in here by saying touch and the name of the file. So let's just do index.html. There you go, index.html. Now, what if we wanted to open this index.html? Again, we just do open, and the dot means we open the folder we're currently in, which is here. But if I do open index.html, it opens the file for us. How cool is that? But index.html is pretty empty right now. Wouldn't it be nice if we can open Sublime Text from here and add something? Again, you can do that with open. You put in A, so line A for application, and the name of the application. So Sublime Text. Close the double quotes, press enter, and look at that. I have Sublime Text. But if we wanted to do application Sublime Text and open the index.html file, we just do this. And now I can say HTML, and we'll just say, hello world. Save that. And if I do open index.html, we have our index.html file loaded. Wasn't that a lot faster than right-clicking, creating a folder, then dragging everything to Sublime Text? And as you can see, you can do things really, really fast here. Okay, let's change something. I'm going to close Google Chrome and Sublime. And in the web app, let's say I wanted to change the name of index.html to about.html. Well, I'll do the mv command, which stands for move, but it just moves the index.html file to about.html file. So it's a little trick. You're essentially just moving one file to another, but by changing the name, you create a new file and you replace it with the old one. So now I have about.html. Very cool. Now, these commands, typing them can get pretty tiring. I can press the up arrow and it goes through my entire history, which is very cool. I can also press the tab key and it will bring up my most recent command or completes what I'm about to write. So you can do it really, really fast. And when your commands get longer and longer, it's a very useful thing to do. Okay, I don't really need the about.html file anymore. Let's remove it. We do rm for remove and the name of the file, about.html. It's been removed. Perfect. Now, what about the web app file? We can remove that as well, but if I just do remove web app, well, it's not going to work. First of all, if I do ls or present working directory, I'm in the web app folder, so I need to move back to the test folder. Let's clear here, do cd. Now my present working directory is, I'm in the test, so I can remove web app by doing remove web app. But rm only works for files. To remove a directory, a folder, you need to do rm and then use the R option and then the folder name. In our case, it's the web app. There you go. It's gone. And with that, you know what? We can remove the test folder as well. We can go back to our desktop and then do remove our test. There you go. It's gone. And one last trick. On a Mac, you can do this.
This is so cool.
Right? Very, very cool. Okay. As you can see, you can have a lot of power with the terminal, and I want you to get used to writing commands on here. And from now on, try creating files and folders this way. Eventually, you'll get more and more comfortable with it, and things will be much faster than just using the GUI. In the developer environment section, I'll show you how you can change this boring black and white terminal to something like this. That's it for now.
See you in the next video. Bye-bye.
As a developer environment is really important. Since you'll be spending a lot of time in front of the computer, you want to make sure everything is set up properly. In this video, we are going to go over how to set up your developer environment. And I'll show you what I use on my laptop. Now, since I'm using a Mac, I will leave notes after this video for Windows users as well. Finally, this video is completely optional, and actually this entire section is optional. If you aren't looking to customize your setup or you already have it done, then you can skip over this section and move on to the next one. Now let's get started. In this video, we're going to customize Sublime Text. Sublime Text looks pretty nice, and I have a sample project, actually our background generator here. You know, it's kind of plain and boring. I want to show you that if you go to Sublime Text to Preferences, you can actually choose some color schemes and themes. So theme, for example, you see that we only have 2 right now. I can change it to that. I can change the color scheme to this, and we get a bit of a change. But the one that I really, really like is Material Theme. And I'll leave the link to this for you, and you can see over here that it makes your Sublime Text look really, really nice. If I go over this, we see that we can just install it with something called package control. And the way we do that, and it actually gives you pretty nice instructions, is we just need to press Command, or in case of Windows, Control, and P. So let's do that. I'm going to say Command-Shift-P, and I see over here install packages. So I can actually start typing and I'll get install packages. Or if you don't have package control, you can actually install package control through here as well. So let's install packages. And let's see what it says over here. And enter search for material theme. Okay, so we'll just say material theme. And there it is. I'm just going to click on it. You'll see that down here it's doing a bit of work to download it. And once it's done installing, we should have, there you go. We've installed it. And it says to activate the theme. Well, it actually gives you really nice instructions again. It's actually a really good idea to close and reopen Sublime Text just to make sure everything is running smoothly. So I'm going to close and let's just reopen it. And all we have to do now is just go to Preferences, Theme, and look at that. We have our material theme. So I like the, you know what? I like the darker one. So we'll do, let's do the default one. There you go. Okay, we're getting there. Let's check out what else it says over here. So we've changed it to material theme. And if you go to color schemes as well now, you should have material theme as well. So we'll make sure that those match. I'll say material theme. Look at that. That looks pretty nice. So we have our script file looking nice and also our CSS looking nice. Okay, awesome. Let's see what else we can do with this theme. Other thing is you have a couple of add-ons. You can actually add file icons if you want. You can see over here that you can add these. So let's see how we can install this. We can just do package control, install package, and find a file icon. So let's do that. I'm going to, again, do Command-Shift-P, install package, and let's do file, a file icon. There you go. Please restart Sublime Text for the applied icons to take effect. But it looks like it already has. Look at that. You can see over here, I have the HTML5 icon, the JavaScript icon, and the CSS3 icon. That looks pretty cool. Awesome. I'm going to close that. Let's go back to material theme. And they have recommended settings for a better experience. I'm actually just going to copy this. Where you want to put this? Well, if you go into Sublime Text, Preferences, and you go into Settings, you'll get default settings on the left-hand side. And on the right-hand side, you have the user settings. And you want to make most of your changes on this side. You see that our theme has already been automatically changed to material. So here we can just add our copy and pasted suggested theme options. Let's save that. Some of the themes have changed. Awesome. I'm going to close this and all right, things are looking a little bit nicer. What else can we do here? You can actually also change the fonts. If I download something like Roboto Mono, which is a Google font, if you remember, we just have to click the plus icon. We'll download it. And once we open that, there you go, we have our font. And what you do is you actually grab this and drag it into your application, which is usually, even on Windows, you'll have a font app. On Mac, we have the font book right here. And all we do is just drag it in here. So I have Roboto Mono now as my font. And it's actually very easy to change. If I go into my settings again, and we can just say font face, and we'll do Roboto Mono. If we save that, there you go. We've changed our font. Looks even nicer. And one last thing that I really like doing is changing the color scheme. There's something called Oceanic Next. That's really, really nice. And as you can see, this is completely up to you. If you want to have your own little color scheme and theme, you can do that yourself. But again, I just want to show you my setup here. So package control, Oceanic Next. Again, we just simply do Command-Shift-P, install package, Oceanic Next color scheme. Press enter. And now if I go to Sublime Text, Preferences, Color Scheme, I should have Oceanic Next. And there you go. I personally like this color style. If you like something else, well, that works too. Very cool. And the last thing I want to show you is that besides just looks, you can install packages with Sublime. And if you just go to Sublime packages, you can do a lot of things. You can add a lot of extensions to Sublime Text and anything that you need. For us, I think the most important thing is that, again, we do install package. And the first one is called Babel. And as you can see, it's a syntax definitions for ES6 JavaScript with React.js extensions. Whew. What does that mean? Well, again, as new features of JavaScript come up, we want to make sure that Sublime Text recognizes it and adds all the colors and formatting that we need. Well, by having Babel, and we install this, we now have a Babel file format. So if I actually click on this instead of the JavaScript one, you can do some really nice things like error functions, and it'll recognize it. I recommend using the JavaScript Babel version to make sure that any new JavaScript features that you use, it'll be nicely highlighted. One other one actually that I'll show you is the sidebar. Oh, I got to install package, and then sidebar enhancements. Up until now, if I right click here, I have only a few options: rename, delete file, or reveal in Finder. If I add sidebar enhancements, and now I go right click, I have way more options that I can do with my files, which is very, very cool. All right, that's it. Play around with your settings, and you can read up a ton on the internet about everybody's customized way of doing things. I think this works really, really well. It looks pretty, and it makes your life a whole lot easier when writing new JavaScript syntax. I'll see you in the next one. Bye-bye. Welcome back. I wanted to show you quickly another option you have for an editor. And I mean, there are a ton of options for you to choose from of where you want to write your code. And I prefer Sublime Text, but I want to show you Visual Studio Code as well, because between Sublime Text and Visual Studio Code, these two are probably the most used, most popular code editors for web developers. Now, the way you get Visual Studio Code is, well, you go to their website and just download whichever operating system you're on. In my case, it's a Mac. So I'll just download that. And once it's downloaded, I can just unzip it, open it up. From here, we can just open Visual Studio Code. And there we have it, nice and easy. Now, the reason a lot of people like Visual Studio Code is that it's free. Unlike Sublime Text that allows you to, well, still use it for free, but every once in a while you get an annoying pop-up to purchase the full subscription. Visual Studio Code actually has really, really nice plugins and tools to make developing better. Personally, I like Sublime Text just because it is nice and simple and clean. I find Visual Studio Code can get noisy, although you can change things around. But let me show you how I would set up Visual Studio Code. First, well, we can just create a new file. And let's create a new JavaScript file. If I save this, save it to desktop, and we'll call it script.js. One of the really neat things about VS Code, and let's make this a little bit bigger. If I create an object here, let's say object, and this will have name of Sally. If I go object dot, oops, that's not what I wanted, object dot, you see that I get auto suggestions from VS Code. I didn't have to install any plugins, nothing at all, but it detects what this object has as a property, and it auto-completes for us. And underneath the hood, it's using something called IntelliSense, and they give you a ton of suggestions when you're typing, as you can see here. For example, if I type in the window object, I see all the methods and properties that I can access, which is really, really nice, and people really like this. And if I make any mistakes in my code, you see that I get that underlined in red saying, hey, there's something wrong here. So that's really, really nice. And it has a few more options. It has a debug feature that is really nice. It also integrates with GitHub and source control. My favorite feature is we can actually open up the terminal in here. You see that I have my terminal right in my code editor, which is really, really nice. You don't have to switch between the screens like I do when I use Sublime Text and iTerm. Although I actually like that, some people prefer having everything in just one go. Now, if I was using VS Code, there's two plugins that I really recommend. And if I go to File over here, or let's go to Code, Preferences, and then do Extensions, there's a ton of extension here, just like Sublime Text. And one of my favorites that I like using with VS Code is Quokka. And I'll show you what it does in a second. I'm going to install this, and I've actually already installed it, so I don't have to click anything here. In your case, you might have to click Install. It'll install it for you. And once it's installed, I can do something fun. I can do Command-Shift-P, or if you're using Windows, it might be Control-Shift-P. And it's going to display the editor's command palette, which again works the same in Sublime Text. And if I type in Quokka here, you see the list of commands that I can use. And most likely in your case, you want to start a new JavaScript file. So if I do this, check out what happens now. If I create an object, let's say object, and I start typing, let's say name, you see that it's actually evaluating the script and giving me any errors. So name is not defined. If I do name is Sally, all right, everything is good. And if I start typing things like Sally.hi, I'll say Sally is not defined, and it actually evaluates what we're writing, which is really, really neat. And I can just have Quokka evaluate what I'm currently writing, and look at that. I see that object has name Sally. Very, very cool. So that's a really, really fun plugin. Another one that I really like, and no, we don't need to save that. Another one that I really like, and probably the only other one that I would add, is the Indenticator. And again, I have that already installed. The nice thing with the Indenticator is, if you notice here, I have these lines. Let's have another object within an object. You see that these lines are being highlighted here, showing me where I am in the code block, which I find very useful. And then finally, just like with Sublime Text, you can change the theme that you have. So if you go to color theme, for example, you have a few default ones and a few others that you can just install. So I actually installed Night Owl, which is one of my favorites. You can see that you can download different themes and customize it to your liking. That's enough about VS Code. Everybody has their own favorite code editor. There's no right one for web development. You just pick the tool that you find yourself liking the most and you find you work the best with. Some people like a lot of plugins. Some people like the simplicity of Sublime Text. It's all up to you. Just customize it however you want, because at the end of the day, it doesn't matter what code editor you use. But if I had to recommend two, definitely Sublime Text or VS Code. I'll see you in the next one. Bye-bye. In this video, we're going to set up our terminal to look nice along our newly set up Sublime Text. As you know, the terminal is just a text-based way to communicate with the computer instead of the graphical user interface that we normally use. As developers, you will spend a lot of time with the terminal, especially as you become more and more senior in your role. So let's make it better. If we open up the terminal, I have it open already for myself, you see that we have the word bash here. Bash is a type of shell that a terminal can have. And what do I mean by that? Well, just as the name suggests, it's just the casing around the terminal that is customizable. There's actually more than one shell. Bash is just one of them. One of my favorites are OMyZSH, there's the fish shell, and they all have different things that you can do with them, but it's just another way to customize your workstation. before I get into that, let's just customize our bash. The way we do that is we can first start off with getting something other than just having this to the left. The way we do that is we type in nano, which is a text editor, and then we do squiggly line /bash_profile. And here what we opened is a file that is the bash profile. So this is what our profile will look like. This file gets read every time we open up the terminal. In here, we can put in a bunch of things that we want our terminal to do. One of the cool things that I really think is fun is updating your PS1 variable. And I'll link to this website. And there's a bunch of examples here that we can use. Let's just pick one that, like this one over here. All we do is copy and paste this. And within our bash profile, we can just copy and paste. And as you can see, our PS1 now equals a whole bunch of gibberish that we don't really need to worry about. We see over here that to exit, we need to do Control X, then save modify. We just press Y and then press enter. Okay, nothing happens, but the way we fix that is we now do source and then bash profile. It essentially reloads our profile now. And look at that. We now have a cool little prompt to the left. So you can set up your PS1 to display whatever you want. If you want your current directory to display, that's great. If you want your username to display, that's good as well. You can set up in a ton of ways. The other thing that the terminal lets you do, if you click on something like edit background color, you'll get a few things that you can change in your shell. You can change your color based on what you want. And if I bring this over here, you can also click on the profile and actually it gives you a bunch of pre-built ones that look really cool. Let's do Pro actually. Very nice. Again, you can customize this as well. And as I mentioned, a different operating system, you have your own ways to customize it. But every single one usually has a profile and a way to modify what gets displayed based on your needs. Now, the one that I really, really like is a shell that's different than Bash. And I've used this one before, which is really, really good. It has a ton of themes that you can use. They have a bunch of options and you can play through them. The one that I really like is the fish shell. It's very simple. It has all the operating systems on it. And I install it using Homebrew. For those on a Mac, Homebrew is a way to install anything from the web. So instead of me going to a website and installing something, I can use the command line to download things. If you go to the Homebrew website, brew.sh, you can actually just copy this link into your terminal, copy and paste it, press enter, and it will install Homebrew for you. I already have this installed, so I'll just exit that. The way I install fish, you can see over here, all I have to do is say brew install fish. And while this is happening, I want to show you another option. So we have the terminal over here, but iTerm, which again is specific for Mac, is really, really nice and it's way more customizable than the terminal. So I prefer using iTerm 2. If I open this and double click, and look at that. This looks way nicer already. So let's just compare them side by side. I have my, let's make that a little bit bigger. I have the bash shell here, and I have the fish shell here. Although they both are in the desktop right now, they're running on different shells. The fish shell has, just like we have with the bash profile, has its own profile. So you can set it up. And you can set up which one gets activated when you first open up the terminal or iTerm. What I recommend is to set up your workstation in a way that's nice to you. My preferred way is to use iTerm and the fish shell. But if you want to use bash, that's great. The beauty here is that if I type in bash, I get taken to the bash profile, and if I type in fish, I get back to fish. iTerm also lets you just customize everything really nicely. If I go to preferences You'll see here that I have appearance, profiles where we can have colors set up. And there's a ton more you can do with your terminal that I won't get into this video because everybody has their own way of doing things. I just wanted to show you a basic setup so that now you have a nice environment that you can work in. I'll see you in the next one. Bye-bye. In this video, we're going to talk about Git and GitHub and source control. Now, you might remember GitHub from our previous section where we used it to put the website online. But I'll show you that it is so much more than that. More importantly, Git and GitHub is used by most professional companies, and it is a skill that is expected to be known by all developers now. So this is an important section. One of the first things most developers have to do on their first day at the job is to submit something called a pull request, which uses Git and GitHub. We'll get through that in this section. Don't worry. You're going to learn all of this and it's going to make sense. Let's first start with source control. Up until now, we have only worked on small files. No team members, just ourselves, just a couple of files. But in real life, you're most likely not the only developer on a team. Most likely the projects are huge. There's many, many files. Source control allows us to make sure that multiple people can work on the same file from different locations. Think of it as Google Docs that allows people to collaborate on one document. But enough talk. Let's actually check it out. I have over here set up 2 folders. One is for myself, Andre, who just started a new job at X company. And I have Marcy here, who has been working at the company for a while, and she has project files over here. I'm actually using the files from our background generator video. Now, without Git or GitHub, what I can do is just copy and paste these files. So I have whatever Marcy has, and we can start working on these files. I can have my developer environment here with my terminal and my Sublime text, and I can work on whatever changes that need to be made on the app. And Marcy, over here, also has her own version where she can work on it. And we're both working on the same project. But let's say that both Marcy and I are working on this project and she decides to change the project name from gradient background to super background. And at the same time, in my project, I decide to call this cool background. Well, now you'll have to set up a meeting between myself and Marcy and decide how we should change the code. And this is a small example, but you can imagine that as different programmers work together, there's always going to be this issue of one person changing one thing and another person changing another thing. This is where source control came in. And source control is a way to control this where we have one place instead of our own computers. In this case, it's just represented by the folder that I have in here. Instead of each of us having a copy of the project, with source control, we have a copy of the project, but there is a centralized location up somewhere, maybe owned by the company or somewhere on the internet, that has the ultimate version that we each talk to make sure that we each have the same version. Getting GitHub is a way to do this, to be able to use source control. And as a matter of fact, it's the de facto way of doing this. So like I said before, this is most likely the tool you'll be using every single day at your workplace. So if I go to the GitHub website here, what it allows us to do is it's a place, a central place that both Andre and Marcy can talk to. So even though we work on the same files, the same project, I can ask this central location, such as GitHub, hey, has Marcy made any changes? And Marcy can ask, hey, has Andre made any changes? And every once in a while, you'll get something like this where we have cool background and super background where we have something called a merge conflict. What GitHub allows us to do is say, hey, I noticed there's a merge conflict. I see that you guys have both changed your background. I don't know who's right, but here's the information. Andre and Marcy, can you guys talk amongst yourself and figure it out? That's pretty much the workflow. So let's actually see what this looks like. The first thing we want to do is set up a GitHub account. If you haven't done it in the previous exercises, you absolutely should start a GitHub account. It's free. And like I said before, if you're a developer, you just need to have it. It's where everybody puts their projects. It's where you work. You'll be spending a lot of time on this website. You might remember that when we had the GitHub project, I also told you to get GitHub for desktop. Although we used that to make things simpler during that video, this is actually not the recommended way of doing it. It allows you to visually see and interact with GitHub, but it's kind of looked down upon by employers, and most people use the terminal or the command prompt to actually do this. So I won't be teaching you this way just because I think it's bad practice and getting used to the terminal is important. I'm going to close that and we're going to get this started. The very first thing we're going to do is we're going to click on Start a Project. And here we're going to call it whatever we want. We'll call it Background Generator. And you also want to leave it as public, and we want to click on Initialize this with a README. And we'll click Create Repository. And what that does, well, we've created a new project on GitHub. And here, the README, which is just a file that describes your project, you can see that it's here. We can type into the README whatever we want and it'll describe our project. But let's go back. If Marcy, let's say Marcy has been working at this company for a long time. I'm actually going to remove my files here. Marcy has been working at this company for a long time, and the employer finally decided, hey, we need to use GitHub. We're going to hire this new guy, Andre. We want to make sure that you both can work on it, on the project together without any issues. Can you put the project up on GitHub? So what Marcy will do is she will go to GitHub, create background generator, and then she's going to click right over here to clone or download. And she's going to make sure it says use HTTPS. And from here, you just click on this button, which copies this link to your keyboard. Then Marcy goes to her terminal. And right now we're in Documents. We want to have the project in the Marcy folder. So I'll cd into Marcy. If I click ls, I see that, yep, I have my files. Now, the first command that we're going to learn is called git clone, and then copy and paste what we copy from the website. We're just saying, hey, clone this project from github.com. So I press enter, and there you go. Everything is downloaded. If I go back to the folder now, I see that I have background generator. If I double click this, you'll see that I have a .git folder here that's actually hidden. You might not even see it on your laptop if you don't have this feature on your computer enabled. But this .git now allows me to communicate with GitHub. So what we can do now, Marcy can copy and paste these files and put it into background generator. Now let me show you the next git command. Marcy right now, if we see, she's in her folder, but now we need to go into background generator, because if we do any git commands here, well, it won't work because it's not a git project. We need to actually go inside of the project that was created on GitHub. So I'm going to cd into that directory. Notice here, I have my terminal set so that it actually shows me what GitHub location I'm in, and I'll explain what master means later. Now that we're here, we can look at all our files. Yep, I see that now I have my README, which I created on GitHub, plus the files that I copy and pasted. We need to sync this so that if I go into my background generator, instead of the README files, Marcy can put up her files on GitHub. The way we do that is our second command, git status. It tells us that we have untracked files. That is, we have index.html script.js and style that are untracked. And it says use git add file to include what will be committed. So now that we see our status of what we have in our folder, we can say git add and the file name. So I can do index.html, git add script.js, and git add style.css. Let's clear this so we can see it. And now I can do git status again just to see what our status is. And now I have your branch is up to date, changes to be committed. You see that now with add, we've said, hey, we want to add these changes. We have new files that we've added and says to be committed. So the second step is to do something called git commit. And git commit says, hey, I'm committing that these are the changes that I want to make to GitHub. And it allows you to pass a message so that on GitHub, it'll show the message. When Andre comes back in, he can say, oh, Marcy added these files and this is the message. And we do that by doing this. And within here, within the double quotes, I can say adding, starting project. Close the bracket, press enter. I'm going to clear this. Now there's one last step. We did git add to add our changes, then git commit to commit and say, yeah, we're locking in those changes. And then finally, we need to let github.com know that these are the changes. So we do git push. And there you go. It has now been pushed to this repository. So if I go back and I refresh, look at that. It's the same thing that we did when we put up our first website online, but instead of using the desktop version of GitHub, we use the command line. And now we have our project, which is very good. Now let's go back to our example. So Marcy has been working on this project. There's a Git repository, and I just joined the company, and now I need to start working on this. What do? Now I need to access GitHub and get the copy of background generator. The way I do that, well, I go into my folder and I do the same thing. I do git clone, and then I copy and paste the repository just like before. Git clone and clone the repo. And there you go. If I go back to my folder, look at that. I have background generator. So we're both working now on background generator, but not off of each other's files. We're working with whatever version is on GitHub. All right, so now more realistic. We go back to working, and on the first day of my job, I say, I'm going to change the gradient background title, actually the H1 tag, to cool generator. If I save this and I do git status, oh, well, I'm not in a Git repository right now. If you remember, I have to go into background generator. Let me open that up a bit so you can see. There you go. Again, these git commands won't work if you're not in a folder that has the .git folder. So let me do that. cd into background generator. I'm going to clear this, and I'm going to say git status. And look at that. It tells me that I've modified index.html file. And if we remember, I will say git add. I only have one file. I can do index.html. But if I had multiple files and I want to just commit all of them at once, I can just do the period. So I'll do that, and then git commit, and I'll add a message changing title. I press enter. I'm going to clear this. Okay, and again, I do git push, and it looks like everything went through. So let's open that up and check it out. I now refresh here, and well, we haven't seen any changes, but we now see that we have 3 commits. we have the initial commit, the adding background project that Marcy did, and it shows you all the files that were added. And if I go back, I have the changing title commit. And now I see that, yeah, Andre just changed the background generator, which is in red, to cool generator. So as you can see, we have a history of all the changes, and we can always go back if there's any mistakes. But there's one issue right now. If I go back to the code and I go to Marcy's computer, I see that, well, she still has background generator here. Why is that? Well, because her computer doesn't know that GitHub has been updated. The next command I'm going to show you, this is the last one I'm going to show you in this video, is git pull. So remember, git push to push the changes to github.com, and git pull to pull whatever's the latest. So I do git pull, and there you go. You see over here that it shows me that index.html file was changed. Now you see that my title has been changed to cool generator. Let's just say that Marcy saw my first change and she really likes how I've added cool generator, but I think she wants to make it capitalized. Again, she's going to save that. She's going to say git status. All right, I have my index.html file, git add, then git commit, and I'll add the message capitalize title, and then git push. There you go. Again, I go back, I refresh, and now there's 4 commits, and we see that capitalized title is the new changes. The first day of work is done. I come into the next day of work, and well, I want to start with whatever the latest project is of background generator. And let's say Marcy worked all night to change that title to cool capitalized. I want to make sure that I have the most updated version. So what I do is when I get into work in the morning, I'll say, well, I want to make sure that if there's any changes that Marcy made, I know about them. So I'm going to say git pull, and notice here how the title's going to change after I do the pull. And now I click to Sublime Text, and there you go, cool generator. All right, in the next video, we're going to expand on this and show you what happens if both Marcy and Andre make the same changes. What does GitHub do? I'll see you in that one. Bye-bye. Welcome back. Let's continue from our previous video to talk about a more advanced workflow in Git and GitHub. Now, up to this point, both Marcy and I have just been working on, over here, branch master. What does that mean? Well, it says branches, but I only see master here. And you might have noticed one issue with the way that we were doing things. That is, if it's my first day on the job and I just changed the title, but maybe we didn't even want that change. Maybe that breaks our branding or breaks our app. But I was able to do it so easily to change it into master. Maybe Marcy didn't even know that I've added that change. And that's a big problem, right? You don't want to put things into what we call production, into what the user sees, if it's going to break our website. If you're a big company like Facebook, that could mean millions of dollars in lost revenue, even if you have a bug that lasts a few hours. So I'm going to show you a more realistic workflow that you'll have, and that is with branching. Let me show you what I mean. I have over here a visual of what Git is really good at. Up until now, we've been working on what we call master. That is the master branch. Think of the master branch as the authority. This is the right way that our app or our website should look. And up until now, when I added the cool background title, well, I went from background generator to cool generator. And then when Marcy changed it to capitalized letters, then we went to here. And we just went in a linear fashion from one end to the other, to the other, to the other. But like I said, that is a bit of a problem. So a better thing to do is what we call branching. If I wanted to change the title, I will create a branch and just call it little feature, for example. And I just work on that branch on my own without affecting the master branch, what the user sees. And only when it's finished, when Marcy has reviewed it, when we have tested it and everybody on the team's okay, then we bring it back into master. And you can see over here with the big feature, you can keep going for a long time on your own branch. And only when you're done, do what we call merge into master. I'm going to show you how that works today. I'm going to close this and remember our example. We have Marcy's computer here with all the files, and we have my computer here with all the files. We both have our workstation set up. And now you see what master in my terminal means. And I'll show you in the notes afterwards how you can have this set up so it tells you what branch you're on. But we can see that we're both on master. That's my computer. And Marcy's computer is also on master. We want to make sure that we're both up to date with the latest GitHub. So Marcy's going to do git pull, and I'm also going to do git pull. And let's say that I'm now working on a new feature. And because it's a better workflow not to work on master, and this is a good tip generally, don't work on master, always branch off. If I do git branch, it'll show me that, well, I only have one branch, and that is master. But we can add to it. We can say git branch new or little feature. And now if I do git branch, I see that I have little feature, but master is highlighted because I'm currently on master. So the way I would go to the little feature branch, I'll say git checkout little feature. And there you go, switch to branch little feature. And now I'm on little feature branch. So what I've done is I've branched off of master and now created little feature. Let's create a bit of a change. I'm going to say in the little feature, we're going to change the current CSS background title to say, this is the background. I'm going to save here. And again, I do my simple workflow that we did in the last video. Git status. I see that, yep, we have the index.html change. Going to clear so we can see. So now that we've made this change, let's do git add. And again, just git status to make sure everything went through. Yeah, we're ready to commit index.html. So we'll do git commit. Message will be changing text. Perfect. Let's clear that. And now, again, in order to let GitHub know of the changes, we need to do git push. So we'll do git push. All right. Let's go to GitHub and see what happened. We see that now we have this yellow bar that just showed up and says you recently pushed branches. So if I click on this green button here, compare pull request, it shows me what changes I have, which is I've changed the title. And here I can let Marcy know, saying, Marcy, I've changed the text. What do you think? And I click on create pull request. And now I have my PR. And you see here how it says merge pull request. Well, if we go back to our diagram, I've created this little feature. And now I'm saying, hey, Marcy, I've just done this new change. What do you think? Is it okay for me to merge it into master? And what will happen here most likely is Marcy will come, see this pull request. You can see that we're on the pull request tabs. So she'll be able to see them and seeing, oh, Andre just did this change. She'll look through the changes and she'll say, well, if she likes this, she could be like, looks good. She can click on Start a Review. And you know what? She likes this, so she's just going to approve. Now, Marcy or myself, usually you don't want to merge your own pull request. Somebody on the team does it. Can now just say merge pull request. Confirm merge. And there you go. Some teams like deleting the branch afterwards, so you can just click delete here. If I go back to the code, well, I don't have the branches anymore because I just deleted it. But in my master, if I go to index.html, I see this is the background. So now Marcy can go to her project and say git pull. And again, she has the latest update. Now let's talk about some conflicts that can arise. Now let's say Marcy wants to change something, and I also change the same thing, and we get a merge conflict. Let's see what happens. So let's say Marcy wants to create a new feature saying, we'll call this one big feature. And she'll say git checkout or git branch big feature. She'll say git checkout big feature. And if I do git branch, we see that, yep, there's a new branch here. Let's clear that. And she'll say here that she wants to change this back to background color or background generator because all the users are complaining that the title changed and they like the old title. So she's changed that. She has done the git add, git commit, reverting back to old title. Perfect. And then she's going to do git push. Oh, let's clear that first actually. And we do git push. The first time you get this, you might get this error saying that there's no upstream. You just copy the code that they give you here. Perfect. Now if I go back to background generator, I see the big feature pull request over here. And just to show you that you can have multiple commits, let's say Marcy decides to, oh, this is me. Marcy decides to add an exclamation point here. She can just say again, she saves this. That's clear. She'll say git add, git commit. You do this a lot, so you'll get really, really good at Git after working at a company for a while. And she'll say added exclamation. Oops. That's not what I wanted to do. Git commit. Commit. Added exclamation. And she'll do git push again. And let's go back to GitHub. If we look at the pull request, it'll actually have both of these, reverting back to old title and added exclamation. And we see over here both of the changes. Create the pull request, needs changes, Andre. So while this pull request is out there, I decided to start a new branch called, let's just call it conflict for now. And I'll do git checkout conflict. And now in the conflict branch, I decide to change this to just completely remove the cool generator. I save that. Again, I check my status and index.html file has been changed. So while this is happening, I get Marcy to merge the pull request. So she's entered it into master. Her pull request is in. And now if I go back to my conflict and I do git status, and we have to add these, so git add, then git commit. I'll just do a short message here, just check. And now, if I go back to master, oh, I have to do git checkout master. again, before I push my changes, I want to make sure that I have the latest version of a master, so I'm not changing anything, or I won't have any conflicts. So I'll do git pull to get the latest. And now I go to git checkout conflict branch. And I can do this command, git merge master. So I'm saying merge whatever is in master into conflict. Marcy has been working on the big feature and she's merged it. So now master has the big feature branch. But I've also created another branch and I've been working on my own on the conflict branch. And the conflict branch doesn't know anything about master. So I'm saying, hey, whatever's in master right now, which includes the big feature that Marcy worked on, pull it in and make sure that there's no conflicts. So I do that, and I get conflict, merge conflict in index.html file. Now, if I actually click on Sublime Text, let me open this up so you can see it better. Oh boy, I get this weird little syntax. It's overwhelming at first, but it's easy to see what's happening. Head is where my branch is at, and it shows me that here to the end, I don't have the H1 anymore, but in the master branch, we have background generator. Now I can talk to Marcy and say, hey, Marcy, do you want to keep the background generator title? And she'll say, yes, that was the right thing to do. Don't change the background. Well, in that case, I just remove these lines and remove this and save now. If I do git status now, okay, we have the modified status here. Let me just make this smaller again so you can see. So let me clear this. What we do now is we have to do git add, again, because we made those changes. And we have to do git commit, fixing merge issue. And I forgot the M. Let's try that again. M, conflict, fixing merge issue. Let's clear here and do git status. Nothing to commit, working tree clean. And if I do git push, well, again, I get this error, but I want to show you this time around. If I do git push origin conflict, it now works. Let's go back to GitHub, see what sort of things we have. We have the conflict branch. And if we look at the conflict branch now, well, there's nothing changed because, well, I just reverted all my changes, so it's completely empty. There's no changes now, so Marcy will be like, hey, did you mean to make this PR? It's empty. So I'll see this message on my PR and I can keep going. And that's pretty much the workflow that you'll see in Git. I'll leave the commands for you after this. But you see, it's very, very nice to work with. You learn a few commands, and as long as you have this visual model of every time you're working on something, you always create a branch. You title it with whatever feature you're working on. And every once in a while, you want to pull master and merge master into your branch to make sure that you're not missing out on any updates that other developers or teammates have done. Once you're done with your feature, you make a pull request by doing git push. And that pull request, you'll add comments and people will review your file changes. And if they want you to make a few changes, then you can do again git add, git commit, finally make your changes, and then you can merge pull request. And once that's done, then everybody else on the team, there's now a new master. So everybody else on the team should do git pull as well. It does take a bit of time to get used to, but is a really, really nice workflow to make sure that everybody on the team works on the same files, same projects without causing any errors and making sure that everybody collaborates well. And that's it. Hope you found this useful. I'll see you in the next one. Bye-bye. In this video, we're going to talk about how to contribute to open source and actually take you through the steps. But first, for those who don't know, what is open source? Well, a lot of technology that has been created on the internet that we know today has been built on top of open source projects. And open source projects means that anybody can view the code. Anybody can see the code of a program, can inspect it, can modify it, can enhance it. In this way, the idea is that by sharing this information with everybody, we get everybody's input and we use the collective mind to improve software. Not only that, but it also benefits everybody, right? For example, the most famous example of an open source project is Linux, an operating system just like Windows or Mac OS, except it's built by everyday programmers. And it's code that is completely open sourced. Anybody can inspect the code, add on to it, and it's become so successful that most of the cloud that we know of, the servers usually run Linux. AWS, Google Cloud, Microsoft Azure, all of them use Linux. Some of you might be running Linux right now as you watch this video. So not only do you get to work with other developers from around the world, where you can build great projects by just working in teams, by learning how open source works, well, you don't have to create something as big as Linux. You can create a project with a friend, something very small and simple. It doesn't really matter. The idea is of collaboration, of openness and sharing code to hopefully improve on the collective knowledge. Finally, a lot of employers actually look upon open source contribution as a plus. So if you're able to put in your resume that you're an open source contributor, well, that's a good sign. Plus, it teaches you valuable skills using Git and GitHub to work in teams. If you're looking for job experience but you don't have a job, contributing to open source is the perfect way for you to learn how to work in teams and mimic a work-like scenario. This is a really important video and something I'm really excited about. So let's show you how to make your first open source contribution. Improve your resume, learn some real-life skills, and have fun along the way. Now, we've actually created some open source projects for you for this course. We have the Zero to Mastery repository here, where we can see that we have about 64 projects open right now with about 2,000 contributors. That's a lot of people, and this number is bound to increase. Now, this place was created as a practice ground for you, a playground. Nobody will yell at you if you break things. You can contribute, add silly things, whatever you want. It's a testing ground. The idea is to have as much fun as possible and make it as easy as possible to contribute to open source. Now, within that organization, we have a great community of administrator or management team that will help you with these open source projects. By the way, who are these administrators? They're right here. Ignore my name. I help out as well, but they do a lot of the heavy lifting. And they are past students, just like you, that have had a bit of experience now. Most of them are working full-time, but they are now helping out the community by helping with our open source projects, our Discord, and generally just helping our community grow. So shout out to them. If you get a chance, say hi to them on Discord. They definitely do a lot for this community. They're very active on Discord and they really help maintain all of our open source projects. So let's learn how to make our very first open source contribution. I do want to note here that this isn't the only way for you to contribute to open source. This is just a playground that we've created for you. But once you contribute here, you can go off and contribute to all the other open source projects all over GitHub they can find. You can contribute to projects like React and Angular. The world is your oyster. Or you can just stick to these, as we actually have a ton of projects here that are fun. We have events going on like Hacktoberfest. Well, we'll get to that shortly. We definitely have a great community of developers, and we can create some awesome projects together. Now, the way you want to get started is to first go to the Start Here guidelines. Now, in the Start Here guidelines, and I'll link to this page, you actually have a 4-step guide to get started. The first thing you want to do is to actually watch the Get Started guideline. A fellow student actually created this guide for you to follow the steps that I'll mention in this video. So you always have this as a reference. So after this video, definitely check out this document as a reference. But otherwise, once you've browsed through the document, make your first pull request. So if you've already watched my Git and GitHub videos, you should be all set. Otherwise, hopefully you're familiar with Git and GitHub. Now, the first thing we want to do is to actually add our names to the contributors.md file in this project. So if you go up, you'll see that we have a contributors.md, which stands for Markdown file. And if I click on here, you see that all the contributors that we have over 1,000 contributors. And if you scroll down, these are all their GitHub names. So your first task is to actually add your name to this list. So how can we do this? Well, we can just clone this repository, but a more recommended way of usually contributing to open source is to fork the project. Fork essentially means copy over the entire project and put it on your own GitHub profile. So if I click fork here, and we see over here that you can select where you want to fork the project and you want to select your profile. So once we fork this project, we make a copy of it. It's like we own this repository now with our own version of the Start Here guidelines. So once we have this, we can clone this repository using SSH or HTTPS, whatever you prefer. In my case, I'll use SSH so that I don't have to use my password every time. I can now say git clone and clone this repository. Now we can cd into Start Here guidelines, and we can open this up in our favorite text editor. Now, once here, let's clear this. We have the contributors file, which we need to add our name to. Now you can see here the contributors file is getting quite long because, we've got a lot of students who are contributing to open source. But at the very end, make sure you're at the very end here, you want to add your own name. Now here's the thing. Right now we're on the master branch, but I'm going to show you what a good practice is. We have our forked project, and we want to create a new branch to work off of instead of master by saying git checkout -b to create a new branch. And we want to name this branch. In our case, let's just name it test. If I hit enter, you'll see that now I'm on a new branch called test. And in this branch, I can add my name to this contributor list. In your case, you'll want to use your own GitHub profile. So we're using Markdown here, which is a syntax to write and have some functionality. For example, if we go to the contributors list, you'll notice that they are all clickable links. So we essentially use the same notation. We do a dash, square brackets with your GitHub username, and then in the parentheses, we just have the actual URL that you want to link to. In our case, the GitHub username that you have. So your GitHub username here, GitHub username here. Once we do that, we can save this file and now go back to our terminal and say git status. And we see here that, we've just modified our contributors.md file. And if I do git diff to see any changes that we've made, we see that we've added this new line. So let's clear this. We have our name all set up, and we can now add this commit by saying git add and dot for everything. We'll add everything. And then git commit. And we'll write a message that says, added my name to contributor list. There we go. So now it's time for us to push these changes. Now if I do git push origin master, well, right now what that would mean is that we want to push to origin, and the origin is this start here guideline, which I forked. So the origin is actually my version of the project. And if I want to push to master, that is the main branch. But we don't want to do that, because ideally we want to be able to also change and add our name to the original Zero to Mastery Start Here guideline, because this is the main project. So what we can do is, instead of master, push to our test branch. So we say git push origin test. There we go. Now if I go back here and go to my project and I refresh, I now have two branches, the master branch and also the test branch, which I just updated. So one way to do this is to click on new pull request. And you can add comments here, like I've added my name to the list, and you can tag some of our maintainers. In my case, I'll just tag myself. If I do create pull request, I now have my pull request. And notice here how my pull request is now at the Zero to Mastery Start Here guideline. So that if I go back to our Start Here guideline, I see that I'm part of the pull request now, right here. And because I've tagged one of the management teams, so in this case, it was myself, or you can tag any of the management team that we have. Now, in this case, I'm cheating because I also help manage this. So I can just myself merge the pull request. Most likely in your case, you won't be able to merge it yourself. But if I click merge and confirm, there we go. I've merged my project. I've deleted the branch, and the pull request is closed. If I want, I can even delete my own fork. But for now, let's keep it the way it is. Let's check the Start Here guidelines and see if my name has been added to the list. If I scroll all the way down, hey, check that out. There's my name on the list. So I've been added to the contributors list. That was pretty easy, right? And the cool part is that now if I go to my profile, I actually have Zero to Mastery as one of my organizations. So if you're able to add yourself to the contributors list, you can actually join the Zero to Mastery organization and have this little icon appear on your GitHub profile. And lots of GitHub profiles have organizations, so people usually have their workplace icon in here. So it's just a nice little thing to have on your profile to show that you're involved in the programming community. So we've just made a pull request, which is step 2, and that was pretty fast, right? Finally, the next step is to go join an actual project and start contributing the way we just learned in our Zero to Mastery organization. Now, there's actually a guide that we provided for you to figure out what project you choose, what's going to be good for you. We also have in our Discord a group projects section where we can look at some of the current projects that are happening, or you can just go to the Zero to Mastery organization and pick any of the repositories to contribute to. Now, in the next video, we're going to contribute to one of these projects and show you a real life scenario. I'll see you in that one. Bye-bye. Welcome back. We've just done our first contribution, which wasn't that crazy, right? We just went to the Start Here guideline and added our names to the contributors list. But let's actually contribute to an open source project now. Now, in our community, every month we do coding challenges. Now, you can search for coding challenges here, but this month is a special event because we're actually doing a Hacktoberfest event. And this happens once a year in our community in October. And you can see that if we click on the Hacktoberfest 2019 link, so depending on when you watch this, you might have a different year. You see that we've provided for you an opportunity to contribute to an open source project. We actually have Animation Nation. We have a Sanctified project and also a Python project. And you can contribute to any one of these. So if we look at Animation Nation, well, people have contributed their CSS animations here. Ooh, this one looks nice. We also have the Sanctified project. So people have created a little Santa website. That's kind of nice. Very, very cool. And then we also have the Python art project that actually does something really cool. If I go to the website here, it'll actually turn an image into ASCII art, which is really, really cool. Now, there's tons of projects that you can do, but let's try and do this Animation Nation project. So the first thing I'm going to do is go to the project repository and follow the steps that we've done before. That is, we fork the repository. We now clone this repository. Let's git clone. And while that is being cloned, let's look at the instructions. Now, most open source projects will have instructions on how you can contribute. In our case, we have a nice step-by-step guide. So in the art directory, create a directory name after yourself. Okay, that's nice and easy to do. So let's cd into the Animation Nation project. Let's open it up in Sublime. And we see that there's an art folder. And in here, we have to create our own name or our own folder with our name. I've actually already created a folder called Animatron that has a little CSS project with index.html and CSS. So just to show you, let's move this. Or just to show you, this is my little animation using some simple index.html and CSS. Nothing too crazy. Now, all we need to do is move this into the art folder as the instructions have given us. And now we've added our project. Let's see, where's Animatron? There it is. That's my project over there. Next is to, well, within this folder, make sure we create two files, an HTML file and a CSS file, and link the CSS file to your HTML. Using only HTML and CSS, create a work of art. So I've actually already done that. Again, if we go back to the project, I have an index.html file, very, very simple, that's linked to a style sheet. And this is my styles that I've added for my animation that has these little lines. Now, the last part here is to add my own card to this section, to the include.js file. So let's just copy this, go to the includes or include.js, and you see this is where everybody enters their information. And right here, we can just add what we copy and pasted. Make sure the indentation is proper. So the art name is going to be called Animatron. page link is going to be, well, the name of our folder. So animatron index.html. And then the GIF name, which they suggested that we include a GIF. So if I remember correctly, the GIF name was trans.gif. Again, I just created a little GIF of my animation. So we'll call it trans.gif. Author is Andre, and the GitHub link is my GitHub link. All right, so that should be good. Let's now make a pull request. Now, notice here how I did all these changes on master. Ideally, we created these changes on a new branch. So we can actually just do that now. Git checkout B and call it animatron. So if I do git status now, I see that I have 2 changes. That's good. Let's do git add, git commit, adding my artsiness to the project. And then finally, git push origin animatron. All right. If we go back to the project, we see that we actually now have a little icon that says compare pull request. If I go back to the forked repo, 0 to mastery, you see right over here that I also have this yellow banner. So if I click on this and say, please add me to this list, and we'll link to, this is Joy, who's one of the managers. So I'm just going to say, please add me to the list. We actually don't even need to tag her because she will check this occasionally. So I'm going to create a pull request. It's now opened. That's awesome. So please add me to the list. If I look at my file changes, you can see that these are what I've added to the project. So if I now merge pull request, again, you won't be able to do this, but some of our management team, people who are managing the open source projects, will be able to merge for you. We can delete the branch since we have merged everything. And now let's see if the changes have been made. If I go to the 0 to mastery animation nation, so if I now look for my project, hey, look at that. There's my little animatron project that, well, there it is. There's my CSS. That's beautiful. Now, the way this project is designed, it randomly selects the CSS animation. So it might not show all of them at the same time. So you might have to refresh this a few times. But just like that, I made my open source contribution. Now, there's a ton of projects here that you can join. And like I said, this is a playground for you to test, make mistakes, because this isn't a real workplace. We want to practice these skills before we actually go into work and make big, dangerous changes. And that's open source. I highly, highly recommend that you get involved. It's a great way to work with others. It's a great way to learn how Git and GitHub really work. There's no doubt that there's a lot that an individual programmer can do. However, the progress and scale that something can be built is really compounded when many people work on something together. Go make your first open source contribution and have fun building things with your fellow programmers. It may one day lead you to impress a potential employer. See you in the next one. Bye-bye. Today, I'm going to walk you through a typical developer day. Now, I know there's different types of companies, but in this video, there's going to be some main concepts that most likely you're going to see in all forms of work you do as a developer, whether it's for a company or a startup or freelance. similar work patterns are going to be seen. And I want to take you through that because I'm assuming you're taking this course because you want to become a developer or you want to upgrade your skills. And it's important to know what a current workflow is and also what to expect to decide if this is for you or not. So let's get started. It's 9 a.m. now. And as you can see, I've created this great diagram of myself coming into work. It's 9 a.m. And I have here what I call a Trello board. And I can show you right over here what it is. Usually when you work on big projects, in order to stay organized, people have this, what they call Kanban style, where there's a list of things to do, what people are working on, and then there's a done list. So usually in the morning, you come in and the first thing you want to do is you want to make sure that any changes that have been made while you were at home or at night, maybe you have teams that are overseas that have worked while you're sleeping. Well, as you know, we want to always go to Git, check out master. And you should know how this works by now. If not, make sure you check out the previous section. I would do something like git pull to make sure that everything is up to date. All right, and now I have everything up to date. You also want to see if there's anything that maybe you're still working on and hasn't been resolved. If you remember from previous videos, I have a couple of pull requests, and one of the ones was the conflict one. And we remember that, well, this branch that I was working on, Marcy told me that we don't really need that change, so there's no files changed. I can clean up what I've been working on by just closing my pull requests. I'm going to delete this branch so that now going back to my workflow, I'll just have master that I'm working on, everything is up to date. All right, so pretty good. Maybe I'll move this conflict branch that I was working on. I'll just move it to done and say that, you know, I'm done with it, so the team knows that I am no longer working on this branch. 9 a.m. is done and 10 a.m. rolls around, and I have over here, usually what happens is something called a stand-up, where team members and everybody that's involved in a project or whatever you're working on meets to give everybody's updates. And usually everybody stands around, and you see over here that there's an SM, that is usually a scrum master or a manager or a director that usually organizes the meeting and takes the lead. And what we all do is just say, hey, this is what we did yesterday. This is what we're going to do today. Or maybe if you're blocked on something and you're having an issue, maybe you can ask some team members. And usually in this meeting, you also have this scary looking person, which is actually the PO, which is the product owner. So that is anybody that, it could be a client that has vested interest, that is money on the line for this project to be built. It could be your CEO. It could be whoever is owning the product, whoever wants to make sure that the product gets finished and gets finished on time, but is also built properly. That's the product owner. So you have a quick stand-up meeting, and usually around 10:30, you'll go back to work. You'll be working on something like bugs or new features, and the way you do that is, well, you go back to a board like this and see what's on the to-do list, and usually they're all small chunks, and, you know, let's say I want to update the README, I'll drag that in here and to let everybody know that I am working on the updating the README. You know, if I'm updating the README, I'll do something like git branch update README, and I'll just git check out that branch. And I'll start to work on that feature or bug, whatever it is. All right, and let's say that, you know, I've had my lunch, I'm feeling very happy, I got a lot of work done, and I actually finished my README task. Well, in that case, I will actually submit a PR or a pull request, which we've seen in previous videos, where I'll do the classic git add command, then git commit, then I'll be git pushing up to GitHub all my changes. And then what we usually tend to do is if we go back to GitHub, we'll have people that, like yourself or other team members, that see that, oh, there's a couple of pull requests. Let's review a pull request. So that is code that maybe yourself or others have done. And I see over here that I have a nice little person who came and refactored our background generator. So we would view the file changes, and we see here that they have fixed a bunch of our background scripts to include the new ES6 syntax, which is very, very nice. We review everything. If we want to comment, that's great. But you know what? These changes look really good. So I'm going to say approve, do the @ and thank you for these changes. It looks great. Merging now. So I've submitted my review. And everything looks good. If there's any issues, then I can let them know that we need a couple more things fixed, but everything looks good here. Some companies will pass it off to something called QA that does quality analysis, essentially making sure that the changes that we've implemented doesn't affect our web app. It still works on the phone. It still works on all the browsers, and making sure that our features or our bugs are fixed. So that usually happens. And if everything passes, then woohoo, our PR gets approved by our team. The QA says, yep, everything looks good. You're happy with what you've done and your PR. And then you can finally merge into master. And when that's done, we go back to the Trello board and we can just say that update README is done. The team knows that you're all good to go. And it all starts back up the next day, where you get in, make sure that there's nothing outstanding to do. You go to the meeting, you look through the to-dos, grab a piece of feature or bug that needs working on, and you start working on it. And I know it doesn't sound very exciting from the way that I'm describing it right now, but it is a ton of fun. Whether you're building a product yourself or you're the only owner, you still are using these techniques to just keep yourself accountable and making sure that tasks are getting done. Because being a web developer is all about breaking up big tasks like building Netflix into small, manageable chunks. And each day you're just working one chunk at a time to write some JavaScript, maybe some CSS, maybe some HTML to build this one great big product. And that's it. That's a typical day of a web developer. I know it's always good to know what you're getting yourself into, some of the tools that companies use, and some of the workflows. So hopefully this video was useful to you. I'll see you in the next one. Bye-bye. NPM was created for developers to be able to share JavaScript code that they have written. This way, any developer around the world can grab somebody else's code that may solve his or her problem. This creates a great knowledge base of scripts that people can constantly update or improve and build on top of. As a matter of fact, it is very rare that an app or a website these days are built purely from scratch. By using the collective intelligence, we can grab pieces of code that are really good and build on top of it to create our product. For example, using JavaScript, you can write virtual reality applications, but you don't have to figure out everything yourself. Someone out there already worked on being able to use JavaScript VR. So you use that person's code to start your project. Let's talk about how NPM works. NPM looks like this. A website with a search bar, kind of looks like Google, but here you can search for what we call packages. And these packages are located in the NPM registry. And this registry keeps track of files that have been submitted. Anybody can submit these files that are called packages or modules, and they contain two things: a JavaScript file and a package.json file. And the package.json file, which you've never seen before, is a meta file that describes this package. So you can see here that this NPM registry is just a registry of all these files of JavaScript that other people have written. And the idea is to have small JavaScript files that do one thing really, really well so that other people can use it. You then compose or combine different pieces of code and different packages on your project to add functionality and not have to rewrite something that has already been written by another person. So as you can see here, I have, let's say, a person that has just written a JavaScript file that is really, really useful. Well, they think that other people might be able to use it, so they push it up to the NPM registry. And by using the search bar over here, somebody can find your package. Maybe they're looking to have a script file that creates a list of arrays for people interested in cats. Well, then they are able to find this file and download it from NPM registry onto their computer. So let's talk about the benefits from this. Well, you get expertise from others. Maybe you don't know everything. Maybe others are better than you at this certain thing. Well, you use that collective knowledge to use their code. But there's also a downside to this. Not all packages are good code. Anybody can put up their file to NPM. And you're also adding more bytes to your project, which makes your project size even bigger. If you got all these files down into your project, well, that's a lot of files, and each one is going to have to be sent from the server to the browser. And as you know from previous sections, we want to minimize the size of our project, so we build fast web apps. And there is an art to finding good NPM packages, and you will get used to it after a bit of experience, so don't worry. Now, you also see here that I have something called Yarn. Yarn still uses the NPM registry, but you might see it every once in a while. Just like NPM, it's a tool to grab things from the NPM registry. We won't talk about it in this course, but just keep in mind that both Yarn and NPM are very, very similar. If you learn one, then you know the other. So don't be afraid if you hear of a project that uses Yarn instead of NPM. Now, you can browse NPM and find things, but there's usually 3 types of packages. One is packages that you can use on the browser, so on the front end. So that is, you can download jQuery from NPM. You can download all sorts of scripts that help you with front-end workflow. The second type are ones that give you new commands that you can use on the command line. And I'll show you an example of that later on in this section. And finally, the third type of NPM package is ones that you can use on Node.js on the backend. And that might sound scary to you, but don't worry. When we get to the Node.js section, I'll show you some of the Node packages that you can use, but it's pretty much the same thing as JavaScript. As a matter of fact, NPM stands for Node Package Manager. It was initially built for Node, but it was so good and so popular that you can now use it for the front end as well. But it's all the same thing. It all works the same. Like I said before, they're just scripts that you're able to use that other people have written. And we're going to be using them a lot in this course. Now you might be asking yourself, why are we learning this in this course? I mean, is it really that important? Yeah, actually, there are 3 must-do things now when starting a project, and you'll see it in every single project. One is that, well, they have an HTML file, CSS file, or JavaScript file. They might have multiple of these, but all projects have those, especially ones that are web-based. You also have to have your project on GitHub and use source control like Git. Nobody stores their own project on their computer. They always have it with source control. And finally, you manage dependencies, which is packages that other people have written, with NPM using package.json file. So in this section, we're going to be working on this and finishing up our setup of how a typical project looks like. And we know how to do the first 2, right? Now in the next 2 videos, I'm going to show you how to start using NPM to download files and using package.json to manage those files. It is a critical part of a developer workflow. So I'll see you in the next one. Bye-bye. Let's talk about how we can set up NPM on our computer so we can start using it. If we wanted to learn React, well, React is actually a package created by Facebook that we're going to be using in the next section. We need to get it, and how do we do that? First thing we need is this. We need to download Node.js, which comes with NPM. You can see over here that the latest LTS, which means long-term support version, 8.9.1 includes NPM. And you have the version numbers here as well. So for Windows, you can install here, Mac here, anything else, you can use the source code as well. You simply click on your operating system of choice and you'll have your Node package installed. You simply click and it will install everything for you and take you through the whole process. It should be very quick. You can do it in less than a minute. Now, why do we need Node and what is Node is probably what's going through your head right now. And don't worry, we'll get through it. The simple version of it is that Node allows us to run JavaScript outside of the browser. I mean, up until this point, every time we wanted to use JavaScript, we either wrote it here in the console or we attached a script file to HTML and loaded the HTML file in the browser. As you know, each browser has a JavaScript engine, such as the V8 engine that Chrome has. But that was the only thing that was able to read JavaScript. Outside of a browser, we need something to read it, to understand it. And Node.js was created actually using the V8 engine that the Google Chrome browser uses to read JavaScript and run JavaScript outside of the browser. But like I said, we'll get into that later. For now, let's download Node.js, which automatically installs NPM for you. And don't worry, in the next section, I have resources for you to go through this step line by line, both for Windows and Mac, and also some troubleshooting in case you run into errors. Now, after you've installed everything, there's a simple way to check that everything is working. You just go to your terminal and you type in npm-v. And this should give you a version number. If that didn't work, well then go through the steps that I've listed for you and you should be able to get it. So you want to make sure that if you're watching this video and going on through the rest of the course when we're building our projects, we want to make sure that NPM, our version, is higher than 5.5.1. Otherwise, it might not work. And we also want to make sure that we have Node, and we simply do node-v. And again, we want to make sure that our Node version is higher than 8.9.1. Now, let's say that for some reason these are lower. Well, Node, you simply go to the website and they'll have the latest version for you, which should be fine with this. With NPM, if for some reason this is lower, you can simply run npm install npm at latest-g. I don't think you'll run into that error, so you should be good. Finally, while running through npm commands, which is what we'll use to download things, and I'll show you how to do that in the next video, you might run into some permission errors where you're running a command like npm install React, for example. When you press enter, you might get some permission errors. In that case, that means that your user, whatever you're logged into to your computer, doesn't have permission rights. Maybe they're not the administrator of the computer. In which case, you'll have to run these commands as the administrator, which simply means running sudo npm install React, and it'll ask you for your username and password. Again, I have links to this after this video. If you're on Windows, there's a different command than sudo. Again, both found in the resources after this video. All right, so we have npm and node installed. Everything looks good. How can we start using npm and even getting that package.json file that I keep talking about? It's very easy. All you do is npm init. And anytime you start a project, you want to do the npm init, and this command creates a package.json file in your directory. So we have the background generator here. You'll see that after I run this command, it'll ask me a few questions, and then package.json file will appear here. Let's go through it. And you can see over here, it's going to walk me through the setup. I can name my package if I want. In this case, I'm just going to keep pressing enter because unless you're publishing an NPM package, you don't really need to worry about it. So I'm just going to keep pressing enter, but you can see I can add a few things about the author, the license of the project. I just keep pressing enter. And I don't know if you noticed, but if I clear here and on the left, look at that. We have package.json file. Let's open it up. I'm going to minimize this a little bit so we can see it clearly. And we have package.json. There you go. We have our name, background generator. It's version 1.0.1. Main is script.js. It actually finds out where our main JavaScript file is. And we have a couple of other things that we'll go through in the rest of the section. But one question you might be having is, what is .json? Up until this point, we've had .html, .js, .css. Well, JSON is a file format. You can see over here on the right-hand side at the bottom that Sublime Text says this is a JSON NPM file. It's just a format, and it looks kind of like a JavaScript object, except for the fact that it has double quotes for properties. All right, with this comes a lot of power, so I'm excited to show you what we can do with this. I'll see you in the next one. Bye-bye. Hey there, this is Andre from the future. That's right, you just watched a video of me installing Node, but now we're in the future and the Node versions are now higher. Based on when you watch the video, this might be even higher, where the LTS release is probably this version. So what can you do here? Well, it doesn't really matter, right? I said in the previous video that as long as you have a version higher than this, everything in this course will work. But let's say you're coming back to this video, or just in general, you want to keep your software up to date. And you decide that I want to get the latest version of Node because this latest version of Node has the best, most up-to-date features. Let's say we go back to our terminal, and in here I check my Node version. I see that I have version 9.6 now. And this version 9.6, well, it's definitely lower than what the latest is. Once again, if I do NPM version here, I get 5.6, which if we look at the homepage and maybe the downloads here, you see that it includes NPM version 6.9. So if I go to the homepage here, it'll actually automatically detect what machine you're on. Or you can go specifically to downloads and download specific to your operating system. Now, let's go through a process where we update our Node version. All we need to do is click on this, open up the package, go through the installer. Let's continue. Yes, we agree to the license. And let's close. Okay, so let's go back to the terminal here and try Node-V. Well, all I have to do is close my terminal and open up a new window. So in my case, I can just open up a new window. Let's make this a little bit bigger. If I now do Node-V, check that out. I have the latest version of Node. If, once again, I do NPM-V, I have the latest version of NPM as well. Very, very cool. Now, based on your machine, you might encounter some issues, so I will leave some resources for you to actually help you along. For example, if you're just installing the latest version of NPM, there's a way to do it, as I've shown you before with OS X and Linux. And then for Windows, there's a separate way of updating things. Again, if it's just the NPM you want to upgrade, and they actually have a couple of nice links of how to do it step by step. But I'm only showing you this because in the future, in your projects, you might want to upgrade some of your tooling. If you're watching this video right now and this is your first time downloading Node, then most likely you have the latest version anyway, so you don't have to do anything. Lucky you. Welcome back. Let's start using NPM. I wanted to go over one more time exactly what's happening underneath the hood. So now that we have a package.json file, we're able to grab whatever packages we want from NPM. In the next section, we'll be grabbing React, again, a JavaScript library that we'll be using. And that file lives on NPM. So using package.json file and the newly found NPM command, we can grab React and have it as part of our project. So let's get started. I'm going to minimize this. And because we're using React in the next section, I'm going to show you two other packages that I really like at NPM. One is called LiveServer, and the other one is Lodash. I'm going to be going through each one of them so you know what they are, but I picked these two because they're actually different in the way that you install them. For example, with LiveServer, I have npm install -g LiveServer. Okay, that seems fairly easy. And then with Lodash, if I go to the npm registry, I see that it's npm i-save Lodash. Well, npm allows you to install things two ways. One, globally, or two, locally. What does that mean? In our project here, our background generator, if we install something locally, that means npm will install a package that is only able to run in this folder, in background generator. But if I download it globally, and that is what -g means, well, I can use LiveServer outside of this folder, anywhere on my computer. As the name suggests, globally means you can run it everywhere. And usually globally means you can run it on your terminal. So remember that. If you install it with -g, that means it's going to give you a command that you can run in the terminal. If you don't install it with -g, if it's locally, then it will give you powers such as new abilities in the JavaScript file. Let's actually go through this to demonstrate this point. I'm going to install LiveServer by doing npm install -g LiveServer. And again, every time you install on npm, it's the same thing. You run npm install and the package name. Because I want this installed globally, I'll do -g and I'll say LiveServer. It's going to run through the install here. And there you go. We have what's called an EA access permission denied. Remember what I said? If you don't have correct permissions, you might have to run with sudo. Well, this is what it's saying. It's saying my user doesn't have access to install. You need to have admin permissions. And that just means you'll have to enter your username and password. You can fix this on your computer after this, but for now, you can run sudo npm install -g LiveServer. And you see it asks me for my password. And there you go. LiveServer has been added. Let's clear this. Okay, so if I look at my package.json file, well, nothing has changed. And nothing should, because we installed the package globally. It now lives on our computer, but not inside of our folder, as I mentioned. But we have a cool ability now. We can run a command. With LiveServer, you can actually read through the documentation here. But what it allows us to do is if I type in LiveServer while I'm in the background generator folder, did you catch that? It automatically loaded our background generator project. What is happening here? Well, We see over here, Live Server creates a server, a fake server for you, and it watches for changes. So that if I go now to, let's do CSS, and I'll do text align left, and I save, Live Server detects the change. It says CSS change, and it automatically changes this without me refreshing it. Remember how annoying it was every time I changed anything on our project, we had to hit refresh to make sure that the changes work? Well, Live Server creates a server that keeps watching your files, and every time a change is made, it sees it and updates the project. And you see over here that we have 127.0.0.1, and then this is port 8080. And this is the default, what we call local host. It's something that I'll talk about later on in the course. But as you can see, it's just saying you can open this test website at this address. If I actually type in here localhost, which is your local host, you're the server, it's the exact same thing. How cool is that? I'm going to return this back to the way it was. And again, changes detected. As soon as I save, everything is restored. So Live Server is really cool. In the next section, I'll show you something even nicer than that. But again, a really, really great example of why NPM is great. I was able to install something really quickly, and now I have a server, which is my computer, that is watching these files and serving up my project right here on my computer. We didn't need to buy a server. We didn't need to put it on GitHub. Everything is here already. Now that we've done that, let me just close this. I'm going to clear this. So that was a globally installed package. The other type of package that you can install is local, as I said. And with a local package, we can install something like Lodash, and it's actually one of the more popular libraries. Now, for those that don't know Lodash, you can think of it as an extension of JavaScript. With JavaScript, we have all these methods that come with it. We have, query selector, we have get element by ID. But wouldn't it be nice if we had more functions that we can run? Well, Lodash has a whole bunch of them that you can use. And if you go to the website, if you go to documentation, you'll see that they have all these things that you can do with an array, and they have really good examples as well. So anytime you have an issue, Lodash is really, really good instead of maybe writing your own. I don't want Lodash to be on my computer. I just want it just for this project. So what I'm going to say is I'm going to say npm install Lodash. And I'm going to open up the package.json file to see if it changes while we do this. I'm going to press enter. Now, if I go into my Sublime text, we see that package.json just added a new line. It says dependencies, Lodash, and this is the version of Lodash that we've downloaded. And another thing you might notice is that we have something called Node Modules folder that was just created. What does that mean? If we open this, we see that Lodash is installed. And oh boy, that's a lot of files of Lodash that we just installed. You see, as soon as we do npm install, then package name, if it's locally and we have a package.json file, since we did npm init, it will add it to our dependencies, which means packages that our website needs to work. And the way it finds these is that all these packages live under the Node Modules folder. And you can see that Lodash is here, and now we can use all of their new methods. So let's give it a try. Let's see if we actually have Lodash working in our JavaScript. I'm going to open up script.js, and the way we want to get Lodash in here, there's a few ways. One, it shows you the way to do it in Node.js, but we're not using Node.js. So if you remember with modules, we can just do import without, which is a Lodash function. I think we can see it down here, without.js. And I'll just say from Lodash Let's close that. And just to check that we have Lodash working, I'll just do console.log without. I'm going to save. And you know what? Let's start up live server because it was working nicely for us. Let's open up the console. Uncaught syntax error, unexpected token import. And if I actually do import here, yep, the console doesn't recognize import because, as I said before, it's a new syntax that browsers haven't gotten around to actually implementing. So it looks like I have to use the require syntax. And you might remember this syntax from this video where we talked about moduling in JavaScript. And we discussed that ES6 and this thing called Webpack is what we use now. But that's for the React section. For now, we want to be able to use require. And the way we're able to do that is browserify. Luckily for us, we have something called NPM that we can install a global package. So I can do install global, and there's browserify. And again, I have the access error, so I have to do sudo npm install g browserify. Let me clear that. Everything's installed. Again, import syntax, which comes from ES6, we're able to use that with Webpack. But because that's for next section, I want to show you what we did before this. We used something called browserify, which allowed us to use this require syntax. So let's copy this the way they have it in NPM. And now I'm going to say console.log underscore. But this won't actually do anything. If you remember, this is a module bundler. And it's a global package that we installed. We give it a script file, and it outputs another script file that we can use in the browser. The command for that, because we installed it globally, we can use browserify now. And I can say that my script.js file should be bundle.js. Did you see that? We now have a bundle.js file. If I click on this, well, I have a whole bunch of things. It looks like a big file. And that's because we included Lodash. It has created for us a bundle file that adds what we wanted so that the browser understands it. We simply go to index.html file, and instead of the script.js file, we'll do bundle.js. I'll save. And let's try this one more time. I'm going to do live server. Open up the console. There you go. It looks like it's working. If I go back to my script file, with Lodash now in my project, if I had an array, let's call it variable array that has 1, 2, 3, 4, 5, 6, 7, 8. And I can use a Lodash method that is without, and I can do console log answer. And within here, we'll say Lodash, which is the underscore. We've assigned the underscore variable to Lodash, as the library suggests. And we'll give it without, which again is a method that comes with Lodash that you can check on their website. Within here, I will put my array, and the second parameter will be what I want it to be without. So let's say I want it to be without the number 3. In that case, I save this. Change has been detected. I open up the console and refresh. But you see, we don't see anything here because, again, we need to put it into bundle.js. I know it's annoying, but this is good practice for us to understand how all of this works. So again, bundle has been updated, And now I can run my live server, open up console, and look at that. I have an array with 1, 2, no 3, 4, 5, 6, 7, 8. So I can use Lodash. So looking at this, you might realize why NPM is called Node Package Manager. Because it was initially created for Node, which accepted this require syntax, but not for the browser. Browserify allowed us to use the syntax, the require syntax that was used in Node.js on the browser. All we had to do was input our script files into Browserify, and then it outputs the bundle for us. Very cool. All right, that was a lot of hoops to go through to show you a few things, but you have some really, really good context of what we're trying to do here. We've set up a system now where we're able to import all these different things that other people have written to make our code better. But you might notice two issues with the current setup. One is the fact that I'm only using this without method that comes with Lodash. But if I look in the bundle.js file, well, it's massive because it's included this entire library. And that is something that you want to be careful with. When you're working with NPM, a lot of beginners just start installing a ton of packages without thinking about how much weight they add to a project. It's a good idea to really assess whether you need that package as a team and add it to the project. If it saves you time, if it's really well written, if it has a big community around it, it's something that you always want to consider. The second thing is that now we have something called dependencies. That is, our project depends on these things. We need to make sure that our website and our app always has Lodash in a certain version so that it works with our website. It also adds that extra layer of complexity that you should consider. But package.json file also offers you a lot of great things. Maybe they're not evident right now because our project is fairly small. But when you start working on big projects, it serves as a great documentation for what packages your project depends on. You'll see that most big projects can have close to 100 dependencies. And having just one location, package.json file, to see all these packages, to see what the project depends on, is really, really nice for people that are joining the team. And it also allows you to specify the version here of your dependencies. With Lodash updates, I can also update my version just from this one line without having to go to the Lodash website, download the file, and add it into my index.html script file. Again, another thing is we're not adding these script files over and over and over, as we've spoken about before. Now, these numbers that you've seen before, it's called semver, and they each have a meaning. The rightmost number is the patch release. So that is, if there's any bug fixes, they will update it here. If they find a bug and they need to fix it, this will become 5. This one is the minor release. That means there's some new features that were added to Lodash, but there won't be any changes that are major. And then finally, this is a major release, which means this is a 4th version. If the 5th version of Lodash was released, well, that's a major release that might be quite different from version 4, and it might break some of the websites that depend on Lodash 4. Package.json allows you to really decide what versions you need for each of these packages. But probably the biggest benefit that you get with NPM, this project is much easier to share with other developers. I don't need to add script tags in HTML for these now. And for a developer, in order for them to download all the packages or the dependencies that a project requires, well, I will never put the node modules into my GitHub repo because all you need is the package.json file. Let me show you what I mean. If I delete my node packages here, and let's say somebody new started at the company and we want to make sure that they have the latest version of the project so they can start working on it. Well, even though there's no node modules, because we have package.json file, NPM is smart enough to say, let me clear this, or let me stop this server, and I'll clear. As long as the new person does npm install, and there is a package.json file, well, in that case, all of the dependencies get downloaded. So right away, they can start the project with the exact same version of all the files that everybody else has. And that's why you won't see any node modules folders, which can get really, really big, on GitHub, because we don't need it. We have it all described here in package.json. Now, one other thing. There's actually another type of dependencies that you can have. These dependencies are what background generator depends on. But there's another type of dependency called dev dependency. And a dev dependency are packages that are only needed for development and testing. So it will never be shipped to a website so that an end user can see. And you can do many, many things that, again, we'll get into the React section, but we'll have a separate section called dev dependencies here that will have different things that only are used for the developers, but are taken out automatically when we release the product so that it doesn't add too much weight to our project. Okay. I promise this is the last thing. Let me clear this. If I now run npm run test, so the syntax is npm run, then whatever the script says, in this case test, I get echo error, no test specified. Now that's actually what is defined in here. NPM scripts allow you to do commands from package.json file. Let me show you. Remember how annoying it was that we had to do browserify to do the bundle? Well, in here I can say build, and within this section, let me make this bigger. Within this section, I can say browserify script.js to bundle.js. And I can run these scripts, a build script that automatically runs this in my terminal. Let me show you. If I save here, let me clear, and I'll say npm run, and then whatever the name of the script is, build. Look at that. I've just updated browserify, and it runs the script. Very cool. Well, what if we also add the live server command to it? And live server. If I save and run the same command again, look at that. I have my array displayed, my website's running, and it does all the commands right away from my terminal. How cool is that? All right. I think that's enough for NPM. It is a very useful tool. We're going to use it a lot, and you will use it a lot in your day-to-day. And you will get more comfortable with it the more you use it. In the next section, we're finally going to get to building a real-life app with React. We're going to use some of the knowledge that we've gathered up to this point. We now have a complete view of front end. Although you may not feel extremely confident, you'll see that we've gotten to the point where we can build really, really nice apps and websites. We have all the tools in our arsenal now to create some amazing things. So I really, really look forward to the next section with you. I'll see you in that one. Bye-bye. Welcome back. Now, we're going to get started on React and learning React and building a project around React in the upcoming videos. But I do want to mention one thing. That is, at the end of the videos, we're going to build a project, a RoboFriends project, and we're going to put it up on GitHub. Now, you don't need to worry about all the files that are in here, but you will notice that there's a package.json file. And this package.json file we've seen before has some dependencies with some versions of libraries and tools that we use. And we've talked about this before, right? This is what NPM allows us to use this package.json file. But I want you to pay attention, because when you start doing the project and we install React, your versions are going to be different. For example, the version we're using for React is 16.2, which is actually outdated. Because a library is constantly evolving, new fixes are being made, new features are being added, new security issues are being solved or fixed. So this number is constantly increasing. Now, when you watch the videos and you follow along, you'll have the latest version of React. And your projects are going to work, no problem. But at the end of that section, when we build everything, I'm actually going to go back and upgrade and show you how I would do an upgrade so that we keep our projects as up to date as possible. Now, why would we care about that? Well, if I go to my RoboFriends project, which I'll link to when we finish our React project, if we go to security here, you'll see that I have 0 opened alerts, but there's 24 closed ones that I actually closed myself. And if I scroll through, it shows me how many security issues I have in this project. You see, one of them is high severity. One is critical severity. That's not good, right? And sometimes when you look through GitHub repositories, you might see a warning like this. Hey, we found some potential security vulnerabilities in your dependencies. That is, in my package.json file, I have some libraries that I've downloaded or that I'm using in my project that are now outdated, that I should upgrade because there's been some security updates. Now, if I click on something like handlebars, you'll see that, we need to upgrade handlebars to this version or later. So essentially update it like this to fix an issue. Now, GitHub is nice enough to actually do automated security fixes. So if I click on this, it'll actually make a pull request to my project to update these things. But we're going to save that until the end of the project so that you can actually see how the project is set up and how we can keep projects up to date and also secure. So don't worry if this lesson is a little confusing. We're going to come back to it. I just want to prepare you that when we build our project with React, we're going to be upgrading a bunch of the things later on at the end of the project just to show you that process. Now, the last thing I want to mention is this idea of the semver, which we talked about, which is the versions of packages. You see over here that I have the Lodash package, and I'll link to this resource that you can play around with. Let's say I wanted to download handlebars, like we see over here. So if I wanted to check out handlebars, I see the handlebars package, all the versions that it has. Now, if I go to the handlebars vulnerability, it tells me that I should upgrade handlebars to this version or later because there's some security issues with the older version. Well, I can just copy this version, and if I go over here and enter the range, it shows me exactly which packages I should be downloading or have in handlebars. Now you see here that I have different symbols that we haven't seen before. And if I go down, it actually tells me that it specifies a range of stable versions. So this just means, hey, download anything greater or equal to version 4.0.14. If I do the caret symbol, which we've seen before, and I hit enter, I get the same thing. But if I change this to, let's say, version 1, I see that with the caret, I get all the versions that are within version 1. But if I change this to greater than or equal to, you see that I get versions 1 and above. So I'll leave this resource for you to explore. Again, it's something we don't have to worry about too much right now. But I want to prepare you to start thinking about these things, because when I first got it started, nobody told me about this idea of updating packages. How do you update them? Why do we update them? But this is a good practice that we will encounter. I'll see you in the next one. Bye-bye. All right, everybody, we have a really exciting video here because we're going to build our own portfolio page. That's right. We're going to build this so you can showcase your projects to your future employers and just have a place to put your projects that we're going to work on throughout the course. Again, to impress that special someone or your future employer. Now, this is actually very cool because this page was built by a fellow student. This student actually finished the course and went on to create this project as a way to say thank you to the developer community that he received so much help from. And it's called Simple Folio. And we're going to use this project as our base for our portfolio. Now, I'll link to this repository so you can follow along and you can customize your own portfolio. And as we go through the course, you can actually add the projects as I'm about to show you. Now, one thing I do want to say is that this project is MIT licensed, which means that you can use it freely for yourself and customize it to your liking. I'll show you how to do that, but I do want to acknowledge the fact that this student put in a lot of effort to this, and it's actually quite a nice project. So I do recommend, if you have just 0.5 seconds, going to his project and clicking on the star to show some appreciation. All right, enough talk. Let's actually build our portfolio. I'm going to clone this project. I'm going to use SSH, but you might have to use HTTPS depending on your GitHub setup. So let's clone this repository. I'll say git clone and clone the Simple Folio project. I'll cd into Simple Folio and I'll open this in Sublime. Now don't get intimidated by all these files. There may be things here that you haven't seen before. Again, we'll cover most of these throughout the course. But luckily for you, this project actually has a really nice getting started guide. So let's go step by step. We've cloned the repo. We've cd'd into the repository. We can run this command if we want to remove the origin repository. That means if we had forked the project, which, by the way, if you want, you probably might want to fork this project. In my case, I just cloned it because, well, this is just for demonstration purposes. But you can actually run this command to remove this original project so that you only have your own copy, your own forked copy to worry about. Because most likely you won't do any pull requests to this original project. You can just have your own version. Next, we run npm install. So let's do that. Let's say npm install. And while that's being installed, let's go next. And it says we just have to run npm start. And it gives us a couple of commands if we have any issues. But hopefully things go well. We can just run npm start. Let's clear this and say npm start. Hey, look at that. There's the portfolio. Very, very cool. Just like that, we have our template for our portfolio. Now, if we go back, we'll see that we have template instructions here. So it actually tells us exactly what to add, and we have enough knowledge now to be able to understand this, right? So it looks like we can change things in the template.html and change the hero section, which is the main section, with our hero title and hero CTA, which means call to action. So let's do that. Let's go to the source folder into the templates.html. And then, well, we can change the title here to my name. And then in the hero section, right over here, we'll change hi, my name is to your own name. I'm the unknown developer. Let's call this the I'm the developer you need. And then the hero call to action, instead of no more, we'll just say hire me. Sounds kind of desperate, but it's fine. All right, so just by saving this, it's going to detect the changes. And if I go to our project, hey, look at that. I have my name here. I'm the developer you need. And it says hire me. Awesome. Next up is probably the About Me section. Let's go here. In the About section, once again, there's a nice README, so we can just replace our p tags with whatever descriptions we want. And we can also change the image so that we have our image in here. Now, in order to do that, all we need to do is to change the profile picture in our assets folder. So if I go to the assets folder, I see that there's a profile PNG here that we just need to replace. Now, if I open up the project here, if I go to source, the assets folder, I actually already have my picture. So I'm just going to paste this picture in. I'm going to replace it with my own profile PNG. So that now, if we go back, we have my giant face here. And check that out. There you go. I have the About Me page. I can even attach my resume if I want. And now let's go to the projects section. Ooh, and the project section is quite nice. So we can attach source code. We can see live. So we can maybe attach a GitHub page link here, our own website. So let's say throughout the course, we build projects and you want to showcase your project. So we have the background generator project that we've created already. But let's say in an upcoming section, in the React section, we're building a project called RoboFriends. So let's say we just created the RoboFriends project, which is right over here. And this is something that I'll link to when we finish that section. And we'll have this exact setup. And let's say we want to showcase this project on our portfolio. Well, if we go to the instructions, once again, we have a great step-by-step guide of what to change. So we just need to go to the project wrapper section. So once again, go to our template, scroll down past the About section into the project section. And here, each row is a project. So let's make this a little bit bigger. We have the project title, which will replace this with RoboFriends. We don't have to change the description right now. And then we can link to the live version, which in my case, it's right over here. Again, I'll show you how to do this during the React section of the course. But I can just change this to href like this. And the source code will just be this repository. So once again, copy and paste like that. Now, the last thing we need is to have an image of our project. Now, I want to show you a really cool resource, which is this logo maker. And I'll link to this resource. It's called Hatchful, and we can actually create logos for free. So let's just click Get Started. We'll build a tech logo, but you can pick whatever you want. And let's say we want an innovative logo. All right, let's click Next. And I've done this before, so we can call our project RoboFriends. Let's do a capital R. Actually, no, let's leave it like that. And the slogan that I chose is the only friends you need. So if I click Next here, let's say what the logo will be for. It'll be for an online store or website. Click Next. And check this out. It's going to generate some logos for us. And they all look pretty cool, right? Let's see which one I like best. We can pick whichever one. I like this one, so let's do RoboFriends over here. I can include the slogan if I want, but let's just click through next and you can download the logo. Now, in order to download and get the logo for different things like Facebook profile image, Instagram profile image, you'll have to create an account, but again, it's free, so you can still use it. In my case, I already created an account and I have this image downloaded. So all I'm going to do is replace, again, in the same assets folder as before, replace the banner with my own banner, which is the logo that we downloaded. So again, if I go back to the project, everything should be working. Let's go to our portfolio. Hey, look at that. That is awesome. There is my project. If I go to See Live, there's my RoboFriends project. Again, something that we'll build together, so I can search all my friends. And I can even go to the source code of my GitHub profile page. And notice here that the projects all have the same image now. That's because in the code, all the images point to banner.png. But as you can imagine, by just changing the name to different logos, you'll be able to have multiple projects on your profile. How cool is that? And you can have different things like call to action. Again, we've looked at getting an email subscribe form. If you want, you can link to your GitHub profile, your Twitter account. And we have a pretty nice project just in a couple of minutes. How cool is that? Now, if we go to the documentation, you'll have different things like the contact section that you can update, the footer section that you can update. But the last thing I want to do is this styles. That is, you can adjust the styles of this project by going to the styles, abstracts, and variable.scss. This is actually a file format for what we call Sass. It's kind of like CSS, but it gives you extra features. So let me show you what I mean. You see here that I can change the default colors. So if I click on this link that this document provides, it gives us a couple of UI gradients that we can use. So I can actually just copy this, and you might see that this is quite familiar to what we had before with our background project. But if I copy this, go back to the documentation and change the default values. So that is, if we go to the styles, the abstract, and then the variables, we can change the primary color and the secondary color of the gradient. So let's just copy what we just copied from that gradient website. And this is where the Sass files come in handy. You see, with Sass files, you can do something called variables, like this, using the $sign notation. And now, anytime in the Sass file, when you use the word primary color, it's going to be replaced with the actual color. So it's just extra little boost that you get with CSS. Again, something that we don't need to worry about. All you need to know is that you can change the colors over here. If I now save and go back to my portfolio, hey, look at that. The colors are all different. I get that blue color, still get that nice gradient, and I've made this portfolio even more personal to me. Now, I'll leave the rest up to you. This is just a way for you to get started and keep track of your projects as you go through the course. And on top of that, there is also a step-by-step tutorial for deployment. So you can actually deploy this project to production using something called Netlify and make it really, really easy to share your project outside of just on your local host. Again, that is something for you to explore and do on your own. But for now, you should have a nice starter template of your project. Pretty awesome, right? Now, the last thing you should do is, once again, thank the student for the work that they've put in with Simple Folio by giving it a star, fork the repository, and once you're done, go to our Discord channel And if we go to Look What I Made channel, you can share your portfolio with others, or you can thank the student that actually created this, which has this handle. So let's just say, thanks for the simple folio. We're recording right now and using your project. Pretty awesome. There you go. Your own little portfolio project to get you started. I'll see you in the next one. Bye-bye. Good job making it this far. Things are going to get more and more fun starting in this section because we're now learning real tools that real companies use and that will get you hired. And development also becomes a lot faster because we're using these tools to make us build websites faster and better. So let's talk about React. What do we have before React? Well, as I've mentioned before, we had jQuery. jQuery was, as you remember, very imperative. Writing code was like mixing ingredients sequentially. If this happens, then do this, and then do that, but also if this happens, then do this. And it created a lot of inconsistencies. And if you remember the DOM manipulation section, well, that is really, really difficult. And constantly keeping track of what changed and what to change is a huge mess. And it creates for very slow development. And as your website gets more and more complex, it becomes very, very hard to scale, which means it becomes very hard for teams of developers to manage it. Now, React was created at Facebook. As you know, Facebook is a pretty big app. And a lot of things need to happen for it to work well. And they had this problem. And they created React as a way to solve this issue and be able to have a tool that allows them to build websites in a nice, predictable way that you can have multiple developers working on it at the same time. And I like to use the analogy of a bread machine. Using React is kind of like that. You just throw in the ingredients and React does all this magic underneath the hood and puts out a website. So it's very reliable and very consistent. And it does one thing really, really well, and that is the view. It manages to make our websites, the DOM, change in predictable ways that is easy to scale and easy to manage. And the beauty of React is that because it's just the view, it doesn't necessarily mean it's only for browsers. As a matter of fact, React can be used with mobile devices to build native apps. It's used in virtual reality apps. You can build desktop apps with React. Anywhere that has a view, well, React can use it. And big companies, as I mentioned before, Facebook and Instagram use React, and Netflix uses React. Whenever you browse through movie choices, well, that's using React underneath the hood. It's a very, very useful tool and in very high demand. So I'm excited to talk about React and teach you this valuable skill in this section. Now, in order to understand React, there's a few things that we want to go over. And these are principles that are very valuable that have been learned over the years by developers. One is the idea of thinking in components. Up to this point, we've just built websites. Everything is just one JavaScript file, one CSS file, one HTML file. But wouldn't it be nice if the web was a network of these small components? Think of them as Lego blocks, where everybody builds a specific Lego block, and you just combine these Lego blocks to create your website. That is the idea that React established. Let's use this as an example. You first have atoms, which, as you can see here, are icons and little small indivisible elements on your website, such as images, there's some text, and you divide these into atoms. From there, you form molecules or combine atoms that have similar functionality, such as the navigation bar down here. You combine individual atoms to add some functionality. And then you have organisms, again, a little bit bigger than molecules that combines to a bigger scale functionality. And then finally, you have templates, the combination of these organisms to give you an idea of how your app or website should look. Finally, you have your pages, that is, the page of your app. And if you think in components, as this image demonstrates, well, you're able to build small little components that you can reuse and put on different parts of the web page. For example, this back button here. If I build a React component that is the back button, I can now use it on multiple pages and I don't have to rewrite the code. If I wanted the navigation bar to be used in different areas of the app, well, again, I don't need to rewrite the code. I write it once and I can reuse it. As a matter of fact, I can even share it with the world. And this idea of components makes React amazing because right here I have a website that has React components built by somebody. And we can reuse these. And it's not just CSS and HTML, but real functionality, such as navigation bars and sign-in forms. I can just download this React component and attach it to my website. And because of the way React is structured, it doesn't really need to know about the rest of the web page. It's just its own Lego block that works by itself. By reducing dependencies on other parts of the website, I can just plug this anywhere I want. Another important concept with React is the idea of one-way data flow. The best way to describe it is by looking at this tree-like structure. In here, you see that we have a parent, some children, and then those children have their own children, and those children have their own children. And the idea with React is that data flows from top to bottom and never the other way around. That is, if these red, let's call them components, change, well, in that case, only their children know about the change. The parents don't really care about the change because, well, the direction of the data flow is just always downstream. So if we go back to the idea of components, if we had a website built on components, and this was the page, and these were organisms, and then molecules, then atoms, well, in that case, the red components change, and then only the ones below it, as you can see here in blue, know of this change. And based on that, they will act accordingly and change as well. Now, without actually having a problem, it's hard to understand this concept, but trust me, this is a very important concept that React brought in. It creates a lot of really nice bug-free code. And it is an idea that you'll understand more and more as we start to code in React. The next thing is the idea of virtual DOM. You know what the DOM is, the document object model. And we also learned that one of the most important things as a developer is to minimize the amount of DOM manipulation that we do because, well, web browsers have to work really, really hard to achieve that. And it reduces the performance of the web page plus increases bugs. I think this image demonstrates what React does really well. Beforehand, we were the painters. We told the DOM exactly what to do. Remove this element, then put this in, and then also add this and color this way. With React, we have this React bot. And the React bot creates something called the virtual DOM. Virtual DOM is just a JavaScript object. And this JavaScript object that just describes our website, the current state of the website. And we just give it that object to React, and the React bot will automatically make changes to the DOM and paint the picture in the most optimum way possible. So we just tell it, hey, this is the object, this is what we want in the DOM, and the React takes care of DOM manipulation for you. Remember how annoying it was to do query selector all, then grab elements by ID, and then doing all these event handlers? Well, React takes care of that. So again, the virtual DOM is just a copy of the DOM that's in a JavaScript object, and then React underneath the hood just changes the view. And that's why it's able to work outside of browsers, and you can use things like VR and mobile devices, because React is the machine, and what the canvas is on, well, we can change the canvas to whatever we want. Finally, React has a great ecosystem. It is probably one of the biggest ecosystems in JavaScript right now, and there's so many tools that work with React. As a matter of fact, the developer community is so big that any problem you have, there's most likely a chance that somebody else has had it and has posted it on the internet, and you can find solutions for it. You can find React packages in NPM. You can use it with Node. There's Webpack and Babel that you can use with it. It's just a really good ecosystem that uses the latest JavaScript technology to build websites in a really nice, elegant way. Now, one thing that I want to warn you about. In this section, we're going to see code like this. And it's going to look very strange at first. It's like the same way when you looked at JavaScript the first time. It seemed like a whole new different world. It will when you first look at this. But trust me, knowing what you know about JavaScript, this becomes really, really easy. You have classes that extends the React component, and this is how we build components. We have constructor, again, that we've seen in advanced objects. And then each class has a mandatory render function that you just tell it what this clock should render. And as you can see, it looks like HTML, isn't it? It's not exactly HTML, but the syntax is very similar. So even by looking at this, you see that this clock component, again, this logo block, just returns a hello world h1 tag with an h2 that says it is, and then the time. Again, just to give you a heads up, you're going to hear words like props and state and React components, but these are just language syntax that you'll learn. And it's actually quite easy once you get used to it. So don't worry, this is all going to make sense by the end of it. And you know what? We're going to be building a pretty cool app. It's called RoboFriends. And we're going to build this app that, well, searches through your robot friends. And you can find their contact information. And as you can see, it updates live. It's super fast. It's responsive. It's going to be a lot of fun, and we're going to build this pretty fast just to show you how powerful React is. All right, I'm really excited to get into this section. You're going to have a lot of fun. I'll see you in the next one. Bye-bye. Oh yeah, it's time to create our first React project. Now, I have excellent news for you. You see, up until now, we've created everything from scratch ourselves. But you see, React is one of the most popular tools out there for a web developer. So what does that mean? That means that there's an entire community of developers, of really, really smart people that want to make React a really good experience, a really good way for you to get started super fast and build projects, beautiful projects, right away. Let's see how a normal developer would start a React project. Now, we can do what we've been doing up until now, which is to npm install React, right? We create a project folder, we install the React package, and we are able to start using it. But there's something even better than that, and it's called Create React App. It's actually on their documentation page for React. It's a comfortable environment for learning React and is the best way to start building a new single-page application. It's the recommended way to start with React. And we're going to see over the next couple of videos why this is such an awesome tool. As a matter of fact, it has its own dedicated page. Set up a modern web app by running one command. Sounds pretty nice. It essentially allows us to install a whole bunch of packages instead of doing npm install 1,000 times, instead of setting up our developer environment, setting up our first page. It does everything for you. And this is created by really, really smart developers that have worked on React, that are on the core React team. So that this way, you know you're using the best tools, the latest tools, and using the best practices when creating a React app. And this gets updated constantly, so you know that you're using the best of the best. Now, if we go to the documentation, we see that we simply used this command, npx create React app, and then the name of your app. So let's copy that. And let me just explain the command for you. Now, before, you might be wondering, what is npx? npx, we've never seen that before. I mean, back in the day, what we would do is say npm install -g create React app. Install create React app globally so we can run the create React app command from our command line. But doing an npm install -g is a little messy, and also you have that thing where you have to run sudo if you don't have enough access. Well, since npm 5.2, npx actually comes out of the box for you. So for example, let me just clear this. If I do npm-v, your version should be higher than this. And if your version is higher than 5.2, which trust me, if you're watching this video now, 5.2 is an old version, you definitely don't have it. Otherwise, you can always upgrade. So npx actually comes out of the box already. So again, if we copy this, we can use npx create React app and my app. Actually, let me cancel that. Let's name our project, because we want to have a proper project name, Robo Friends. And I'm going to create the React app. Now, while this is loading, you can see it's installing React, React DOM, React scripts. We're going to talk about that later. For now, you just need to know that npx is a package runner. I'm going to leave a resource for you in this video that you can read more about npx. Essentially what it does is it allows us to run this command of npm installing globally the create React app without actually having to install something globally. While we wait for this to download, let's just find out what npx is. npx, what is it? You know, as developers, we're really good at Googling, right? Oh, there you go. There's an excellent article. We have npm, the node package manager, the package runner. So it's a CLI tool whose purpose is to make it easy to install and manage dependencies hosted in the npm registry. So it's now very easy to run any sort of Node.js based executable that you would normally install via an npm. Executable means a package that you can execute. What does that mean? Well, it's this thing. We can execute create React app. Back in the day, we would have done npm install -g create React app. Well, we can execute this create React app command that we would have been able to execute from here after doing this, now just by using npx. Just a simplified way of doing things. So once that's installed, I then go into my folder and then run npm start. Sounds pretty easy, right? Let's go back to our terminal. You see that everything has installed here. We have npm start, npm run build, npm test, npm run eject that we can use as commands. Well, we can just run npm start, right? So let's go cd robofriends because we want to go into our new project folder. If I do ls here, check that out. We already have all these things out of the box created for us by create React app. We have a no modules folder, readme, package.json, some public and source files folders. Again, something we'll go over later on. For now, let's just do npm start. Let's see what happens. Hey, look at that. Congratulations, you have your very first React app. Out of the box, you didn't really do much. You just installed create React app, but there's your first app. Pretty neat, right? You don't have to set up anything. Create React app takes care of it for you. So again, if we go to the create React app documentation, you can read more about it here, but the idea is that the best of the best are creating these tools for React developers so that out of the box, you're going to have linting, testing already set up. Again, things that we'll cover later on in the course. You'll see why create React app is useful more and more as we progress through the course. So don't worry. So we have our app. What do we do now? Well, we open up our editor and we start evolving this simple React app into what we want, into RoboFriends. So let's start doing that in the next video. Welcome back. So I'm back in my text editor and my terminal. We have the RoboFriends app, and we haven't really done anything but install the Create React app. So let's go to package.json and just see what it actually did for us. Let me just make this a little bit smaller. So we have package.json that's set up, and the thing that we really care about is this scripts. You see here that I have a couple of commands, the start, the build, the test, and eject script. And all of these run the command React scripts start or build or test or eject. So what is this? This is what Create React App is. Create React App is this React scripts. And when we ran the command inside of our Node modules, you'll see a ton of packages that installed for us. Actually, it's quite a lot, isn't it? So if I scroll all the way down, holy moly, that's a lot of packages. You see that I have a React scripts right here. And this is where the magic happens. In here are the scripts like build, eject, init, start. All these things, this massive file is being run through here. And this is what Create React App provides. It provides us a couple of commands plus all these packages for us to use to have a really nice developer environment. So we're able to run things like NPM test to test our project. And you'll see here that it will run a test for us. So if I run A, it's going to test our app.js file. And look at that, we have one passing test. Again, we're not getting into testing, so we don't need to worry about that. But you see here that we have this out of the box. Another cool feature that we have out of the box, again, let's not worry too much about what this is. I'm going to go over in detail what this file does. But let's say app.js, where our app is. Maybe I messed something up. Maybe instead of return, I'll say return, and I spell it wrong. If I save this and I do npm start, let's run our app. We get, line 5 in app.js, return is not defined. And even in here, I get return is not defined, line 5 in app.js. How cool is that? I get that out of the box. So let's say I fix that. As soon as I save, okay, compiled successfully, everything is working. So as I'm working on this file, let's say I mess something up. I keep getting these errors. As long as I run npm start, it's constantly running linting and checking in the background for me. How cool is that? Okay, let's get back to what we were talking about. So we have package.json. We have all these things that are happening for us. You see here that we have some dependencies. These are the things that were installed when we ran that npx command. So we have React. We have React DOM. We have React scripts, which is the Create React app. And then something called Web Vitals. So it installed a bunch of dependencies for us, as well as some testing libraries. Now we also have package.lock.json. And this is automatically generated by the package.json file. And it makes sure that the versions that I'm using right now of our dependencies, every single thing that you see in Node modules, it locks the version numbers so that if I send this project to you across the sea, across the world, you open this file or this group of files, it's going to work the exact same way because these version numbers are locked. So this package.lock makes sure that we can run this project anywhere in the world. And it's automatically generated every time we update package.json. We also have a README, which is a nice Create React App README that you can read through some of the things that we can do. Again, I'll leave that up to you. It's not important. We have something called gitignore and has a dot in front of it, which means it's a dot file. What this means, a dot file is a configuration file. And gitignore tells whenever we run a git command, let's say we're going to push this project to GitHub after we're done with it, before our git commands, it's going to check this and say, hey, I'm not going to commit, I'm not going to add, I'm going to completely ignore. I'm going to git ignore any files or folders that are in here. So for example, I'm going to ignore the node modules folder. Remember how I said we don't want to push that onto GitHub? Well, it's going to ignore that. It's going to ignore any other things that we have. It's going to ignore coverage if there's a testing coverage. It's going to ignore any random files or folders. So DS store is like a common Mac specific thing that people mistakenly upload to GitHub. So it just kind of has this niceness about it. So we can always add things in here that we don't want to push to GitHub. We have the node modules folder, which is where all the third-party libraries that we're using are. And then finally, we have these two important folders. One is public. This is where we have things like the favicon. So that is this little icon that you see here. That's the favicon. We have index.html. So this is the HTML page that actually renders. So we see here you have React tab. So React tab, this is the HTML page that gets rendered. We have some logos in here. We have manifest.json. It's a special file that if now there's new features on the web where users can download or bookmark your website and put it on their home screen or put it on their desktop as an icon, kind of like a desktop icon. Well, we can add those on here. We don't need to worry about that. We have robots.txt. Just some niceness that they've provided for us. We don't need to use all of them. All we really care about is this index.html. And the most important part is this div ID equals root. As you can see here, there's nothing inside of the body. Yet, on the page, we see this React tab, or at least some animation with some text. This div ID of root is actually where React grabs onto the HTML page. Now, where is this happening? This is happening inside of our source folder. So the source folder contains our logic, our app. As programmers, this is where we're going to work with our React app. Public simply has the index.html files and some assets, but where the logic lives, where we build our React app, is right here in the source folder. And inside of the source folder, there's something called index.js. And this index.js, if you see here, might have something that you recognize. Document, get element by ID, root. This root is exactly what we're grabbing here. That line says, grab this. And once we grab this, I want you to do something. What do you think that is? Let's take a cliffhanger break, and I'll see you in the next video. Bye-bye. Welcome back. Now, you just watched a video on the folder structure of React. And you might be wondering, hold on a second, Andre. I see something a little bit different than in your video. Well, if that's the case, it means that you installed React 18 or higher, depending on when you're watching this video. So I wanted to make a quick video to show you the process of how, as libraries change, you want to stay on top of it. Now, we actually have a couple of videos and exercises in this section towards the end where I show you how to upgrade your React app, and we actually upgrade everything to the latest version of React and show you the minor changes. But just in case you have questions right now, again, we're going to get to it later in the course, but let me just give you a small snippet on how, as a developer, you want to stay on top of changes of the libraries that you're using, in this case, React. So I've actually prepared for you two things. One is what you just saw in the previous video with the React DOM.render of our RoboFriends app. We have the React strict mode and the document get element by ID root. On the left-hand side, I just ran a npx create React app command and got this. which, depending on when you're watching the video, you might have this version versus this version that you see in the video. So why the differences? The key is in the package.json file. Again, if we look at the package.json file, on the right-hand side, we have this React version. And then on the left-hand side, we see that we have a React version that is 18 or higher. And that's why there's a difference. So what I can do is go to the documentation website, the React.js documentation, and see that right here, how to upgrade to React 18. Well, in React 18, the major change that we really care about is this updates to client rendering APIs. Again, this is something that we're going to practice in this section where you get to read the docs, see how you can upgrade your projects, and practice that muscle. But you see here that React DOM.render is no longer supported in React 18. Use create root instead until you switch to the new API. Your app will behave as if it's running React 17. Okay, it's telling us that we can no longer use React DOM.render. We need to use create root. So let's test our assumption. All right, so let's test this out. Let's say that I copied the old way of doing it. So it's telling me React DOM.render no longer exists. But what if I just replace it over here like we had it before and run this with React 18 or higher? If I do NPM start, and this is a newly created create React app command, so it's just my app with React version 18 or higher. If I do NPM start, I get nothing. And it says over here, yeah, look at that. .render is not a function. All right, so exactly what we thought is no longer supported. So the only change that we really care about, and again, we're going to have an exercise to update the code base later in this section, is we see that we no longer use React DOM.render. Instead, we do something called create root. And inside of this function, we do the document get element by ID, which is exactly what we do here. And then that, after we create the root, right here, that's when we can do the .render. So technically, we can just do this as well if we wanted to. So if I don't even declare a variable and I just do .render, this should work. Let me test it out. Look at that. Everything works as expected. Again, this is just important for you to realize that libraries are constantly updating. So your job as a developer, as a smart developer, is to always be on top of your game. And we'll work on those exercises of updating our code bases throughout the rest of the course. Easy peasy. I'll see you in the next video. Bye-bye. Welcome back. We just talked about this div ID equals root, where we only have this on our page, but somehow React grabs it and displays this. So let's figure that out. We see here that we have index.js. This is the entry point of our app. This is the first file. When we look at the HTML page, it says div ID of root. The first thing that we're going to do when we build our React app is we're going to look at the index.js. This is the first thing that is read by the computer. And in here, we see that we import React from React. So this is the React package that we need to, well, write React. We have React DOM, which what it does is connects the React package to the DOM. So that is the document object model of our browser, of our page. And the reason they're separated into two is because React can be used with anything. It doesn't have to be just for apps on the browser. It can be for mobile. That's what React Native is for. It could be for VR and virtual reality. So based on where you're using React, you need a package to essentially two packages for the main React library and whatever the connector is. We have index.css. So that is where we add all our niceness, all our CSS for our app. So you can see here, if I go to actually index.css, this is the CSS that applies to all or the entire page. And then we have import app from app. Now, this is right here. And we're going to talk about what this exactly is later in the videos. But as you can see here, what we're doing is we're using React DOM, and we're saying, hey, React DOM, the thing that interacts with the document object model on the browser. Use this method that comes with React DOM, and honestly, with React DOM, we pretty much just use this, render. And in here, I want you to render this. And what is this? The first parameter is, I want you to render this, put this on the page. The second line is this, put the above on the page in here, which is document. Again, document is something that comes from the browser. So document, get element by ID, root. So all we're saying is this, I want you to render inside of this div. And that's what we do. We grab the root and then React renders this part. And what is this part? This app that we import? If we go to app.js, well, this is what it is. This is what we see on the screen. Remember the image, the logo that's spinning? Well, that's right here. Remember the edit source app and save to reload? Remember the learn React? If we change that to learning React, we see the change right away. So what we see on the screen is contained inside of this app component. Now, this looks really confusing. I know. It's like a whole new world we've just entered, but we're just getting started. This is just a high-level overview. We still got a lot more to learn. So for that, let's take a break, and I'll see you in the next video. Welcome back. Does your head hurt yet? I remember when I first saw React code, I was really confused. It looked impossible to learn. It seemed so different from what I've known before. But as with anything, it's just a matter of time and getting used to it. And trust me, by the end of the course, you'll get used to it. But I do want to mention a few more things before we start building our RoboFriends app. First is that in this source folder, we have a few more things like set up tests or report web vitals, which we're not really going to worry about. These are just configuration files that are nice things to have. Again, Create React app provides a lot of nice extra things, but they don't really help us build the app. So we're not going to worry too much about it. If you want, you can always go to the React app documentation. You can click on Get Started and read some of their documentation. The key for us and the things that we want to focus on is index.js and app.js. These are the main things that allow us to build components and build this React app. Now I want to test our assumption. Remember how I said that the React app gets rendered right in here, inside of this. So as a developer, always test your understanding. How can I test my understanding to verify that what I said is correct? Well, we can simply go to app.js and update this like I did, but we can go even a level higher. Remember how I said we're rendering the app right here? Well, could I do this? H1, hello world, and render H1 header like this? Pause and think, is this going to work? Well, let me find out. I'm going to save this. It's compiled with warnings. Line 4, app is defined but never used. Again, another nice thing about React. And that makes sense, right? I'm importing app from app.js, but I'm not using it. So it's just a warning, it's still fine, because instead of app, I now have hello world. Let's see if this is still working. If I go to my app and I refresh, I get hello world. That's working. And why is that? As we're going to discover, with React, we're essentially using HTML like syntax, like H1, plus creating our own custom HTML-like syntax using something called JSX. Again, we're going to learn more about that in the upcoming videos. So I could have something like this here where I say app, save, go back and refresh, and I have hello world and our default app. So again, I'm testing my assumption that I can add things in here and React DOM renders it on the HTML page for us. Very, very cool. Now, in some of the upcoming videos, you might not see things like report web vitals. Instead, you might see something like register service workers. That's an old version of Create React App and something we won't really get into in this course because, again, it's outside of the scope of what we need to know. The key and the focus that I want you to have for the next couple of videos is what we do inside of the source folder. To be a good React developer is learning how to work within this source folder and building good React components. And that's what we're going to teach you throughout the next couple of videos. The final thing I want to show you is this. If you're on Sublime Text, you might have the syntax highlighting a little bit messed up like this. So if that's the case, what you need to do is instead of JavaScript, because these are .js files, you can actually select Open All with current extension and use JSX. So go to JavaScript and select JSX. And this will give you proper syntax highlighting for what we call these JSX files that the React package allows us to write. More on that later. For now, let's take a break and I'll see you in the next one. Bye-bye. All right. I had to make this quick video to talk about the elephant in the room. If you know anything about the React world, well, this discussion has to happen. Classes versus hooks. Now, as you learn in the course, there's many ways to build React components. And one of the newer ways to write these components is using hooks. Now, the way we've structured the course is the way that we actually recommend you learn how to write proper applications. The thing is, hooks are fairly new and they're exciting. So a lot of people talk about them, but they're also very specific to React. What you learn about hooks, you can't really apply to anywhere else in the programming world because they're so React specific. Versus classes, well, that's part of JavaScript. Learning classes is an important concept, not only in JavaScript, but a lot of other programming languages. Also, because hooks are fairly new, a lot of code bases in React still use classes because there's nothing wrong with classes. So the way we've structured the course is that we're going to teach you React starting with classes so you know how those work so that you can apply that knowledge to any of your future projects, or if you land on a project at a job that still uses classes, and then we're going to convert the app using hooks so you get to learn both ways. And we also started with classes because there's been a little bit of move lately in the industry where people are shying away from hooks because of the added complexity it adds to React. Now, this is a hot topic of discussion. It doesn't really matter whichever one you prefer. Our goal is to teach you both, and then you can decide for yourself what is best. The way we've structured the course is what we think is the best way to learn React. That is, starting with classes as they were intended, and then learning hooks afterwards to show what problems hooks solves that maybe we had with classes. So hang in there. We're going to cover both of these. I'll see you in the next one. Bye-bye. Welcome back. I know we want to get coding. One last setup before we start building our first component. I want you to change this function app into something that I'll explain as we go through the course. You see, this is called a functional component. I want to change this into a class. And the way we do this is we say class app extends React dot component. We're going to remove this since it's not a component. And then we're going to return this in a render method. So this, what you see here, let me make sure I add the proper brackets. Like this. I'm going to save this. I get React is not defined because I have to import React from React. And why did I get that? Because I'm using React.component here. So if I save that, I get, okay, app is defined but never used. That's because of the index.js file. Let's just, for now, use app again. Everything is good. So I've created a class component. Let's just make sure this works before I explain it to you. Look at that. Everything works as expected. So I didn't change anything, but I did convert this into a class. Now I want us to start off like this because back in the day when Create React App got started, this is how the default app.js file was like. And as you'll see, we'll have to convert this into a class to create what we call a class component versus a functional component. Again, don't worry about the naming. But essentially what I'm doing is I'm using the React package that we installed using .component. This extends or gives us the power that comes inside of the React package. So I make an app and I say, hey, I want the power of React.component that I've installed. And this React.component automatically detects this render method. Usually you want to add a render method because automatically part of the functionality is that it's going to run the render and return something, returns some sort of view in here. So if you're wondering how all this magic is happening, it's all in the React.component. Again, something we're going to dive deeper and deeper into, but as a starting point, I want us to start off with the class, extends React component, and then from there, we're going to dive deeper and deeper. Now, the final thing is that when we go into the next lesson, you might see some things different. You might not see this React.strict mode. Create React App is constantly updating. So they add new nice features that doesn't really affect us immediately, but just makes things simpler. So React.strict mode just gives us extra protection that, again, we don't need to worry about. So you won't see that in the next video. And you won't see things like report web vitals in the next video. You might see something like register service worker, which used to be part of Create React App. But once again, we're going to ignore that. We're going to focus on what I said, the source folder and building out our components. So let's get started. All right, welcome back. We have our Hello World app, but that doesn't look very cool. We want to make our Robo Friends app. So in this video, we're going to get started by building our first component. If we go back here, we remember that we have the terminal on the right-hand side, and we just ran npm start, and Create React Apps checks all the files for us, make sure there's no errors. It says that our app is defined but never used, so let's comment this out. Again, command / save this, and you'll see that everything's working fine. Now, you may have a few questions just on this index.js file. One, we see that we're importing React, but how come that's working? We remember that it didn't work before. We had to use require and then browserify. Again, React has Webpack underneath the hood that does the bundling for us. So we're allowed to use imports. As long as we keep these at the top of the file, we can import whatever other files we want or whatever packages we want. We also see that there's two things, React and React DOM. If you remember, React is a view library. So this is the little robot that we remember from the previous video. It's the core of the package that does the DOM manipulation for us. But as I said before, React can be used in multiple places, not just the browser. It can be used for mobile devices, it can be used for virtual reality, and you can plug and play different libraries like this based on what screen you're rendering to. So React DOM is used for the DOM websites. So it's the glue of React, but we can have something like React Native that actually renders to mobile phones. We also have import index.css, and this is a new syntax. Well, React allows us to add CSS not just in one file, but for each different component. If we go to app.js, well, we have app.css that describes the app. If we go to index.js, well, we have index.css that has its own styles. And these styles will only apply to whatever components index.js renders. And the way we use it is we just say import. And then unlike a React package where we just say the name of the package and it automatically knows to check the node modules folder, we have to tell it where index.css lives. And this syntax of // means it's in the same directory. So it's saying check in the source folder, index.css should be there. Okay, and finally we see register service worker. And this is an advanced topic that we won't cover in this course, but think of service workers as a new feature that allows our apps to become faster and potentially work offline. It's something that we don't need to concern ourselves with. So for now, you can comment this out and it will still work, but we'll keep it here just because Create React App gives it to us for free. The things that we really care about though is, well, this line over here. This whole thing is what React does. It's saying, I want the React DOM package to use the function render. And this render is, I want you to render whatever this is. But if you remember before we had app. And well, this isn't really an HTML tag, is it? We've just created this from, it looks like the same directory, there's something called app. And it doesn't have a .js file like we see it over here. And that is because it automatically says that if there's no .css or any type after it, well, it assumes that it's JavaScript. But this will work as well, as you can see. Okay, so let's go to app.js file and see why we can use this HTML tag that we've created. If we go to app.js file, well, again, we see that we're importing something. We're doing something called destructuring here and getting component as well. And we have a few files like logo.svg and app.css that we're importing. And again, we see that our syntax is a little bit off, so make sure that we change our files to JavaScript Babel. And it looks like class app extends component that comes with React, and this is just standard syntax. This renders. Remember, a component always has the rule that it must render at least something. And the way we do that is we return a HTML piece of the website. So we see over here, welcome to React, to get started, edit. Well, that's exactly what it says over here. That is the power of React. We're creating our own custom components, our own custom HTML tags that we can just add. And if you remember the one-way data flow picture, we have one parent that has children. So app has children. But you know what? Let's build our own component to make this point clear. Instead of having hello world in here, let's create a component called hello. And it's a self-closing tag, so we want to have the backslash. And in here, instead of saying import app, let's do import hello from, we'll call it hello.js. And you'll notice that it's capitalized here. Well, if you're building a component, the standard is that it's capitalized. So it'll be called hello.js. If we save this, we'll get an error. It says module not found can't resolve.hello because the file doesn't exist. So let's create one. I'm going to say new file, hello.js. There you go. We have a new hello.js file and it's compiled successfully. If we go to the website, well, look at that. It actually even gives us error on the website. And that's why Create React App is just so awesome. It shows you exactly what the errors are without opening up the console right here. Again, we have nothing built right now in hello, so we need to create it. Let's use app.js as an example. It looks like we need to import React and component. So we need to say import React component from React. Okay. And the reason we're doing this, again, this is destructuring. Instead of doing React.component, we can now just do component and it means the same thing. Again, looking at app.js, it looks like we say class, our component name extends component. Let's do that. Class, we'll call this hello. Again, that's what our component's called. Extends component. And again, remember to change our JavaScript to Babel. And if you remember, one rule is that we always want to have a render function. And within this render function, we tell it what we want to return. Well, we want to return the hello world example. We can say h1 hello world h1. Okay, let's see what happens when I do this. I save, and it says export default imported as hello was not found. Well, it's because we're not exporting this. Remember, if we want another file to use it, we have to export. And we use export default when we're just exporting one thing. If we use the word default, that means this file only exports one thing, and that is the app. So I can say export default hello. Let's save. Looks like it's working. Let's see what happens in our website. Hello world. We've just created our very first component. How cool is that? Now, right now we only have one line, but what if I wanted to do something like div, wrapping it in a div, and maybe underneath here I'll say a paragraph that says, welcome to React. If I save this, I get another error. And it's because we're just giving it multiple lines here and returns expecting a single thing. We need to wrap this in brackets like this in order to have JavaScript say, this is an expression. Evaluate this entire thing. If we save this, looks like it's working, and then hello world, welcome to React. Very cool. Within here, if you remember, if we import .hello.css, we can create whatever CSS styles we want. But we need to create that file first. So let's do new file. And I need to add an O in here. The new file name will be hello.css. Now in hello.css, I can just say that the h1, and this is just standard CSS, will have background of red. I'm going to save this as well. Everything looks good. And look at that. But you know what? To make this faster, and because we've gone over CSS, I want to show you a cool package called Tachyons. And Tachyons allows us to have, similar to Bootstrap, predefined class names that we can just add to components to make things look really, really nice. So let's do that. I'm going to close this and say npm install Tachyons. All right, it's added a package. We can check by going to package.json. We see that tachyons are there. And we can use tachyons very easily by just going to index.js file and saying import tachyons. And now we have access to this package. Just to show you what tachyons are, if I go to tachyons, styles, it gives us little classes that we can use that, for example, text center will just say TC. And as long as we have tachyons installed and we use TC as class name, it will align our text. So now that we have tachyons and its index.js file, we can just say within here, class equals F1 for font1 and text center. If I save, I have to do npm start here, make sure that our server is running so that we can check our changes. And we get hello world, welcome to React. But there's actually one trick here. If you open up the console, although this worked, I get a warning saying invalid DOM property class. Did you mean class name? And React's really, really good at giving you errors. And you might be asking yourself, why class name instead of class? Because if I save this, go back, I no longer have that error. Why is that? Well, up until this point, we've kind of just written HTML, but this is a JavaScript file. How are we able to do this? This is actually something called JSX. Part of React is that it allows you to write this HTML-like syntax in your JavaScript. And you might be asking yourself, one, doesn't that break the rule of separation of concerns? And two, how are we even able to add HTML to JavaScript? To answer the first question, separation of concerns, React has the idea of components, and that is, it's better to have functionality and styles per component so that each component is its own separate universe, and you just add these components. And the idea of separation of concerns with React is that components, well, they're concerned about themselves, nothing else. So it changes the paradigm here. And it's kind of nice, right? I can just look at the hello component. I know exactly what it's doing. I can look at the CSS. And anytime I need to make a change, I just need to worry about the files that contain the hello CSS and JavaScript. The second thing is this thing called JSX. Underneath the hood, what React is doing is actually letting you use this syntax, but they're not actual HTML tags. Remember what I said about the virtual DOM and how React creates its own object and then looks at the DOM and compares it and says, I need to change this, and it does it for us? React uses JSX to create their virtual DOM, their fake DOM that they build based on what we give it to them. Then they look at this virtual DOM and the real DOM and say, this part has changed. I'm going to change the DOM now based on the virtual DOM. And that is why React is really, really fast. It creates these objects, which is really fast in JavaScript, and only changes what needs to be done in the DOM. So just get used to it. It's awkward at first, but again, as long as you wrap it in a bracket, you can write here HTML, as well as your own custom components, such as hello, that we used in index.js file. And now maybe it makes sense why we can't say class here. Because class is a reserved keyword in JavaScript. Class is part of the language that JavaScript uses. So if this is JavaScript, the fact that we're saying class here doesn't make sense. In the old version of React, this actually broke React, but now it gives us a nice error. Because this is JavaScript and not HTML, we have to say class name. And it's something that you'll get used to. You'll get tricked up with at the beginning, but it becomes easy after a while. All right, the last thing I'm going to show you is the power of React. Within the hello component, I can now add something called props or properties. And these props can be called anything. Think of them as HTML attributes. I can say greeting equals. And then within here, I want to wrap it in curly brackets. And this is a JavaScript expression, whatever I want. I can say, hello, React Ninja. And if I save this, I get an error saying that no useless concatenation. So it's saying that, hey, why are you even adding things? You can just put them all together. So it's smart enough to even give you suggestions or warnings of when you're doing something that's not clean. But for now, for demonstration purposes, this is fine. Now that I've given it what we call a greeting prop to hello, I now have access in hello.js to props. I can now say this dot props dot greeting. I save this, go back, and I say hello React Ninja. You see, with this syntax, it's saying that this object, which is hello, has properties, props, that is greeting. I know this is confusing. It's just a syntax you have to get used to. But now we have access to whatever property and whatever property value we get from hello. This is a power that will come in handy later on, but I want you to build your own component here and get comfortable with the syntax. It is really, really powerful, and once you get used to it, you can build any components you want. Okay, one final thing. This syntax might be kind of difficult, but I want to show you that this is actually just a function. If I do const hello, and in here, this function accepts props. If I do an arrow function here, wrap it in curly brackets, and instead of doing this render, I just simply return if I save this, well, I'm getting an error because this.props.greetings doesn't really exist because it's not an object anymore. It is a function. So I don't need the props. It receives props, whatever parameters we give it, and props.greeting is acceptable to us. I save this, go back, and look at that. It's working. It's just functions. Think of React as that. We're just creating these functions that take parameters, and these parameters, which are given by giving attributes and values, are just being rendered. I have access to props.greeting. If I give it another prop here called, let's say, dog, then I'll have props.dog available to me as well. And again, we get a nice little error saying that component, we're grabbing this, but we're not really using it, and we're using unnecessary string concatenation. Again, really useful. As you can see, fairly simple to pick up. In the next lesson, we're going to start actually working on our RoboFriends app, now that we have the basics. I'll see you in that one. Bye-bye. All right, let's build our RoboFriends app. I think to get started, we want to think about components again, and what kind of components we want to build. Looking at this website, the smallest component that we probably want to start working on is perhaps the card component, this card over here. If we can build one of these, then according to what I've said before, we can just copy all these components and add them to the page. So let's start off with this, the card component. All right. Now, we won't be using the hello component anymore. And if you remember, it looked like this. I know it's sad, but we're going to delete it. We're going to delete the hello CSS. Start off clean. So I'm going to delete. Okay. And we'll also delete hello.css. I know all our hard work just completely gone. you know what? We're going to start deleting things that we don't need in this project. For example, the app.js that we had initially, well, we can delete that. We can also delete app.css, app.test, and the logo. All right, so everything's looking very small now. We have just index.css, index.js, and this register service worker that comes with Create React app that we don't need to touch. Okay, obviously we have failed to compile because, well, the hello import doesn't really work. We don't have anything. So let's start off with this. Let's start off by creating a card component. And this card component, we'll have to import it from card.js. Again, if I save this, still get an error because it doesn't exist. So let's create it. I'm going to say new file, card.js. Again, making sure that this is using Babel. And let's do what we've done before. We do import React from React. Instead of doing the class way for now, we're just going to worry about building the function. So I'm going to say const card equals, it won't have any properties for now, and this will return, have some brackets, and within here we'll say that it has a div. Within this div we'll have an image, and this image will have some sort of a source that we don't know what it is yet, so we'll just keep it the way it is. Closing tag, and we'll have another div that within here, if you remember, we have our name and email in here. So we'll just do an h2. We'll just write hard-coded values here. We'll do Jane Doe. And finally, a p tag that has some email address. So let's do janedoe@gmail.com. Close the tag. All right, so we just have a simple component that's returning card. And remember, we want to export this. So we want to say export default card. Save. I get img elements must have an alt property. Again, it's giving me a nice hint. So let's just add a alt property. We just say what this photo is. So I'll just say photo for now. Or I'll say robots for now. Compiled successfully. If we look back at our app, we have robots, Jane Doe, and Jane Doe. Perfect. All right, we have the card component, and you must be asking yourself, why are we using React here if we're not really using it? Let's see what happens if I remove it. I get a whole bunch of errors that says React must be in scope when using JSX. Remember, JSX is this. We're not writing HTML, we're writing JSX. And we need to import React so that our program understands JSX, this HTML-like syntax. Okay, now we need an image. And for this exercise, I have something called RoboHash for you. It's a really, really cool API. And for those that don't know what APIs are, don't worry, I have a section coming up with all that information. Well, you'll get to learn about it. But the cool thing about RoboHash is I can just say anything in here, and it will return a random robot for me. All we need is just this URL, and I can just say for now, test. If I save this and go back to my example, there you go. We have our random robot. if I change this to, let's say, test, I save, well, now I get another robot. How cool is that? All right. I want to make sure that the size is somewhat small. So you can do a question mark here and just give it width and height. So I'm just going to do 200 by 200. And again, this is just something that you do with this URL that they give you in the information here. I won't make you go through it. I save. Everything should look nice. Now, let's say I wanted to add a title, and I'll do something like div or h1 robo friends here. You see I get an error here? It's because, remember, we need to return one thing, and we can't have multiple elements being returned, right? If we want to return something, make sure it's one thing or an array, but for now, we'll worry about the title later. We want to make sure that we're only returning one element. So in this case, the div element that has a ton of things inside, which is the card component. All right, let's save. All right, we have our card component. It looks nice, but what if I wanted to have multiple cards now? According to what we know, because we have the card component, if I go to index.js, I can just say, I'm going to put this on a new line so you can see, I can just wrap this in a div, again, because we want to return just a single element, and I can say card, and close the div tag. Save, and look at that. We have multiple cards now. They're each their own component. Okay, but let's add some styling to this just to make it look nicer. Again, because we have tachyons, we can use some really nice syntax. If we go to the cars component, within the div, I can say class name. Again, remember, we can't use class. BG light green, so that is background light green. And this is just tachyon classes that are already predefined for us. Again, CSS section, this isn't that. So we're not going to focus too much on CSS. I'll just give you the stylings that you need. We have the div, the border, we have padding of 3. We'll add some margins too as well. And then we'll do grow, which is the animation. So if I save this, look at that. That's pretty nice. You know what? Let's add a few more. We'll do BW2 and shadow 5 to add a bit of shadows to them. There you go. They look more 3D now. That looks very nice. There you go. We have our cards. Again, we don't want this static card where it says Jane Doe, Jane Doe, Jane Doe. We want it to be dynamic, right? So it sounds like we need what we call properties. Well, and I actually have for you a robots object that I've created. So I'm just going to add a new file here that says robots.js. And within here, I'm just going to copy and paste this. As you can see, it is just a constant object. It's robots. It's an array of objects, and it has ID, name, username, email. And these are just random that I've made. If you want this file, then you can grab the files from the end of this section. But for now, this way I have something that I can use, and you can see I'm exporting it. Well, I can say import robots from dot, because we're in the same directory, robots. Now, if I save this, I get robots is defined but never used. But because this is using export instead of export default, this file could have multiple exports. It just so happens that I only have one. The rule is, for these ones, because they were default, well, you can just do card. For ones that aren't default, you have to destructure it. That is like this, so that if I have another variable, let's say that says cats, then I will have to do cats to grab it. So we have robots. And now I can give it some properties. I can say ID equals, and again, we have these brackets so that it's a JavaScript expression, and we'll say robots first array dot ID has the ID. Then we have name equals robots, again, the first user dot name, close the bracket. And then we also have email equals robots first in the array dot email. Holy moly, that's a lot of typing. And I'm going to make this smaller just so you can see. I'm going to copy and paste for the other ones as well, except for change this to the second user and then the third user. Oh, the second user. Now, if I save this, it's compiled successfully, but well, nothing has changed because we need to go to cards. I'm going to close robots.js for now, and this, because cards needs to now accept parameters. And what are the parameters? Well, it's properties. And these props are now props dot name and props dot email. I save that, go back. It's not working. Well, because this is a JavaScript expression, right? So I need to wrap it in curly brackets, just the way it works in JSX. Save. Look at that. We have dynamic names that we're passing as properties to each one. Let's add text center here. And there you go. Now we have everything centered. That's a lot better. Okay, but we also passed ID. We can use ID to do something cool. If you remember in the ES6 section, we have template strings. And because this is a template string, we have to wrap it in a curly bracket, so it's a JavaScript expression. And now within the robohash, instead of using test here, we can randomize what robots we get by using this syntax, as you remember. And in here, we can just say props.id. So now this will say robohash.org ID of whatever it is for the robot with the size. So we make sure that, again, the IDs are always dynamic and changing. If I save this and go back, look at that. You see that there's a bit of a delay, again, because we're talking to the API and the API is returning answer for us. But how cool is that? We just created our own dynamic cards. One last thing. Although this works, something nicer that you can do is we have something called destructuring. We can do something like const name email equals props, again, as you might remember from ES6. And now I can use, and let's add ID as well. And it still works. Another cool thing that you can do, and this is even cleaner, is within the parameters, you can do destructuring. So again, you can add these over here now. And now if I save, it should still work, and it does. This might be confusing if you're new to destructuring, but as you saw, step by step, we're just receiving props and we're destructuring the props right inside of the brackets here. This is much cleaner. Whew. All right, that was a lot of fun. In a really, really fast way, we've just created our own cards. In the next section, we're going to expand on this and make this even better. I'll see you in that one. Bye-bye. I'm going to tell you a little secret. A secret that not many people tell you about. But you may have thought to yourself, hey Andre, how do you know all these things? Or anybody that you see online that maybe you watch their YouTube videos or take their courses, or even your college professor. How do they know all these things? It seems so hard to get to where you want to be, right? But there's a secret. It's not that hard. As a matter of fact, anybody that's teaching you online, even myself, teaching you React right now. I was in your shoes. I didn't know React before, but now I do. As a matter of fact, in my past role, I used to get paid as a consultant, as a React consultant in Silicon Valley, a lot of money per hour to advise on React projects for big companies. But was I an expert? I mean, yes, but how did I become an expert? You see, a lot of people think that learning involves finding the right course, finding the right YouTube video, reading the right blog post. But there's something that a lot of people forget. The people that know React the best, or any library, any tool for that matter, are the people that create it. You're never gonna be as good as the people that create that product, like let's say React. But you can become almost as good as them. And the best way to do that is to read documentation. You see, we live in a world where we want the quick, easy fix. I just want to learn React fast. So I'm going to watch a couple of YouTube videos or a couple of tutorials and learn. And yes, you can do that. But most people, as a matter of fact, I very rarely in my profession met people that read the full documentation. Do you know how you become the best of the best when using React? Well, you go to their documentation website and you literally read everything. They have a Learn React section. They have references. They have a blog that they do updates on. If you read this, you're literally going to be better than most people out there. Why? Because this is written by the people that have created React. Their job is literally to create documentation, to make their library or tool as easy as possible to use. So they're going to put the most effort out of anybody to explain how things work, to explain how to do things right. And that's the dirty little secret. You watch all these people online, including myself, that teach you how to use a tool. But how those people learned how to use that tool is by reading documentation. So you can bypass a lot of this, who should I learn from? What video should I watch? What blog post should I read? By just reading the documentation. That's how I was able to be a consultant at a big company in Silicon Valley. I wasn't doing anything exceptional. I simply read every single piece of documentation in React until I understood it. From there, you gain experience by building things, by working at a company and seeing how to use React in production. But the baseline, the most important thing, is to create this foundation of how things work. Now, I know this isn't the most exciting video. We didn't build anything. You just listened to me. But this is the best piece of advice that I can give you. You don't necessarily need to always find online courses to teach you something. If you want to learn a tool, you're smart enough now to read documentation on your own and try things on your own. Don't think that documentation is not sexy enough. It's too boring to read. You have to do the hard things if you want to be good at something. And reading documentation is the best thing you can do. So use my videos for React as a reference. But after this course, if you really want to dive into React, read the documentation. And that's going to put you above most people, because most people, unfortunately, are too lazy to read what's right in front of them and the best tool to learn something. I'll see you in the next one. Bye-bye. Welcome back. Let's continue building our RoboFriends app. Now, up to this point, if you look at our index.js, well, that was a lot of copy and pasting that we did. If we had a lot of robot friends, imagine having hundreds of these that we have to constantly copy and paste. That's not very efficient, is it? Also, if you remember our diagram over here of one-way data flow, we always had a parent, such as an app component, that had children, that have their own children, and so on and so forth. So using that knowledge, we can have one big app component that have different children so that we make each component small and reusable. Let's go back to our example. Now that we have robot.js, we ideally can list all these 10 users. The way we do that, let's have a card list component so that if we import a card list component, which is a parent of card, then we can just render that instead of all these cards. So I'll say card list. And again, we'll have to create it. So we'll say new file, card list.js. Again, changing it to our Babel syntax. We'll do import React from React. And I'll make this a little bit bigger. And again, we'll just say const card list equals, won't accept anything for now, but it will return, well, what should it return? It should return the cards, right? We can just copy and paste this, put this in here. Let's fix the indentation here a bit. Now, card list will be the one that returns these cards, and index.html will just render card list. If I save this, well, I'll guess that card isn't being used, so we can remove it, and robots aren't being used. But we can use the robots now to pass that as robots equals the robots array. Card list is accepting a robots prop. If I save this, everything's working, but I'm getting this error because, well, as you can see, we didn't export. If we go back to the card list, export, default, and hopefully by now you're starting to get the hang of it. There's a lot of repetition here, but each time, as long as you learn the syntax, we're creating these components nicely. And we get a ton of errors because we don't have any access to robots and IDs and, well, card for that matter either. So let's import card from, again, same directory, card.js. Robots isn't defined. We know that card list receives robots now, so I have access to it in the props. Or I can destructure it and say that we have access to it with robots. If I save this, look at that. I have everything back the way it was. But it's not all of them, is it? We're only grabbing the 0, 1, 2, only 3 of them. And as we saw in robots.js, I have 10. How can we do this better? Let's make this a little bit smaller so you can see. It looks like we want to do some sort of a loop, right? We want to loop over the robots and create a card component for each one. How can we do that here in React? Let's start off by adding another variable here. We'll call it const card component. And within the card component, we want to say that robots, we want to, well, what do we want to do? When we do a loop, as I've said before, we want to map, right? We could do for each as well, but I always recommend doing map. And within this map, each robot gets this. So we get a user every time we map through it. So we can say user should return, again, because a map needs to return, it returns this, right? We want to return a card component. I can copy and paste this right here. And within the return, I can just say now, instead of robots index 0, do we have the index? Well, yeah, because you remember, the second parameter that we get in a map is the index. So I can say user and I for index. And now within robots, I'll say I for index. Each time, the first time around, this will be 0, then 1, then 2, all the way to 9 to include our 10 robots. Let's see if this actually works. If I add card component here, you remember that we have to wrap it in curly brackets because it's JavaScript, so it knows to evaluate. If I save this, looks like it's compiling successfully. I go back and holy moly, we got ourselves a card array. How cool is that? That was incredibly fast to do. We just used our common sense and JavaScript knowledge, just use map, to return multiple components. I hope you realize how powerful that is, and that is why React is so popular right now. We're able to use JavaScript to return these HTML elements and do things really, really fast. If I open up the console here, I'll see that I get a warning. Each child in an array or iterator should have a unique key prop. And there's a link to it if you want to read up more on it. This is a special case that you just have to remember. When working with React, the way the virtual DOM works is it keeps track of what all these cards are. But without having something called a key prop, if some of these cards get deleted, React won't know which one's which and will have to change the entire DOM. Versus if it had a key prop and says, oh, this one gets removed, I can just remove this from the DOM. Remember, we want to minimize the amount of work that we do to the DOM. So when you do a loop, it's just something you have to remember. You have to give it a unique key. In our case, we can just say I, which is index. If we save this, we have to wrap it in curly brackets again because it's JavaScript. And there you go. Now we don't have the error anymore. And let's just make this on a new line just so it looks prettier. And because we're returning it on multiple lines, we want to wrap this in a bracket, right? All right, and that's better. So this is working nicely as we want it. I want to show you one thing. Because this is JavaScript, anything we put in these curly brackets is JavaScript, including comments. Well, we can just copy and paste this entire thing, remove the constant, and just add it within the brackets. If I save this, it should still work like it does. And this is another power of React. React makes you a really, really good JavaScript programmer because other than this JSX syntax, everything else is just JavaScript. So we're able to create a card list component that lists cards, and all we need to do is pass it a prop of robots. And we just made this a ton cleaner. Very cool. All right, that's it for this video. More things will happen in the next one. See you in that one. Bye-bye. All right, we're getting closer and closer to having our app look like this, but we clearly see that we have a search box here. So in this video, we're going to work on having this interactive. Looking back at our app, we see that we definitely need a title and the search box. So let's create that. If I go to index.js, I think now that we're officially building an app, instead of having the card list component here, we should have one big component called app. And this app will be the father of all our children, all our components. Let's do that. Let's build the app component first. And this app component, again, will import React from React. And app will equal the card list component, which we can just copy and put in here. And again, changing this to Babel. We want to import the card list component. And we also want to have our robots actually imported in here, so we have access to it. And then finally, we now just want to render the app component. So we can just bring this back to the way it was. We save. We need to obviously export our app. So we'll say export default app. Save this. Let's go back. Yeah, everything is still working. Now within the card list, we also have a header. So we'll do header 1. That will say RoboFriends. And again, remember that we need to return just one single parent. So we need to do something like a div to wrap it. Oh, and I need to close this h1 tag. All right, I have my RoboFriends title, and we also need a search box. And although h1 was easy and we didn't have to build a component for it, it sounds like we probably want to create a search box component for this app. So let's do that. I'm going to say import search box from a file that we'll create called searchbox. We will create a new file. And this file will have import React from React. And the search box will have a function that returns. Let's think about what it returns. Well, it definitely returns an input, right? That is type of search. And let's also have a placeholder. Let's close this. And a placeholder that says search robots. We close this and save, and we have to export. Export default search box. Save, compile successfully. All right, we have our search box, but well, it's not searching anything right now. Let's add this on a new line, just so it looks nicer. And it's always a good idea, just in case you want to add more things to the search box, to wrap everything in a div. So I'm going to do that right now. And this div will just have a class name of padding2, again, using tachyons. And with the input, we can do a class name. And I just know these look good, so I'm just going to copy and paste here, just padding, or with background lightest blue. If I do this and let's go back, all right, this looks better. We want to center everything. So maybe in the app, we can just add a class name equals to text center. See if that works. There you go. That's much better. I like this already. Now, how can we make this interactive? Up until now, we've just had this static websites, but real websites are interactive, right? let's think about this logically. We have an app, we have a search box, and we have a card list. But the search box component needs to communicate with the card list. And same with the card list. Card list needs to know what is in the search box so that it can filter out robots accordingly. Let's go back to our image that we have of one-way data flow. Looking at this, we have the app component and then the card list component that has cards, and then the search box component that, well, doesn't have any children now. But in order for these two to communicate, we have a one-way data flow. That is, they need to send their information to their parent, and the parent tells them what to do. Now, how can we do that? Up until now, we just had some data that we just trickled down, but we never had it where one of the children had to modify data or communicate with a neighbor. Well, in order to do this, React has an idea of something called state. Up until now, we learned about props, such as properties that we keep passing down. But we've never changed them because React just reads the props. If I go to card list, it just reads the props that it receives and it just renders something. And this one-way data flow is really nice because this card list is a pure function. It receives an input and then it always returns the same output. So if robots are always the same, it's always going to return the same thing. It's deterministic, pure functions, and it's something that we've talked about before. And this is a really, really good thing. These components are what's called pure components, and some even call it dumb components. It just means that they don't really need to know about anything other than the fact that they're pure functions that receive something and return something. And this is really nice because we always know what this is going to look like. And that's all we had up until this point. But now we have to worry about something other than props. Props never change. Props are always just inputs that we get and we've never modified them. But in this case, we need a memory in our app. We need this to communicate with this and also change and update accordingly. And that's what state is in React. State, and you'll hear this in computer programming a lot, simply means the description of your app. A state is simply an object that describes your application. And this state, which describes our application, is the robots and whatever is entered in the search box. And state is able to change. We're able to change the value of the search box, the value of the input, and we're able to change what robots array means, what gets displayed. This is a rule that you just have to remember. Props are simply things that come out of state. So a parent feeds state into a child component, and as soon as the child component receives a state, it's a property. That child can never change that property. The parent just tells it what the state is, and the child receives it as robots. So the first thing we need to do is to start being able to use state in our app, the description of what our state should be. So let's just do a constant state for now and show you that our state needs to have a robots array and it needs to have, let's call it, search field. And this is just whatever our search field needs. But in order to use state, we have to go back to our original way that we created React components. If you remember this when we first did create React app, we create a class. And we do that by saying export default or export app extends React.component. It extends the component class. And again, we can use shorthand here and just say, so now we can just remove React from here. And this always has a render function that has to return something, which is this. Again, it's just the syntax that you have to get used to. If I save this, oh, and I made a mistake here. Instead of export, this should say class. So yeah, class app extends component, and then we do export default app. So again, we're just declaring a class. I save, and we just have something that says state is assigned a value, but never used. That's because that's pretty true. We don't use it. So how can we add state? Well, in React, we simply do a constructor. You might remember this from when we spoke about objects. And this constructor, in here, we can declare the state. We simply say this.state equals, and in here, we just put whatever we want our state to have. So if I save this, I get this is not allowed before super. Again, something that you might remember from the advanced objects video. In order to use this, we have to do this weird thing where we call super, which calls the constructor of component. If I do this and save, everything's working fine. And now we have our state, which is robots and search field. And this state, as I've said before, is what describes our app. These are the things that can change, and that's what it is. State is something that can change and affect our app. And they usually live in the parent component, the component that is the parent that just kind of passes state to different components. So now I can access robots not from here, but from this.state.robots. And again, just React syntax that you'll have to get used to. All right, so everything is working as expected. And you see that our state, which is robots, is now passed down as props. So card list accepts robots as props, even though in the app.js, it's state. And like I said, because app now owns state that includes robots, it's allowed to change it. Okay, now the way we can communicate them, we have these two values. And ideally in the search box, I have something called onSearchChange, which again is a function that I'm just going to make up. This is just a random name that I've created. And on search change, I want to say that every time the input changes, just like we did with DOM manipulation, we get an event. And within this event, I'm going to console.log this event. I've created a function, and I want any time this input changes to trigger console.log. So we can pass this actually now. I can say search change is on search change. But again, because this is an object, we have to say this dot. So that it says this, which is the app dot on search change is search change. If I save this and now go to the search box, I now have search change as a function. So I can just say, just like in HTML, remember in HTML I can do on change HTML? It's an event We're just listening to any time the input changes. I can say on change equals search change. Let's see if that works. I'm getting no errors. If I go back to my app, I open up the console and I type in something. Look at that. I'm getting the event. And this is just something you have to remember, is that with an event, we always have event.target.value, which should give us the value of the search term. Let's save that and type in something here. Look at that. We're now noticing the difference as we type. So let's go over one more time what just happened. And again, I know this is tough. This took me a while to get when we first started, but this diagram really explains it well. I have my app component, my search box, and my card list. Anytime the search box changes, on change, I'm going to run the function. I'm going to call this function. And the way we call it is we add this. Remember how when we did DOM events, we define the function, and then every time the event happens, it would call it. So we are saying every time the onChange event is triggered, call the searchChange function. And if you remember, the searchChange function, which is a prop, is the onSearchChange function that is defined in the app. That's how we communicate with the parent. It triggers the event. The parent says, oh, run this function. And now this function gets ran. But now that I have the value of the search input, I can now directly communicate that search input to the robots list. Let's see how that works. We can create a variable, let's say filtered robots, and this will equal the this.state.robots. And these robots, which is the array, again, this is how we access state, is going to use filtering our array. We give it robots, and now our array will have to return a condition. And the condition is going to be robots.name. And we're going to do something that we haven't seen before, which is to lowercase. And this is a method that comes with all strings, and it just makes everything lowercase. And this is good for comparison, so we don't have to compare capitalized or lowercase. And if the name of robots, which is now lowercase, includes is another method, and again, it's pre-built into JavaScript. If it includes the search field, and again, we want to do to lowercase in case we use capitals or lowercase, it works both ways. And there it is. If the name of the robots in lowercase includes, and this does the comparison, if anything in the string includes to lowercase, well, then only return the robots that returns true to this. Let's save. Oh, and you see here how I get the search field error because, well, it's part of the state. I have to do this dot state dot search field. If I save this, I get that filter robots is assigned a value but never used. But don't worry, we can now console log this and see what we get. If I save, and let's go back to our app, and if I search something here, I get an error. And this is an error that is very, very confusing. It is tricky the first time, but bear with me here. The problem right now is that the value of this, well, it's not referring to the app. Because the event happened in the input, the value of this is, well, the input. And input doesn't have state.robots. And this is a trick that you always forget, but just keep this in mind as a rule of thumb. With anything that comes from React, so constructor and render are pre-built in React, anytime you make your own methods on a component, use this syntax, so arrow functions. And this makes sure that the this value is according to where it was created, which is the app. I know it's confusing. You can read up more about it. I'll leave a resource for it. It's a tough topic to get, but again, rule of thumb, use the arrows. If I do this now and I click, there you go. I now get robots. But here's the thing. Search field right now, you see that I still have 10 robots. It's not really filtering anything. And that is because my search field is always an empty string. In order to update state, again, another rule of React is to do this dot set state. And it's, again, a method that comes with React. And anytime you want to change state, you always do this. You don't do this dot state dot search field equals. You never do that. You have to do this dot set state. And within here, we just say search field is, and again, we're using an object. So search field is now going to be event.target.value. If I save this and go back, you see that now everything is being filtered. So I'm changing the state so that the search field always gets updated. And now we're filtering the robots according to the changed search field. Okay, so one last thing. Looking at this, we have the fact that filter robots is still not assigned. And you're right. If we look at this, we've now communicated the search box with the app, and we have the search field constantly changing. So now we need to communicate it to the filtered robots. What we can do is that filtered robots can now be used as props instead of this.state.robots. So let's do that. Let's move this down here. And now we have access to filtered robots. And instead of passing this.state.robots, we simply pass filtered robots. If I save this, make sure the search bar is saved as well. And now I go back. I'm going to close the tab and let's check it out. Look at that. We have our app working. How cool is that? Let's go over it one more time to show you exactly what it does. We have our app component that has two states, robots and search field. And because app owns the state, any component that has state uses the class syntax, so they can use the constructor function to create this dot state. And this state is what changes in an app. It's what describes the app. Remember when I said the virtual DOM is just a JavaScript object? The virtual DOM is just an object that collects this entire state, and React uses this state to render and pass them down as props to these components, so that these components that are just pure functions can just render. And we always know that the app is going to look the same because, well, they're just simple pure functions. We manage this state in here. The app is the only thing that can change this state, but it can pass down things such as props. So we pass down onChange to the search box. And the search box, every time there's an onChange on the input, it lets the app know, hey, there was a change. Run this function. It runs the function with the event and updates the state of the search field to whatever we type. Now, with the information that we have from the search box, we can now communicate to the card list and tell it, hey, I want you to filter the robots state to now have only what includes in the search field. And instead of passing the this.state.robots, we just pass the filtered robots. You might be asking yourself, well, robots never really changes, does it? We always just create a new array called filtered robots, and we always pass that down. Does this need to be part of the state? And right now, not really, because we just have a hard-coded robots. But when we get later on into the course, you'll see that that's not the case. Most of the time, you're getting the users or robots from another place over the internet. In which case, we will need robots to change from an empty array to an array after we go and grab all of our users. Whew. All right. That was a lot. I know it's a lot of information, a lot of new syntax, but as you can see, with a few lines of code, we build a pretty awesome app. In the next video, we're going to finish this up and finalize our app so it looks as pretty as this. I'll see you in that one. Bye-bye. Okay, our RoboFriends app is starting to look good. It does some searching, which is great. It's very interactive, but let's add some styles to it just so it looks like this. And I mean, styles is something that we've already covered. I just want to get you up and running quickly. Let's start off with first the background. As you can see, we can just generate a gradient and have that background. I've already found a really good background gradient that we can use. You can use the background generator that we've actually already created in previous videos. For now, as you know, if we want to change the CSS of our entire app, well, we have index.css, which is perfect for this. And then we can just put in the gradient that we want. I'm going to save this. And look at that. It tells us that there's an update and gradient has outdated direction syntax. New syntax is like to left instead of right. Well, isn't that convenient? Let's do that. To left. Let's see if that still works. Okay, everything's looking nice. Perfect. Let's fix our font. Now, if you see over here, we have this cool font. How did I get that? Actually, I just Googled for the Sega logo font. And I found this website that has free fonts that you can use. And we can actually just click on Generate Font Face Web Font. And this is something that you don't really need to know. It's just a matter of Googling and finding the font that you want. But if you download this file, you'll see that it actually has the WOFF, which is actually a font file, and style.css. So it actually tells you what you can include. Let's copy that, add it to our header 1, which, if you look over here, lives in app.js. Using app.css, which I think we've deleted that already. So let's bring it back by adding a new file, app.css. So we'll just copy and paste what we did, and font face just tells us our font. And in order to use that, we'll just say h1 has font family of Sega logo font. Now, this won't actually do anything because, well, we need the font file so they can find Sega logo font. And that's simply a matter of us dragging in our font file. Let's minimize this into our RoboFriends. And let's see now, it should be right over here. And we can simply access it by looking at the URL. If our app.css file has access to this font, we can just move it into our source folder. All right, and one thing you might notice is that, well, nothing will change because in order for this CSS file to work, we have to import it. So always remember, import app.css, save it, compiling. All right, I don't know if you can see it, but it's there. So we want to make it bigger, and obviously the color black doesn't work well with this background. Again, this part isn't CSS, so I'm going to go through this quickly. I have a few styles here, font weight, and a color that is nice. Make sure that we have it imported. And using tachyons, we can just make this bigger. We can just say class name equals, you can do F1, F2. Let's do F2. So F1. All right, that looks pretty good. Our app is looking nice and clean. There's still a few changes that we want to make, but overall, everything looks good. We've played around a bit with the CSS. We've added a new font file, and we've changed the background of index.js file with the index.css file. All right, we're going to get back to learning more React in the next video. I'll see you in that one. Bye-bye. Welcome back. In this video, we're going to talk a bit about something advanced. And we haven't covered it much in this course, and we definitely will in the next section. But I want to get started with it so that even though it might be new and confusing at first, by the time we get into the next section, we'll come back and review exactly what we're doing. I want to make this app more realistic. In a real-life app, we wouldn't necessarily have these robots written like I have here in robots.js. I've just created this file, but in real life, well, we're not manually entering users. We would use something like an API. And what that means, well, we want, when this website gets loaded, to make a request somewhere out there in the world of the internet and grab these robots from a server. Well, we can actually do that. We have over here something called JSON placeholder, and you don't need to worry too much about it, but they actually have a really nice URL that we can use, and they return what we need, a name, an ID, and a username. The rest of the information, well, we don't really need it, but as you can see, just by typing in this URL, I get this. So using this, we're going to make our app a little bit more realistic. Let's get started. If I close my CSS file, since we don't need them anymore, and let's close the rest of the tabs as well. Looking at this app component, we see that it is what we call a smart component. Unlike the search box or card list that are just pure functions, as you can see here, app.js actually has state, a piece of data that describes our app. And because they have state, we call them smart components. And smart components tend to have this class syntax. Now, in real life, when we start up this app, this robots would actually be an empty array because there's nothing there. We haven't grabbed the users. So most likely, if I save this, robots wouldn't display until I load the website, and then as soon as the website gets loaded, I ask for the users from somewhere over the internet. Somewhere, hopefully, here. So let's do that. React comes with a few other things inside of components that we can use. And they're called life cycle methods. And it looks something like this. Don't get too overwhelmed. These are just methods that we can use in here that comes with React. And they're called lifecycle hooks because what they do is if we run these, it will automatically trigger when this app gets loaded on the website. Let me explain. We see that we have three sections. We have mounting, updating, and unmounting. The way React works is we do something called mounting. When I click refresh here, the app component, this component right here, gets mounted into the document with the ID of root. If we go back to our index.html file, well, our web page is nothing but a div with an ID of root. When we say we mount a component, we're replacing this and adding our entire app. That's mounting. So mounting is the start of the app. Now when mounting, these are the lifecycle hooks that get hit, and they're in order. So the first thing is it checks, hey, does this component have a constructor? Well, does app have a constructor? Yes. Okay, then run this piece of code. Does it have component will mount? No, it doesn't. Then ignore it. Does it have render? Yes, it has render. Run this. Does it have component did mount? No, it doesn't have component did mount. Ignore it. And it just runs through this every time. It also has something called updating, and that is whenever a component changes. For example, when we had the list, well, every time I type something, the card list component gets re-rendered because we have new information. The function receives new inputs. Same with the input component. So again, within those components, if we wanted to, we can add component will receive props, should component update, so on and so forth. And finally, with unmounting is when a component is removed from a page. For example, if we change to a different page here, the component will unmount. The app component will get deleted from the page. These are called lifecycle hooks because they get run every time a component does something, and it comes with React. So you can just put them into your class component, and they'll automatically get triggered. You don't have to worry about calling them. Let me demonstrate this for you. We want to use component did mount, which gets called after render. This says that, yes, the app component is mounted on the web page and it's rendered. That is, it's displaying something. Well, we can do that by saying component did mount. And because this is part of React, notice that I'm not using arrow functions here. Now, within component did mount, I can say console.log check. If I refresh this and open up the console, you'll see that I have check. If I refresh, there you go. That was really quick, but you see that that gets called automatically even though I haven't said anything. Using this, we can do something interesting. Now, when component does mount, I can say this.setState to now have robots to the robots that we get from the JavaScript file. If I do this and save, let's refresh and see what happens. It's really, really fast, but you see that we're getting our robots. I am saying run the constructor with an empty array just to show you the order of execution here. If I add a console log and we'll just say 1 here, we'll say 2 here, and we'll just say 3. If I save this and open up the console, I have 1, 3, 2, 3. Let's just check that. We have 1 that runs first, then 3, which is render, then 2, which is component did mount, and then 3 runs again. Actually, let's change this to actual words so that you see better what is actually happening. All right. If we save and refresh, look at that. We have constructor that runs first, then render, then component did mount, just like this order. But we now also have render. Why did render run again? Well, if you remember, we created the constructor, we ran render, and then we updated the state in component didMount. So because we updated the state, every time the state changes, remember, we go to the lifecycle, it's updating, it runs render again. So because it goes from an empty array to a robots list, render gets rerun. And the virtual DOM notices that there's a difference and repaints our web browser to include the robots. Very cool. Knowing what we just did, we can remove this and finally make this more realistic. Instead of using the robots file, I'm actually going to remove this. And in here, I'm going to show you a cool way to grab this list from here. I'm going to copy the link and I'm going to say fetch, which we'll learn about in the next section. We're just saying make this HTTP request. And fetch receives this. Again, we're just saying go to here, dot then. This is going to receive a response. And this response is, well, this part is a little tricky. You just have to get used to it. .json, we just have to convert the response into, again, something that we'll talk about in the next section. For now, just you can copy and paste this, follow along. We'll come back to this and explain what's happening. And from here, let's add this on a new line so we know exactly what's happening. We'll say .then robots, or we can say users, because in this case we're getting users. And in here we can say this set state robots to equal users. And we have to make sure that we return this. Save. Let's see if that works. Look at that. Let's refresh. And you see that little lag? It is now working. So in here, we can actually make this smaller and reduce it to one line. We should remember how to do that. And we see that we're simply updating state after we fetch. So we fetch whatever the users are. We're getting a response. We're doing some magic here with JSON, which we'll talk about later. And then we're getting the users and updating the users with set state. So if I refresh again, if I don't do this, let's say I just here don't do anything and return an empty object, you see that I don't receive the robots. I only receive the robots after I update with these users. How cool is that? All right, that was a lot, and this probably looks pretty scary. To make you feel a little bit more comfortable, because I'm using fetch and there's nothing attached to it, does this mean that it's part of the window object? Let's check. If I open up the console and I do window.fetch, yeah, look at that. Fetch is a method on the window object. It comes with all browsers now. It is a tool for us to make requests to servers. And as you can see, this is a server that returns for us when we do /users, a list of users that we can use, which is perfect for our app. And finally, you're wondering, what if this was really slow? What if this took, 5 seconds and we had a whole ton of users? Well, in that case, you can do something like an if statement. If robots.length is 0, in that case, we can return an h1 that says loading. Else, we can just say return this. Again, it's just JavaScript. That's the beauty in React. Oh, and you see how I get robots is not defined because it's this.state.robots. Again, we're referring to the state of the app. And here, if I refresh, let's just say that we're not updating the state, and I'm going to just return an empty object. Well, in that case, I just get loading. Very cool. And this is how you build real apps with React. You have a loading bar that you can just add here, make requests on component did mount, and interact with components. Very cool. You know what? We have ourselves our app. There's one last thing I'm going to show you with React, and you've learned the basics in React. You can take this now to build any app that you want. So one more thing to go, one more little piece to get our React knowledge completed. I'll see you in the next one. Bye-bye. Our robo friends are looking really, really nice. I really like this app. There is one issue though. If I minimize this, okay, it's responsive, it looks good. But if I scroll down, well, I lose my search bar at the top. Would it be nice if this was at the top and I have a scroll that I can do and still search through my friends? Well, you might be thinking, well, there's probably a CSS style that I can add here, but I want to illustrate to you the fact that React and why React is so good is because you can create components that are reusable, not just car components, but functionality. Wouldn't it be cool if there was maybe something where we can add around card lists? Maybe I can create a scroll component, and this scroll component just wraps the card list. And now card list will be completely scrollable. But now I can use scroll, this component, anywhere in my app. Anytime I need scrolling, I can just wrap it around. Can we do this? Let's give it a try. I'm going to import a component that we don't have yet, that's called scroll, from a file that we'll create in just a second. Let's create a new file. We'll call it scroll.js. And here we'll, again, go through the motion of React from React. Let's make this a little bit bigger. And again, I want to change this to Babel. And we'll say const scroll equals. It's going to return. What should it return? Before we talk about that, just so we don't forget, we have to export default scroll. Now here's a problem. We want to return something, but it doesn't make sense, does it? If I go to app.js, scroll, it's not a self-closing component. It wraps components. So how can we tell scroll to, hey, just render whatever is inside of you? Up to this point, we've learned about props and we've learned about state. There's one other thing in React that I want to teach you, and that is children. And children is this. Scroll can use children as a way to render its children. What do I mean by that? Well, in here, every props object has children. So if I go props.children, well, let's see what happens. I save and go back. Everything's rendered. But if I remove this and I just do an H1, I just get this. You see, props.children is exactly that. If I console.log props, let's open up the console, I see that I get an object. And even though I didn't pass any props to scroll, automatically every single component in React has this property, children. And this children, it kind of looks confusing here, but has card list, type card list. So using this props.children, we can create components that wrap other components. Up to this point, we were only able to wrap these lowercase components, which are kind of like the HTML tags. But every time we had a custom component with capital letter that we built, well, we couldn't really wrap it. And now we can using this .children. But here's the cool part. Using props.children, well, I can create a scrollable component. Let me show you how. Simply do div, close that div, and in here, again, curly brackets, props.children. And all we need now is to add styles to this div. I could create a scroll.css file and add a style so it's scrollable, but I want to show you another way, which is using style. Just like in HTML, using the style attribute, in JSX, I can add styles, but using double curly brackets. That is, this is a JavaScript expression, and within this, I'm returning an object. And this object can have CSS styles, such as a property overflow y, which is a CSS property. And this, we can say scroll, again, a CSS way to make the element scrollable. We'll say border is 1 pixel, solid, black. And then finally, we'll give it a height of 500 pixels. I'm going to make this smaller so you can see. I'm going to save. Compiling is fine. If I go back, it looks like we have a box here. Let's make it a little bit bigger just so you can see. I'm going to say 5 pixels, even though it's ugly. Oh, and I forgot a T in here. Height. All right, let's see. Look at that. We have a scrollable component. Let's make this a little bit bigger just so we can see it better. Look at that. If I make this smaller, I now have a scrollable component inside of this. Very cool. Now, this is a simple app. It allows you to search. It allows you to scroll. But it does show the power of React, doesn't it? We've created these simple functions, and the only thing that we tell it to do is, well, we tell it what state it has. The entire app is described through these two things, the robots and search field. And React takes care of the rest. As soon as search field or robots changes, React trickles down all this information as props to all these components and magically creates our view for us. That's why React is so powerful. It's a view layer. It takes care of manipulating the DOM, and all we tell it is, hey, what's the state? What are the functions that you want it to work with the state? And the rest, well, it optimizes to make sure that everything is super fast. And you can see how amazingly fast everything is here. It's a super snappy app, and these components are now reusable. I can bring search box now into another part of the website. I can add scrolling to another part of the website. This is what made React so powerful. And this is why so many websites are powered by React. Once you learn the syntax and you get used to everything, that's when React truly becomes powerful. And although we took a bit of time to create this app, once you get used to it, an app like this, you can create it in, well, less than an hour, probably 30 minutes. All right, I think we've done a great job here. Can't wait to see you in the next video. Bye-bye. I want to add one final thing that we've kind of overlooked up until this point because, well, I don't want to bog you down with too many things. If we take a look at our project, well, it's a lot of files. Even though it's a simple app, you can imagine how bigger and bigger and bigger this source file can get. And organization is a big part of working on projects. Most applications will be way bigger than the ones that we've built, and we need a good way to organize these. And folder structure is one of the most important things. So let's clean up this code. I'll show you what I would do if I was working on this application and I want to make it more extensible. That is cleaner, so when other people come on the team, they understand it, and also I can keep growing this code base. First thing I will do is I'll create a few folders. One is going to be called components. And these are the components that we've built, such as card list, search box, and scroll. The second one is going to be called containers. And containers are these smart components, the containing components that have state in them, that have lifecycle hooks, that have the class syntax. You see, these components or these containers, we can't use a pure function with them because technically they're not pure. They have state that they modify within these functions, and that's okay. It's impossible to have just pure functions because most of the time, well, we need to make requests to the outside world. But these components are special, and we're going to call them containers. They contain things, and they just pass down state to components. Now, we can just say that we're going to move app.css to now be in containers. We're also going to say app.js. We're going to move it to be in containers as well. And then the components, the simple functions, pure functions that we've created, search box, scroll, and card list, well, these can be in components. Let's just open up the folder and make this simpler. I'm going to close the tab, open up RoboFriends, and let's open up source. We'll say that scroll, search box, card, and card list, which are just pure functions, are inside of components. Now, if you remember, our font is also part of the app.css file. So we'll move that in there as well because it's defined in there. With that, let's go back to our app. And well, now we have a lot of fails because these now refer to different parts. We don't app, well, lives in a different folder than card list and search box and scroll. The way we do that is we use ... which means leave the folder or go to the folder, and then from there, go into the containers, from the containers, so where app.js is, I'm going to leave, which is ... And then once I'm at here at the folder level, I'm going to say components. And I can do the same for the rest of them as well. Save. And we also have index.js that now is referring to app that lives in containers. So again, because we're now leaving a folder, we're in the same neighborhood. Well, we can just do .containers app. Let's save. Oh, and I spelled out wrong. Good spelling by me. Everything looks fine. Let's go back to our website. There you go. Everything is scrolling nicely. Okay, so we have a nice folder structure here. Things have cleaned up. And we also have scroll.js. And I think we just have an extra copy of it. So we might have made a copy of that. Make sure everything still works. Yeah, everything still works. We want to remove a couple of spaces here that we've done. We also notice a few errors. So not necessarily errors, but stylistic things. For example, with the filter, I say filter the robots and iterate through the robots. That doesn't really make sense, does it? It should be each item is a robot user that we get. So I save that. Still the same, no errors. I also see a bit of cleaning that can be done with using this.state a lot. We can just say, again, using destructuring, we can say const robots and search field, we're doing destructuring, equals this dot state. And now I can remove this dot state from here. I can remove this dot state from here and from all the other places that we're using this dot state in the render. If I save, everything still works, but the code is much cleaner. We also notice that within here, robots.length equals 0. There's actually an easier way of doing this. And again, it's just stylistic. This is going to equal 0. So if this is 0, that's going to evaluate in JavaScript to false. So we can just say the opposite. Remember this syntax? So if this is 0, which is going to be false, turn it into true so that if there's no robots, we're loading. Save, and that should still work. And then finally, if you see an if-else statement, well, we can do a ternary, can we? We can say return robots. If there's robots, return this. Let's see if that still works. Oh, we don't need that extra bracket. Look at that, it still works. And you can see now that things are much cleaner. We have an app that renders all our things for us. And to finish off, remember package.json, how we had some pre-built scripts? And we had this build command. If I stop this now and I do npm build or npm run build, check this out. While this is building, they've created a new folder called build. And within here, we have all our files, but this time optimized. What does that mean? Well, if we go to static and go to JS, look at that. Everything is minified for us. Our CSS is optimized. And everything that we need to deploy the website is in this folder. So we can now take this build folder and put it anywhere. So it's on the internet. And it even gives you some good information. So now we have this optimized build. We don't have to minify it. We don't have to do all these optimization. It goes through Babel so that we can use import statements in the browsers. And now this build folder can now be deployed anywhere. Like I said, Create React App takes away all the pain of the setup. Everything is done for you. You can just write code, use React components from around the web to build beautiful websites. I hope you're excited about React as I am. This is why it's such a popular tool, and this is why so many companies now are using it. I'll see you in the next one. Bye-bye. Welcome back. I've just put our RoboFriends project on GitHub. But let's say you're downloading this project. Maybe you're sharing a project with other developers. But this project, let's say, was written last year. How can we update this project? If you remember, when we look at the package.json file, we have the React version as 16.2, but the React version is now higher. So let's update this project as you would on any other project. I'm going to clone this repo, and I'm going to use SSH. You might have to use HTTPS if you haven't had that set up. But I'm going to use SSH just so I don't have to enter my password every time. So I'm going to clone this repo, say git clone RoboFriends. Awesome. Now if I go into my RoboFriends folder and I open this in Sublime, there we go. We have our package.json file, which we can see over here. Now, when I usually download a project, I want to make sure it starts. So I'm going to say npm start and make sure that everything is still working. Oh, and I get an error because I have to first do npm install. Oh boy. And we get a bunch of errors or warnings saying we've audited some of your packages. And there's a few vulnerabilities, actually quite a lot and two critical ones. And we can run npm audit fix to fix them. So let's copy that and run that again. And now I get another issue that 27 vulnerabilities required manual review. And you see here that it's mainly because some of them require what we call breaking changes. It might break our app. And this is the trade-off when updating libraries. You are using an older version of a library that may have changed and now breaks your app completely. So sometimes you want to go one by one to actually check and see what the changes are in these libraries. Now, if I run npm audit here, it'll actually give me some idea of what my issues are. Now, before I do npm audit fix and then do -- force to force all those changes, I want to talk a little bit about this package.json. You see, the React scripts, which is the create React app script that runs, is outdated. There's a way higher version of React scripts, a bigger version of the CRA, create React app, and same with React. So one thing I can do is say npm update. And if I run this, and when I click on this file, check this out. Did you see that? My versions got updated. Now, npm update, what it does is it looks at this version and says, what's the highest version that I can upgrade to? In my case, because I used the caret, it said, hey, you can upgrade to whatever the highest version is in the minor release. So if there was a React version 17, well, this wouldn't upgrade to 17 because we're using the caret. Remember, we can use greater than if we want to. But this way, we make sure that we only update whatever is in the minor release, which tends to not have any breaking changes. For example, when we have React 17, that's most likely going to have some breaking changes. Okay, so we have the React version updated, but we still have these vulnerabilities that we need to fix. Let's now run the audit, fix, and force, assuming that we've looked through the changes and we assume that it's okay. Everything should still work. So I'm going to run this. And again, keep in mind that when using force, you want to make sure that you actually review the updates. Now, while this is going, another thing I could have done with React is actually gone to the React website and checked the actual version. And instead of having the caret or doing npm update, I could just change the version. Let's say version 17 comes out in React, 17.0.2. Well, I can just change that in package.json and run npm install again. Let's clear this. we see here that our React scripts is now updated to version 3.2. That is the latest version of Create React App. That's awesome. If I do NPM audit, once again, I have 0 vulnerabilities. All right, looks like everything is looking fine, but we have one issue, right? We've updated everything that we have. There's no vulnerabilities, but because we've updated all these things, will our project still work? Well, there's one way to find out. Let's do npm start. All right, the new Create React app asks me for a target browser. So I'll click yes here. And look at that. Looks like things are still working. Good job, RoboFriends. If I open up the developer tools and I go to console, there's no errors. That's great. So just like that, I was able to update my project, upgrade my project with all the latest React, all the latest React DOM, the React scripts, which is what Create React app uses. We have tachyons updated as well, and everything is working fine. So I can now push this change to GitHub so that we don't have those security warnings. Let's do that. I'm going to say git add, git commit. I'll say fixing security issues, updated libraries. If I do git push origin master, because, well, I'm the only one on this project, so I can just push to master. Now, if I go back to my GitHub page and I refresh, let's check out the security tab. And look at that. We have 0 closed, 0 open, because our project is now fully up to date. How cool is that? This is a great way to keep your projects updated and the security vulnerabilities fixed. But the more libraries you have, the more dependencies you have, the more maintenance you have to do to make sure that every time you update a library, that it doesn't break your app. Our RoboFriends app was fairly small, but you can imagine this being a bigger and bigger issue as applications grow. But I hope you learned one little trick that took me a long time to actually learn in my developer career. That is, the easiest way to keep your projects up to date and secure is to just simply update the package.json file. I'll see you in the next one. Bye-bye. Welcome back. Now that you learned how to update your projects and have the latest version of a library, let's do a fun little exercise. I want you to update your RoboFriends project to the latest libraries. So if you have been working on the RoboFriends app yourself, then open up that project. If not, you can clone the project from the link we've provided for you for the final RoboFriends app. And once you have that, open up package.json and let's have a look at the version available to us. So pause the video and see if you can update your project to the latest and then check it to make sure that everything runs. All right, now assuming you paused the video and tried everything yourself, let's see how I would update this project. All right, now here's the thing. When I am recording this video, this is actually the latest version of React and React DOM, but there is some new changes. If we go to the official React documentation, we see that this is the latest version. We can usually see it at the top. The docs usually point to the latest. But we see an announcement here, React version 17. And React version 17 is the new major release for React. So based on when you're watching this video, React 17 might be up here. But I want to demonstrate to you what you might want to do if you want to play around with release candidates. These are versions of React that aren't finalized yet. It's a release candidate, and soon it'll be the official version. But let's say you want to play around with some new features that they bring to React. Now, keep in mind that React 17 actually doesn't have any new features. You can see it right here. No new features. They have essentially created this new version of React just to make it easier to upgrade React itself in the future. So it's all internal changes that we as developers might not really care about. We'll just have some benefits down the road. But if we wanted to download this version of React, we can't just simply say React 17 in here and just do 0, 0. But whenever you get into this situation where you already have the highest version possible, but there might be a new feature or a new release candidate, what you can do is usually within the post, there'll be a link to try out this release candidate. So let's scroll down. And there you go, installation. So I can simply just copy this. So let's use NPM and install the latest version. And now if we go to package, and there we go. We have the latest version now. Now, we don't recommend actually using a release candidate in a production app, but for testing out new features, that's always a nice thing to do. By the time you watch this video, it's probably no longer a release candidate, and you can probably upgrade to the latest version, whatever it is, 17.0, 17.1, so on and so on. So let's test out the app. So I'm going to do npm start and make sure our RoboFriends app still works. All right, everything looks good. And because React 17 doesn't have no real changes for developers, well, we expect the app to work. Hopefully you were able to update your app to the latest version. I'll see you in the next one. Bye-bye. Welcome back. At the beginning of this React section, I told you that things are going to get a little bit overwhelming, but at the end, you're going to understand everything and things are going to make sense. I want to show you exactly how much you've learned. You've learned that components, well, now this makes sense, right? You are building components during this section to combine things into containers and then finally have a page or an app. You also learned that there is one-way data flow. That is, everything flows from state to props, and you can have multiple children, but the only people that can change state is a container component. In our case, we only have one container component, but you can have multiple. And data just flows down one way, and anytime a child component changes, they just trigger an event on the parent. And you saw how awesome that was. We didn't think about how we should render things. We were doing things deterministically. That is, here's the state of the app, render it accordingly, and React took care of it for us. We also learned that, well, exactly what I said. React worries about painting and making the website look good. We just give it the data and the components. We learned that React has an awesome ecosystem. We had great tools where we're able to start and build, and it gave us great errors. So all these pain points that we had when we were first building our websites, well, they're gone. Everything is built for you, so that you're ready to just focus on coding without having to worry about configuration. When we get to our final project, we're going to be using React components to build something really fast and just plug and play these components. And finally, well, this shouldn't look confusing to you anymore. This makes sense. This whole thing that looked intimidating at first, well, this is just React. In this one image, you have majority of what React is. And once you get used to the syntax, it's an elegant solution to building beautiful web apps that are simple, scalable, and easy to manage. Good job getting this far in the course. It takes a lot of dedication to get through this, but you did it. You're almost there. I'll see you in the next one. Bye-bye. Let's add one more tool to our knowledge in React. And React 16, which was a new version of React, introduced something called error boundaries. And it solved the problem that React had previously, which was if there was some sort of an error within a component, for whatever reason, there wasn't a graceful way to handle it. On the next render, you'd get all these cryptic errors and things just wouldn't work out nicely. And for a user, you want to make sure that even if a part of your component tree breaks, you can still have a nice UI experience, maybe a piece of text that says something went wrong, but not have the app break. So in this video, we're going to talk about error boundaries and apply it to our RoboFriends app. Let's get started. The first thing I want to do is in the component, I'm going to add a new file, and we'll call this component error boundary. And just as a reminder, you do need React 16 or higher for this to work. So make sure that in your package.json file that you have the right version of React. Now in here, we can do our regular import React component, and we're importing that from the React package. And then finally, we have a class of error boundary that extends the React component. And within here, we have the constructor. And again, we call super here. And just so we have access to the props, we'll have to, within the constructor, have the props parameter. And then finally, for this dot state, we're going to create a property called has error. And for now, it's going to be false. And let's also not forget to export default error boundary so we have access to it. And have our default render here that will return for us. What should it return? Well, ideally, with this error boundary component, we can wrap the component, or we can wrap a component such as the card list component with an error boundary component. And if the card list component fails, we can catch it in the error boundary. I know this is a little bit hard to follow. React does have really good documentation on this, so you can always read up on it later, but stick with me, trust me, it's going to make sense. So the first thing we want to do is we want to check if this.state.hasError is equal to true. So if there is some sort of an error, then we want to return this default state of how can we gracefully display something to the user that makes it meaningful to them, even though we weren't able to display what we intended originally. In our case, we can just say that we have an H1 of, oops, that is not good for the user to see. So we're saying here that if for some reason there's an error, we're going to just spit out an H1 tag. Otherwise, and we could just do a return here, we're going to say that this.props.children will render. Again, remember, because children will be anything that's in between error boundary. In our case, it's probably going to be the card list. So render the children, whatever is inside of error boundary. Otherwise, render H1. Now, how are we going to be able to change this has error? Well, with React 16, we have a new lifecycle method that was introduced. And it's called component did catch. And this component did catch is kind of like the try catch block in JavaScript. If anything errors out, it'll run this lifecycle hook. And this lifecycle hook actually gets a couple of parameters, that is the error and the info. But in our case, we just want to say that this.setState is going to now, if this component errors out, is going to have hasError equal to true. So if that ever gets triggered, we're going to render the H1 tag. All right, let's save. And let's go to app.js. let's import our error boundaries from our components. And now we can use this, let's use it over here for the card list. So if something goes on with the card list, we want to have some sort of a graceful exit, a boundary. So we'll say error boundary. And because we're rendering this props.children, if we wrap it like this and nothing goes on, it'll still render card list. So let's save. Let's see if we made any mistakes. So far, so good. Let's go back to our app. And all right, let's look at the console. No errors here. If we refresh, no errors here. If I type stuff, no errors. That's good. Now, with this error boundary, if anything in the card list fails, it's going to catch it and display our error message. So let's see what I mean. If I go into card list here, and now in here, if we say if, for now, we'll just say true, we're going to assume that card list there was an error. So we can do that by saying throw new error. We'll say no. If we save this, everything is still working. If I go back, you see that I'm still getting the error. It says onCut error, no. And at the bottom it says the above error occurred in the card list component. React will try to recreate this component tree from scratch using the error boundary you provided, error boundary. Okay, that's great, but I still see the error. And that is because we're running right now in development mode. For Create React App, they want to show us whenever there's an error in our component. Error boundaries are really useful when you put your apps into production, where you don't have this detailed logs of what errors you have. Your users are never going to see this. So if I refresh here really fast, did you see that right over here, how it said, oops, that is not good. Oops, that is not good. So in production, users are going to see that. But for our case, the intended behavior for Create React App in development is to show us the errors. But with error boundaries, we have that extra safety during production. That's it for now. I'll see you in the next one. Bye-bye. Hey everybody. We have our RoboFriends app now on GitHub. And you should be able to put up your RoboFriends project on GitHub. But here's the thing. Would it be nice if we can use GitHub pages to actually check out our RoboFriends app without having us to clone, download, NPM install, just like we've done with simple HTML projects? Well, with the Create React app, there's actually a way to do this using GitHub pages. Now, I'll link to this resource so that you can follow step by step, but let's just go through it and see how easy it is. I have the project right here. It says that I need to add a homepage to package.json. So let's do that. I'm going to copy this and add it in our package.json. It doesn't matter where it is. Let's add it right after the name. Make this a little bit bigger. I'm going to add my username here. And this is the repository name. In our case, what was it? It was RoboFriends. So again, use your GitHub username, and then in here, add your GitHub project name. Next, if we go through the steps, it says that I need to install GitHub Pages, this package, and then add it to my deploy script. So let's just copy and paste this. So if you're using NPM, you can do that. If you're using your Yarn, this is the command. So let's install GitHub Pages. And while that's getting installed, let's go back here. And it shows here that we need to add these two lines, a pre-deploy and deploy in our scripts. So once again, go to our scripts. and then copy and paste this line. So we have the pre-deploy and the deploy. So the pre-deploy runs npm run build, which we know what that does. It builds our project. It creates a production version of our project and creates a build folder. And then the deploy is going to use this GitHub pages that we just installed and use our build folder. Let's go back. All right, and then finally, we had to deploy this site by running npm run deploy. So let's do that. Let me save. And then in here, let's clear this, do npm run deploy, which is this script. And remember, the pre-deploy is going to be run before it. So if I run this, looks like I have an error in my JSON package. Let's see. What am I missing here? Well, I have a comma at the end here, which I don't need. Let's run that again. You see that the build folder was just created. It's creating an optimized production build. That's great. And there we have it. Our project is now published. Now, all we have to do is go back to our repository, go to settings, and if we scroll all the way down to GitHub pages, we have to change the source to GitHub pages branch. Now you might have to wait a couple of minutes or even refresh the page to make sure that the changes have been applied. And if all goes well, remember, we're selecting the GitHub pages branch, and I click on this link and I refresh. There you go. Our RoboFriends app is now live at this URL. So I can just copy this URL, go to my project, click edit, and then add our website right here. So next time anybody comes and checks out our repository, they can just click here to see the live project. How cool is that? Nice and simple. And just like that, we have a production-ready app. Because remember, Create React App, for us, optimizes everything and keeps everything really, really tiny for production. Our JavaScript files, well, they're minimized, they look very small, and, well, nothing like we had before with containers and components. All of that, because we use Create React App, gets optimized for production. Congratulations. Go show off to your friends. I'll see you in the next one. Bye-bye. In 1989, Tim Berners-Lee invented the HTML that changed the world. But HTML wouldn't really do much if we couldn't fetch documents from around the world and different computers. For that to happen, Tim built the Hypertext Transfer Protocol, or HTTP for short. Now, remember these arrows from the diagrams that we've had? We told you that these arrows were simply the connected wires and cables that connected the World Wide Web. This, right? You remember the diagram. But you see, these are just wires. There are no instructions on how to do things. For that, you need something called a protocol. Think of it as a standard that everyone follows. If everyone agrees, then the protocol works and can be used by everyone. HTTP that I have here is a protocol which allows the fetching of resources such as HTML documents. I mean, it's in the name, right? Hypertext Transfer Protocol. Now, with the use of HTML and HTTP, we now have the World Wide Web. We can grab HTML files and receive them. If we go to google.com/about, we go to the About HTML page, we grab it and receive it. So HTTP is the protocol or the rules that we use over the wires. It is the foundation of any data exchange on the web. And it paved the way for something called a client-server protocol, which means requests are initiated by the recipient, which in our case is the web browser. So they send out a request using HTTP. The server now understands what the web browser is saying because it's speaking in HTTP. And the server can now respond with HTML, and the browser understands it because it's speaking through HTTP once again. So you should think of HTTP as a common language that a client and a server can use to communicate. They're simply saying, hey, can you give me this document? And the server can say, yep, no problem, here it is. And up until this point, we haven't really spoken to a server in our app, have we? We build the front-end applications or the client-facing applications using HTML, CSS, JavaScript, and React. But we lived in our own world, no communications with another computer. HTTP allows us now to communicate with servers, with the outside world. So let's go over the terminology one more time. Clients and servers can communicate by exchanging individual messages. The messages sent by the client, usually a web browser, are called requests, and the messages sent by the server are usually called responses. So if HTTP is the language that allows us to communicate between these two, teach me some of the words, right? I mean, that's a good question. And lucky for you, HTTP is quite easy to learn because you only have a few words. And I'm going to show you what they are right now. You have get, you have post, you have put, and finally you have delete. And now you're thinking, that's it? And yeah, HTTP is beautiful because it's just simple. You don't need to overcomplicate things. You learn these 4 words and these languages, and you can build the app of your dreams. So let's go through it one by one. Get means, well, I want to get an HTML file. So you ask to get something, and the server responds with that request. A post says, I want to post something. So that is, I'm going to send over some data to Google servers, and I want you to post. I want you to add it to your servers or your database. Put is, I'm going to send you some data, and I want you to update some data that already exists in Google servers and just update it with this new information. And then delete means, well, delete a piece of data on the backend, on the servers or on the database. So if we use Twitter as an example, get will be to receive the Twitter feed with all the tweets from today. Post would be if you created a new user and you want to add that user to the Twitter servers. Put would be if you made a tweet but you want to make a change or an edit, so you edit that tweet. And delete will mean, well, you either delete your user account or delete a tweet. And don't worry, we're going to use these when we get to the backend section and we build our final project. Now, over the years, HTTP was extended to not only worry about text, not only fetch hypertext documents like HTML, but also images and videos and post content to servers like with HTML form results. And HTTP can also be used to fetch part of documents to update web pages on demand, which is called AJAX. And we have a video coming up talking about this. But the main idea still stands. Using these 4 verbs we just learned, we can now communicate with servers. All right, so we know that this arrow over here at the top uses HTTP to make requests using one of these 4 verbs. Okay, so I think you get the request part. Now, what does the server respond with? What about response here? The server sends you 2 main things. One is an HTTP message that is something that you've definitely seen before. And I'll link to this W3 Schools resources. A 200 message means successful. You probably have seen 200 OK before. You might have seen 404 messages, which means not found. If you enter a URL that doesn't exist, you'll get a 404. And maybe sometimes you'll get a 500 error message that is, well, there's something wrong with the server. So this is just a number code that comes with every response that tells you the response of the server. So that's the first one. The second one is usually some sort of data, like HTML. And so far, that's what we've been doing, HTML. But in the next videos, I'll show you that it can send other things other than just simple HTML. So let's add to this diagram now. We want to say that this also has a status code, and we'll say 200 for now, that everything was fine. And in the response, we give the status code plus the new HTML file. All right, let's actually demonstrate this online and see how you can watch this action take place. I have over here a great website called example.com, and it's a simple website. You can go visit it right now. But the cool part about it is if you open up your developer console, up to this point, we've looked at the Elements tab and then the Console tab. I want to show you the Network tab that we have here. Now, the Network tab, you might have to click on some of these icons, and you'll see that different things will pop up. Make sure that the filter is gone. Everything is unclicked. And now at example.com, while this is open, just simply refresh. And look at that. I'm going to click on this icon, which makes it a little bit bigger. This is a plugin, so don't worry about this JavaScript. But the top thing, it says example.com, status 200 OK, and type document. And it even tells me the size, the time that it took to get this, which is 53 milliseconds. That's pretty fast. So that means the server responded with 200. If I click on this, I get a whole bunch of things that we don't really need to worry about, but a few things. Request URL, this is what we requested. We get a status code of 200 from the server. And if we click on the response, there's the response message. We received the HTML document from the server. If we go back to headers, we also see that our request method was a get. We did a get request. Let's close this and refresh again. I now get a 304 status. A 304, if we look over here, means not modified. Indicates the request page has not been modified since the last requested. Because I've already requested this now, Google is smart enough to say, oh, I'm not going to worry about the server and requesting the same thing over and over. I already have it memorized, so here it is. Very cool. So Network tab is really, really useful for that. All right, so you can go ahead and play with example.com and see for yourself how HTTP works. And by the way, yes, this HTTP that you see here, that's what it means. When you do an HTTP request, it says, hey, do HTTP. We're using the World Wide Web and go request this from the server. Very cool. And if you're wondering about the S, don't worry. I'll let you know at the end of this video what that means as well. All right, now what if I want to send data? If we go back to our diagram, I'm just doing a GET request, but what if I want to actually send some information to the server other than some URL saying I want this information? Well, there's two ways that you can do it. One is something called query string, and then the second one is through the body of the request. So I'm going to show you how both of those work. I have over here the form that we created in our first advanced HTML section when we only knew HTML. Let's open this file up. I have it over here. If I double click, you remember this, don't you? We've come a long, long way. In this form, if you remember, we had a form method get. And now you might understand what this get means. It's saying, with this form, I want you to do a get request. let's see what happens when I click register while opening the network tab. I'm going to click register. All right, so we have this request. We see that we have made a request and it has created these things called query strings, the first way of sending data to the server. With a GET request, if you want to send information through a form, it adds it to the URL using this question mark, which says, hey, I'm about to send you some query strings, and it's going to have a key and a value. In this case, first name, last name, everything's empty, so there's no information, but otherwise it'll say first name equals Andre. If I click on this, we see that there's query string parameters that we've sent. We have first name, last name, email, password, and birthday, which is blank. But if we scroll down, in cars, default is Volvo, so that we have cars Volvo. So this information now is sent to the server. That's query string parameters using GET. And we did mention one thing though. We see that we have password in here. That's not very secure, is it? If I went back to the form and I type in secret and I click register again, well, now I have my password out in the open, sent over the wire, and I even have it up here, my URL bar. All right, we'll get back to that. So that is one way. The second way is through the body of the request. Let me show you how that works. The way we send information to the body is we use a post request. And this is something that you'll more often see than a GET request, is that we want to add some form data to the server. So we want to post something. If I change this over here, I'm going to save this. And let's open up a new tab with the new saved data. This one is a post form. If I open it up here and I type in password secret and I click on register, I get register.html, but no query strings. If I click on this, I see that now instead of query strings, it's form data. And it even says content type, application, XWW form URL encoded. And this is just an HTML way of saying that this is a form and this is the body, but not displaying here. So now the server can access it not from the query params, and don't worry, I'll show you how servers do that when we get to the backend section. Instead of accessing it through the query params, I can now access it through the form data. So let's go back to the diagram. We now understand that we can do HTTP requests using get, post, put, delete. I can use query strings, which are at the top of the URL, to send the data, or the body of the request. And then the server responds with a status code based on how my request was, and it returns that with a response. But the one issue we saw was that, well, the password was visible in both cases, wasn't it? And what if I have a scary looking person over here? There you go. What if we had a person who was watching our communication, our HTTP requests, and monitoring it? If I used query strings to put my password in there, well, he can just look over my shoulders and see, oh, Andre's password is secret. I can now log into his Google account. Or if I use the body way of sending data, well, he can find a way to get this request to come over to him first and just look at the form data and see that my password is secret. That's not very good, is it? Well, one solution to this was the idea of HTTPS. Now, HTTPS means Hypertext Transfer Protocol Secure. And you can see over here that W3C uses the secure version of HTTPS. The communication between the browser and the websites are now encrypted. And what does that mean? Encrypted just means that it's jumbled up so only the client and the server know the secret pass or secret key to read the message. And this S part, the secret, uses a technology called Transport Layer Security, or its predecessor, Secure Sockets Layer, or TLS and SSL for short. So now, even with HTTPS, if the attacker, or what we call a man in the middle, the person who's just monitoring our requests, even if they get our password, it's going to be just complete gibberish. It's going to have something similar to this, and well, that's not our password, so it's going to be meaningless. It avoids that attack. This is just a tip as a developer that you should tell all your friends. If you're ever sending sensitive information, maybe logging into a bank account, make sure that there's HTTPS out there. If there's no HTTPS when you're sending maybe your login with your password, well, that's not secure. All right, let's review. Your web browser is a HTTP client sending requests to the server machines. When the browser user enters file requests by either opening a file or typing a URL or clicking on a hypertext link, an anchor tag, the browser builds an HTTP request and sends it to communicate with the server. Now the server can get information back to us. The earliest version, we could use URL parameters such as google.com/about and just specifically get HTML. That was it. Then came the form. So we can now actually send more data other than just the URL saying we want to go to this HTML file. Now we can use get or post to send data, either through a body or a query string. And a server can take action based on that data and return a new page. And this is the foundation of the web and how the World Wide Web we have now was made possible through client-server communication. In the next few videos, we're going to learn even more to really understand this power. I'll see you in the next one. Bye-bye. Welcome back. There's one missing piece with the diagram we created in the previous video on HTTP. We talked about URL parameters such as the google.com/about and query string parameters we can do with get. But what about the data when we post something? Can we post anything? Well, not really. When exchanging data between a browser and a server, the data can only be text. So we can't just send a JavaScript object such as a user with first name John and last name Doe. One, because HTTP won't understand it. But also, if we were sending this data to Google servers, well, unlike the front end, the web browser where HTML, CSS, and JavaScript is a standard, when I send a user object to the server, a server can use any type of language like Python, Go, PHP. If we send them a JavaScript type, like an object, they will really be confused because they would have no idea what it is. That's not really their language. Text, on the other hand, can be understood by all. So we need a way to have a standard way to send data over the wires and receive it. That is what JSON is, and what we're going to talk about in this video. JSON stands for JavaScript Object Notation. It's a syntax for storing and exchanging data, and it's text written with JavaScript Object Notation. Let's look at the second point here. JSON is a syntax for storing and exchanging data. It's used to send data between machines. Is it the only way? No. There's also XML. Both XML and JSON can be used to receive data from a web server. And you can see the differences between the two. These are the same data, just first names and last names of employees. And XML uses this HTML-like syntax, while JSON uses, well, an object, JavaScript object-like syntax. But the standard is now more towards JSON, because when you're writing front-end code in JavaScript, getting a JSON data back makes it easier to load that data into an object tree because it's so similar to a JavaScript object than an XML. And JSON format is a more succinct way which saves bandwidth and improves response times when sending messages back and forth between client and server. And XML is just not very efficient. So JSON now is more of a standard. You'll still see XML, but it is outdated, so we won't be talking about it in this video. But they both are used to transfer data between two machines that might not speak the same language. JSON, however, although it looks similar to JavaScript, it is a little bit different. It has these double quotes for even properties. Everything has to be a string and wrapped around double quotes. And, well, it looks like it's a object syntax. But JSON can be read by any language. If Google servers was running a different language, they'll understand JSON. They'll be able to modify that JSON, which is just text, into their own version. So now we can convert this into a JSON object, send it over HTTP, and then the Google servers, or whatever it is, will change it to their own language, understand it, and then send a response again. Let's say, for example, it was returning the user has money, $345. Well, it will then modify this to JSON, send it over the wire, and then the web browser will change it from JSON to JavaScript. But how can we do that? Luckily for us, JavaScript comes with its own JSON function. We have JSON parse and JSON stringify. With JSON parse, if we had JSON, again, this form, we simply wrap it as the parameter of parse, and it will return a object. In the opposite way, with stringify, we can give it an object, such as the one we just created, and it will return JSON. So this myJSON variable can now be put into the HTTP request to send it over the wire. Or the server can respond with myJSON. So let's review. JSON is text, and we can convert any JavaScript object into JSON and send JSON to the server. We can also convert any JSON received from the server into JavaScript objects. This way we can work with data as JavaScript objects with no complicated translation. And this text can be used as a data format for any programming language. So let's go through the flow one more time now with this complete. User object. Before I send it with HTTP, I will do JSON.stringify user. So now it's converted into a JSON string. And this JSON string will be sent over HTTP to the Google servers. It is then going to say JSON parse this user so it understands it. Let's say it was running JavaScript or Node. Now it'll understand the user. It'll say, oh, he wants the money amount for this user. So now it gets money, $345 from the account. It stringifies it, the money variable, sends it with a status code of 200. And now the web browser can parse this string that it received and see that, oh yeah, I have a variable money of $345. And don't worry, when we get to the backend section, in a few videos, we are going to show you exactly how to do this in code, how to make HTTP requests, use JSON, use get, post, put, delete methods. And I'm going to show you how to do that in our final project as well. But now this diagram, although a little bit messy, should make a little bit more sense. And you should understand now how things are working. In the next video, I'm going to introduce you to something that changed web browsing in 2006. I'll see you in that one. Bye-bye. Welcome back. In the previous videos, we learned about HTTP and JSON. We learned that we can send requests and get responses. But there's one issue. Up until now, every time we need to communicate with the server, we make that request. Then the browser, when it receives the response, does a page refresh. Originally, page loading on the web was simple. You'd send a request for a website to a server, and as long as nothing went wrong, the assets would be downloaded by the web page and displayed on your computer. The trouble with this model is that whenever you want to update any parts of the page, for example, display a new set of products, like on Amazon, well, you'll have to load the entire program again. Even the outline, even the navigation bar at the top, everything had to get reloaded, a complete page refresh. This is extremely wasteful and results in a poor user experience, especially as pages get larger and more complex. You can think of it on the Udemy website. If we go to Udemy, well, if I click on, let's say, marketing, the top bar will remain. Do you see that? It's a nice user experience. I can click on tabs and I won't get a complete page refresh. It loads data automatically on the page. Now, this issue that we had here led to creation of technologies that allow web pages to request small chunks of data, such as HTML, XML, plain text, JSON, and display them only when needed, helping to solve this refresh problem. And the technology was called AJAX. It allowed you to read from a web server after the page has loaded and update a web page without reloading the page. And finally, send data in the background while the user is interacting with the website. It was actually pioneered by Google in 2006 and now is what we expect of websites. And any web app you see online uses AJAX now. You see, Google had this big problem. When we're searching something, well, you would initially type in Apple and it would do a complete page refresh. But now with this, I can maintain the top bar and have this loaded. I can even have suggestions brought up from the server. And this is all a response from the server saying these are some of the suggestions based on Apple Store. So it was a big problem for Google and they were able to solve it with AJAX. But now we all have this ability. So how are we able to do this? What is AJAX? AJAX is just a technology, a method of combining pieces together to achieve this. And it was achieved using a tool that browsers built, and it was called XML HTTP request. It looked something like this. You created a new XML HTTP request object. As you can see, it looks a little bit tough. You make a request, you make a GET request at this URL. You say on load when it loads. If the status, the response, is greater than 200 or less than 400, it's a success. We're going to parse the response text. Remember, because we're receiving a string from the server. If it's not a success, well, we can return an error, and we then send our request and also listen for any errors. It looks pretty tough, but it is things that we've gone over. But don't worry, we actually don't do this anymore. This was the old way of doing it when Ajax was first introduced. jQuery came along and said, well, this is kind of tough to do every time. We'll make it easy for you by just doing this. And that was another part of the reason that jQuery was popular. We can just do Ajax requests doing this method. But now there's actually an even nicer, newer way that we've used actually when we build our React app, and it's supported by the browsers. And that is called fetch. As you remember, it was fetch at a URL, and then we did this .then response, and we received a response. Now, this is a really good thing because page updates are a lot quicker and you don't have to wait for the page to refresh, meaning that the site feels faster and more responsive. Also, less data is downloaded on each update, meaning less wasted bandwidth. And this is a major issue, especially on mobile devices where internet connection might not be as good. Ajax allows web pages, and by extension, web applications, to change content dynamically. And it is everywhere. It is something that is just very nice. It looks intimidating, but it's just a matter of doing this, fetch, that does HTTP for you. And all you do is say, if you want to do a get, a post, and add some JSON data to that request. So let's review again what happens with Ajax. An event occurs on a web page, such as logging in, and I click sign in. XML HTTP request object, again, something that web browsers have implemented, is created, and that's created using JavaScript. XML HTTP request object sends a request to the web server. The server processes the request, and then the server sends a response back to the web page. The response is read by JavaScript, and the user is able to log in. At the same time, only updating a small portion of the window. That is what a single page application is. And it's a word that you've probably heard before, and it's a trend in how to make web apps, where you load a base, an almost empty page, and build the content on the fly based on the data fetched from the server. Let's go back to Udemy. When I click on a course, let's do public relations, you see that this is loading one at a time. I had the top bar loaded, then I had a pause, and then the rest loaded. If I click on explore course, you see again that top bar loaded, other parts of the web slowly dynamically load. And again, if I go back to photography, for example, again, parts of the web page load dynamically. And that's the beauty. These applications nearly never do a full reload. They destroy the previous content, all or part of it, and rebuild it based on new data, new page. And this might sound familiar to you. Do you remember how we built our RoboFriends app? We fetched this URL that gave us users. So now that we understand these concepts, let's go line by line and see what happens. I used fetch. Based on what I said, fetch should be part of the window object, right? Let's check. If I open up the console and I do window.fetch, fetch is a function that we can use. And this URL, if you remember, returns for us, what is that? A JSON object. And this JSON object, fetch allows us to do something called response.json. Well, let's just do this for now and see what happens. I'm going to copy and paste this. I'm going to open up the console. And I'm going to open up a new tab to show you that you can do this from anywhere. If I copy and paste this fetch, I get something called a promise. And this is something in JavaScript that you'll get used to. promise is saying, hey, I'm making a request somewhere over the internet, and I promise to let you know when I have this value returned. So the way you access promises, so you have this, once this is returned, give me the value, you do .then, and it gives you the response. If I add to my previous request .then, and I do response console.log response, look at that. I get a response. Status 200. We remember this. Okay, that's good. And we also get this body, but it says readable stream. And fetch, I mean, we learned about JSON.parse to parse JSON. But fetch actually comes with its own method called, well, JSON. So on this response, if we do JSON, it will actually convert it for us. Let's see. If I go back to that request again, I get a response. If instead of console logging, I say response.json, in that case, I get a promise again. So that means we need to do .then to receive whenever this returns the promise, which is the value. So again, I go up and do .then. And in this case, let's see what data we receive. We get data, and we'll console.log data. If I press enter, look at that. We receive our users, the same users that were here. So you see now that we simply use the fetch API, which allows us to do an AJAX call after the component mounted. So once our RoboFriends app was loaded, we made an AJAX request using the fetch API. We got a response, which was a promise. So we had to do .then. And this response, and this is just standard that anytime you do fetch, you'll just remember doing .json. I converted this into something that, well, we can use in JavaScript. And because this returned a promise, we did .then, we got the users, and now we have the users object. And we never had to refresh the page. And by the way, if you want this JSON, whenever you're accessing it to look prettier and be a little bit more readable, I am using a Chrome extension called JSON View. It's free. You just add it to Chrome. It automatically does it for you. I highly recommend it. Okay, let's go back to this. This should make sense now. We now have the ability to dynamically load our web pages, make single page applications using AJAX. And AJAX is a combination of tools of using the fetch API, using HTTP, using JSON to communicate with servers. And now we have a complete picture of our front end. Our front end can have HTML, CSS, JavaScript, React. We can use AJAX to communicate with servers. And we use JSON data to send data over the wire. I'm really excited for the next couple of videos. So I'll see you in that one. Bye-bye.
Promises are a new feature in JavaScript as of ES6. But that means they're really useful to have them introduced as part of the language, right? Well, you're absolutely right. Promises are everywhere. And in this video, I'm going to show you what they are, how they work, and hopefully you'll understand why we should all be jumping for joy that we have them instead of callbacks. Now, in order to understand promises, let's define it. A promise is an object that may produce a single value sometime in the future, either a resolved value or a reason that it's not resolved or rejected. A promise may be in one of three possible states: fulfilled, rejected, or pending. Huh? Let's figure out what that means in this video so that by the end of it, that is all going to make sense to you. Now, in order to fully grasp the concept, we must first talk about what we had before promises, and that is callbacks. Something like this. When something is done, execute this piece of code. Callbacks in JavaScript are exactly that. I text my friend Bob and say, "Hey Bob, what's that really good song by the Backstreet Boys?" When Bob has time, he calls me back and says, "Oh yeah, that song? It's I Want It That Way." And that's exactly what's happening here too. We have an element that we're adding an event listener to, and when a user clicks, we're going to have the callback submit form. That is, once the user clicks, we're going to answer with submit form. Let's think of another example. Let's say we're creating a game, and we have this move player function that has the distance to move the player and the direction. Well, if I wanted to move player 100 to the left, I'd run that. Once that is done, I wanted to run a callback function, which is to move player 400 to the left again, and then another callback function right after that is done to move player 10 to the right, and another callback function to move player 330 to the left. And we have something called the pyramid of doom. This is obviously a simple example, but with callbacks, you'll get this nested function, and you create this pyramid of really, really complicated code of this happens, then this happens, then this happens, then this happens. And it's really, really hard to read. Let me show you a more realistic example. Let's say we had some sort of an app that uses Twitter. And let me make this bigger so you can see. We have a grab tweets function that the first parameter has the URL. For now, I just simplified it. We just passed Twitter and the Twitter handle. And then the callback function, after you grab the tweets, which has an error and the tweets. And if there's an error, we throw an error. So that just creates an error in JavaScript. Otherwise, we're going to display the tweets. But then if Andre's tweets were successful, then we also want to grab the tweets again. Let's do Elon Musk this time. And again, if error, we're going to throw error. Otherwise, we're going to display his tweets. And if that's successful, then we're also going to grab Vitalik Buterin's tweets. And again, if error, throw error. Otherwise, display tweets. And that doesn't look very pretty, does it? I mean, we have to do the same thing. We have to check for error at each time. We have it nested. And just overall, we have a lot of repetition of code. Now, promises serve the same purpose as callbacks. So why do we have two things? Well, promises are new in ES6, and they're a little bit more powerful. Let me show you what a promise looks like. You remember this move player code? Well, this with a promise would look something like this. Doesn't that look much, much better? But it's really hard to grasp what's happening here without really knowing how to create a promise. So let's start with that. I'm going to remove this and create our very first promise. We'll say const promise equals, and this is a new syntax that you'll just have to get used to, new promise. So we're creating a new promise. And this promise has parameter that either resolves or rejects. And in here, in this function, we have the option to, let's just say, either resolve, and let's just do stuff worked, or reject. And in this case, we have an error, it broke. Now, we obviously want to have a conditional statement here. We'll say if condition, in our case, we'll just let it be true for now. If true, so this is if the promise returned, we're going to resolve it. Otherwise, we're going to reject. And here's the thing, this looks confusing without actually knowing the application, but I want you to just have this over here so you can take a look at it as we progress through this video. This is going to make more and more sense. So now that we have a promise, if I put this into my console, my Chrome browser, all right, I have the promise now, but how can we get this promise to run now? Well, I can just do promise dot then. So again, once the promise is resolved or rejected, dot then, I want to get the results, and then we want to console.log the result. That's it. So let's see what happens here. I'm going to copy this, paste it on here. Stuff worked. All right, so we ran the promise, it ran this part, and because we've just made if equals to true, this is going to run the resolve, and the resolve is going to send stuff worked into the result, and we're going to console log stuff worked. And you also see over here that the promise is resolved. Again, if I just log promise here, I see that we have the promise with stuffed worked. Awesome. Okay, so based on what we know now, let's just take a look at what we can do with promises. Let's say that now with stuffed worked, I want to grab the result and add an exclamation mark to it. And then, and this is called chaining in promises, then after I do that, it's going to return the result with the exclamation mark. And in our case, I just want to get the result too, and we will just console.log result2. All right, well, let's see what happens now. So I have my promise, just to make sure that we have it here. Perfect. And we're going to run the promise. Stuff worked with the exclamation mark. Very cool. But what happens if something happens in between here? We just have a console log, but let's say we have an error, and that error causes us to throw an error. Well, what happens now? With promises, you can actually do something called .catch. And this will catch any error that the promise may have. In our case, we just want to console.log. And now, if I run this, we console log the error. Let's just make this a little bit cleaner so that you can see exactly what is happening. There you go. So again, copy and paste. There you go. We get the error. If the throw error happens before, let's say it happens above, and we want to return this. Well, if I move the throw error at the top over here, save, and again, copy and paste. Let's clean this up a bit and see that we still get the error. So .catch catches any errors that may happen between the chains .then, which is very, very cool. All right, so I have a little question for you. What happens if we do something along this line? Let me just go back to what we had before. We don't have an error in there anymore. But this time we have result2 plus the question mark. So we're going to add a question mark to that. We're going to return that. We're going to catch with console.log error. And after that, we're going to have a .then result3. And that result3 will have result3 plus, let's do another exclamation mark. And we want to console log this. So again, oops, we're going to console.log this. All right, what do you think is going to happen? Let's see. We save, copy and paste, and look at that. We have stuff worked, exclamation, question mark, exclamation. So catch only runs if something fails in between here. But because I placed it before this, if this fails, well, I don't get the error console. I get an error within our console because we did throw an error, but the catch statement never runs. So where you put the catch statement is it's going to check and run if anything before it fails. All right, awesome. So that's how we create a promise. A promise has a resolve and a reject. And so far, it's only been resolved. It's just worked out. We've never run the reject. We'll do that later on. But we see that with a promise, we can give it to a variable and run this and do something with it asynchronously when we run .then and get the result and do whatever you want with it. We can keep chaining it, and we can also catch our errors. A promise is something that you have now that you can use around your code even though you don't have the value just yet. You can just assign it to a variable like we did here, to a const promise. Now, when would this be a good thing? Well, promises are great for asynchronous programming. If you don't remember what that is, make sure you check out my video on how JavaScript works to grasp the concept. When you don't want JavaScript to block the execution of your code, like making API calls, grabbing data from a database, or maybe optimizing an image, you use a promise so that the task happens in the background. When the promise gets resolved or rejected, then you'll get that response. Now, let's show you something else that promises can do that makes them really, really powerful. Let's say that within here, we had another promise, a const promise 2, and this promise, again, has a resolve, reject, now we can make this a little bit smaller, and this resolve reject is going to have a set timeout. So set timeout is a web API. It allows us to time out and run something after a few seconds. So set timeout, we're going to say resolve in 100 seconds or 100 milliseconds the hi text. Okay, don't worry too much about the syntax. Essentially, this is saying run this and return resolve hi in 100 milliseconds. Let's also have another promise. Let's say promise 3, and this one resolves in 1 second, and this one's going to say Pookie. And then finally a fourth promise, and this fourth promise is going to resolve in 3 seconds, and it's going to say, is it me you're looking for? All right, so we have these promises. Well, again, a feature that we have is something called promise.all. And promise.all takes an array of promises, in our case, promise 1, promise 2, promise 3, and then let's do promise 4. That's a lot of promises. And in here, we can do a .then, and the values will be returned as an array in the order that they were just written down. And here we can just console.log values. Let's save. And I'm going to copy this into our console. Actually, let's just copy and paste all of these. Watch the bottom of the screen here. As I press enter, 1, 2, 3, 4, 5, and we have our result 5 seconds later. You see here that even though these ones took a lot less, well, because we did promise.all, it waited until all the promises were resolved and then logged out the values. Very cool. And by the way, the reason that if I do this, where I assign the variables first and then run promise.all, the result is instant. And that is because we've already run these promises, right? We've assigned it to a variable, and between the time that we copied and pasted this in here, these promises in the background have been resolved. All right, let's finish up with the final example that has some real-world applications so that you have an idea of when we want to use promises. I'm going to delete this, refresh. Now, I have here a list of URLs, and these URLs are from a simple API. Let me show you. Called JSON placeholder. And they just give us some endpoints that we can use, such as users that return us some JSON data. So I have users, posts, and albums here. And this is very similar to something you do on a website where you want to grab some information, maybe from your server, from the database with users, posts, and albums. And let's say that they're all important to us for the page, for the profile page of the user. How can we grab them all? Well, again, using promises, we can just do promise.all, and we can just grab the URLs. And in this case, we can just map over this, so it's an array. And with each URL that we grab, we want to fetch, again, a web API to grab the URLs, make an AJAX call to the URL, then we want to run the response through the response.json. Again, that just comes with fetch that you need to do. And then from here, we can do a .then. And this is going to return us, remember, an array because we're getting a promise of all these fetches. It's going to return results. These results, well, for now, let's just console.log them. And we'll do results. The first one, the second one, and the third one. Let's see if that works. I'm going to copy all of these. Let's go back to our page, copy and paste our code, waiting a bit, and there you go. There's our response. We see that we got undefined here because I put 3 here instead of 2. Let's do that. We copy and paste this again. I'm going to refresh the page. And there you go. We have our users, we have our posts, and then we also have our albums. Very cool. Let's say that something fails here. Maybe we misspell one of the URLs. So the users API won't work. Let's add a .catch and console.log. Error. If I copy and paste this, refresh, and again, run this through the console, look at that. We get an error. With promise.all, if everything fails because we need users, posts, and albums for our entire page on our website, we get a reject from the promise and we can catch it. And we can do whatever we want with this error. Very cool. All right, so let's fix that. So it's working again. And there you go. That's why promises are so beneficial. We're able to do something like this in a very clean way. Remember, the fetch simply returns a promise. If I just run fetch here, you see that I get a promise that's pending. And by adding a .then, we are answering to whatever the promise returns with, whether it's resolved or rejects, and we get to manipulate the data. So, at their most basic, promises are a bit like event listeners, except a promise can only succeed or fail once. It cannot succeed or fail twice. And this is extremely useful for things that are asynchronous success and failure, such as API calls, because we're less interested in the exact time something became available and more interested in reacting to the outcome. So we're reacting to something that happens asynchronously. So again, let's remember what we started with. A promise is an object that may produce a single value sometime in the future, either resolved or rejected with a reason why it was rejected. And a promise may be in one of three possible states. It can be fulfilled, rejected, or pending. See? That wasn't so bad, was it? Now go off and practice some promises and see all their power. I'll see you in the next one. Bye-bye. The new feature in JavaScript that everyone is talking about lately, async await. In this video, we're going to learn what all the hype is about. To get started, you must first know that async await is part of ES8 and is built on top of promises. If you aren't sure what promises are, make sure you check out that video first. Now, underneath the hood, an async function is a function that returns a promise. But the benefit of async await is that it makes code easier to read. Let me show you what I mean. This is a promise that we just made up. It's a move player function. Imagine we're designing a game and it has the distance plus the direction that the player moves. And if we want to chain these, we have move player, .then, move player again, move player again, move player again. Now, this is asynchronous code. We know that move player is going to happen, then this is going to happen, then this, then this. If we want to have any sort of action within here, we can wrap it in brackets and console log, add extra actions, all things that you can do with promises. With async await, it would look something like this. What's going on here? The big benefit of async await is that it makes code easier to read. And I know you're probably not thinking that right now because this is new syntax, but just give it a chance. The goal with async await is to make code look synchronous. A code that's asynchronous look synchronous. Now, if you remember, a promise in JavaScript is kind of like an IOU. I promise to return something to you in the future. Something like an AJAX call, resizing an image, getting some information from a database. These are all things that take time. Instead of waiting around on them, we want to continue on with our lives and just have it let us know when it's done. But we're going to keep working on our own stuff while it's doing that in the background. We do it this way because that is how JavaScript works. If you remember, in our How JavaScript Works video, we talked about JavaScript being single-threaded. For our programs to be efficient, we can use asynchronous programming to do these things. So promises help us solve this, and it looked like this. Now remember what I said at the beginning. Async await code are just promises underneath the hood. We call this syntactic sugar, something that still does the same thing, but is just different syntax to make it look prettier, syntactic sugar. And promises have this .then that you keep having to chain. Async, on the other hand, has this async word in front of it and some await keywords. So let's go through what all this means. Although these two things do the same, with the player start function, we first declare a function as async. We let JavaScript know, hey, this is an async function, and we declare it with the word function and then the function name. We now can do anything we want inside of this function, but we have access to a new word because we used the async word to define this function. We have the await keyword. And this keyword says, and we can remove this for now. This await keyword says, hey, pause this function until I have something for you. So we're awaiting the response. And you can use this await keyword in front of any function that returns a promise, which we know that move player does. And once the promise is resolved, then the function moves to the next line, and it awaits the next move, and awaits the next move, and awaits the next move. Now, the cool thing about this is that instead of chaining it like this, I can now assign, just like asynchronous programming, variable first to await this, and I can assign second to await this. And first and second will have the result of each function, but in a variable. So it looks very synchronous. You're not using .then, you're not chaining. You just have simple synchronous programming. You're waiting for this to happen, then waiting for this to happen. But let's use a more realistic example so we really understand this. If we use our fetch function, and again, if you remember, fetch function, that's a promise. You see that we get a promise. So with the fetch function, if we use our favorite API resource, JSON placeholder, let's grab the users here. So this user's endpoint, if we want to fetch something, we did return a promise, so we would do a .then response. We would have to run it through JSON, and then finally .then console.log the response or the data that we get. So again, if I copy and paste this into our console, get a promise that's pending initially, then it gets resolved, and I get my users. Now, how can we turn this into an async function? Again, the same feature, it'll work the same, but it will look a little bit cleaner. It will be syntactic sugar. Well, if you remember, we have to declare a function with async keyword, and this function will say fetch users. And fetch users will have this inside of it. But we can now use, in front of anything that returns a promise, the await keyword. So now this function is going to pause until we get a response from fetch. So I can say const response equals await the fetch call. And now, instead of using the .then, I can say const data equals await response.json, because again, response.json returns a promise, so I can put the await keyword. And then finally, I can just console.log data. All right, let's copy and paste this and see if it works. All right, now I call the fetch users function, which is the async function. Oh, and I made a bit of an error here. There's no response, it's short form response. There you go, let's try that again. So let's refresh that, copy and paste, run the fetch users function, and look at that. We have our promise that got resolved, and we have our users. Nothing different from the promise, but now we have a nice step-by-step synchronous looking code that says fetch this, get a response, then run it through the JSON method, and then console log data. And you might be thinking to yourself, is this actually prettier than what we had before? Let's remember what we had before. This is what we had before. This is what we have now. And some of you might argue that the first promise way looks better. And you know what? It's personal preference, and this is a simple example, so there are times where this actually looks a lot cleaner. But I'm a big believer in doing what's easiest to read and understand for you and your teammates. Let's do one last example. Let's do something even more realistic. Let's say that we have a list of URLs, and this time we have the users, the posts, and albums from the JSON placeholder API. And we want to run through them all. If you remember, in our promises video, we had something like this. Let's remove this so we can see it better. So we had something like this. We did promise.all, we mapped through the URLs, we fetched the URLs and responded with the JSON. And then we returned the array, and the array had users, posts, albums, and we also did a .catch. So again, just to make sure that this works, I'm going to copy this, put it into our console, and we see that we get our users, posts, and albums data. So that's working. Let's convert this into an async function. Well, let's start by doing a const get data, and this will be an async function. And I want you to point out that I did it this time with function expression instead of the way that we did it last time, which was async function and then the function name. But I just want to show you both ways. All right, so how can we do a promise.all? Well, if you remember, we can now put the await keyword in front of any promise. So we can put the await keyword in front of promise.all. So I can say that const, and this is a little ES6 magic of destructuring. I can say users, posts, and albums that we're going to receive is going to equal await, and then the promise.all, which we already have. So let's just copy that. We're going to copy the promise.all and place it on here. All right. And now we can just console log what we had. We can copy and paste right after we await all the promises. We'll have users, posts, if I can spell, and then albums. And instead of array, because we've done it with destructuring, we can just say users, posts, and albums. All right, so let's see if this works. Copy and paste this and run get data. And look at that. We got the exact same results. Very cool. But there might be one thing that you noticed here. That is, in the promise way, we have the .catch. If any of these fail, we want to catch these errors. How can we do that with async await? Right now, we're not catching any of these errors. Well, this is the part that not a lot of people are big fans of, but it is something that once you get used to is not too bad. JavaScript has something called try catch blocks, and that is when it sees the try word, it's just going to automatically run whatever's inside of it. In our case, all of this block, we want it to run in a try block. And then try comes with a catch block as well. So try, catch block. And within the catch, if anything fails within here, well, we can catch it in here. So we can just do console.log. Oops. So now, let's say I misspell one of the URLs. Let's copy this. Let's try it out. We'll have the new URLs. Let me clear that. New URLs with the misspelled URL for one of them. We're going to copy and paste the get data. And you'll see over here that we get a syntax error. And that is because one thing you have to remember with catch is that the catch receives an error. And this error, you can console log it if you want. So let's just console log and then try this again. This time we'll just call this one get data 1. Perfect. Now if I clean this up a bit and do get data 1 with the try catch block, I get, oops, type error failed to fetch. So I get the catch block with the error, just like we did with promise.all, just using promises. And there you have it. That's it. Async await, although intimidating at first because there is a bit of new syntax, actually makes things quite nice and synchronous looking. We simply have a variable that we assign the await promise to, and then the function pauses there until the promise returns, and then it continues on with console logging. And you just have to remember the try catch blocks here to catch your errors. And that's it. You're now an async await master. You can use whichever one you prefer. Like I said, at the end of the day, use promises or async await functions based on whichever one is simpler for you and your team. But hopefully, when you encounter both of these, you're now a lot more comfortable. I'll see you in the next one. Bye-bye.
Welcome back. Let's talk about ES9 or ES 2018. There are 3 main new features that you should be aware of for this version of ECMAScript. The first one is the object spread operator. And it looks something like this. If we had an object, let's say animals, and this animals object has a tiger that has age of 23. I don't know how old tigers get. Let's say 23. We have a lion that is 5. Make sure I add the commas. And let's say a monkey that is 2. There's a cute little monkey. With the new object spread operator, let's say I destructure here and say I'll take out tiger. And I can do ... and I can call it whatever I want here. Let's call it rest equals to animals. Well, what's going to happen here is I'm going to grab tiger and the rest is going to include lion and monkey. Let's have a look. I'm going to copy this, paste it on here. Oh, and I have to refresh. Let's try that again. Now, if I grab tiger, I see that tiger is 23. But if I grab a rest, I see that rest now includes lion and monkey. And this is something that we were able to do with arrays in ES6. In ES6, I could have done an array that had 1, 2, 3, 4, 5. And let's say we had a function that we call sum that takes A, B, C, D, and let's say E, and simply returns A plus B plus C plus D plus E. Well, if I copy this here, paste it, I could have done sum ... array, which, as we can see here, gives us the answer 15. I was able to spread the arrays over these parameters so that it was the same thing as doing 1, 2, 3, 4, 5 up here. And this new feature of object spread operator just means we're able to do this with an object as well. So that in the same manner, if we had a function, let's call it object spread, that has, let's say, parameter 1, parameter 2, parameter 3, and let's say we'll console.log p1, p2, and p3. If I run this function saying object spread, and let's bring this down here, and we'll give it tiger, rest, and actually let's add one more here. Let's add bird, that is 40, that's an old bird. And we'll take out line here. So if I do tiger, lion, rest here, and I run this function, let's see what happens. Press enter. Oh, I gotta refresh this so that it sees the variables as new variables. And there we go. We have 23, which is the tiger, that is P1. Then we have the 5, which is the lion. And then monkey and bird as the second or the third parameter. And I know what you're thinking. You're saying, Andre, I'm pretty sure we're able to do this in the React section of the course. And if you caught on to that, good job. In React, when we're building our RoboFriends app, we're able to do this, especially in Redux, where we learned about reducers. And if you don't remember it or you haven't watched that section, don't worry about it. The reason that this worked in React was that Create React App, remember the tool that we used to build our React application, was using object spread operator by default, even though it wasn't officially part of JavaScript because it was so useful. But now that it's part of JavaScript officially, as of ES 2018, you can use it freely. Welcome back. I wanted to talk to you about two other new ES 2018 features. And to show you how they work, we're going to use the example that we had before in the video about promises, where we loop through all these URLs, our Star Wars API URL, we fetched the data, and then we just console logged whatever we received. So that if I copy this and paste it into our console, we get our users. We have Luke Skywalker, C-3PO, R2-D2, and Darth Vader. And if this doesn't look familiar to you, make sure you check out the promises videos first before tackling this one. Now, the first feature I'm going to talk about that's new in JavaScript is called finally. And as the name suggests, it allows us to do something finally after a promise has finished. And the way it works is we add it usually at the end, and this finally block will be called regardless of whether .then works or the promise errors and catches into an error. So no matter what, after everything is done inside of a promise, finally will be called whether it resolves or rejects and does something that we tell it to. In our case, let's say I can have data here, and this data will just console.log to see what we get, and we'll just say extra data. So that when we run this one more time, I'm going to copy. Let's refresh here, copy and paste. I hit enter. We get extra over here, but undefined. And that is because finally doesn't really receive a parameter. So this is usually empty, doesn't receive anything from the promise. So we can just leave this out. But you see here that I was able to call extra even though the .then finished. But what happens if we throw an error and the catch block gets called? We can simulate that fairly easily. We can just do inside of .then. In JavaScript, I can throw an error by saying throw error. And what's going to happen here is as soon as this line reaches, it's going to throw an error, skip over all these console logs, and hit the catch block with this error parameter. So if I save this, or let's copy this, I'm going to refresh the page, copy and paste, and let's see what happens down here. I'm going to hit enter, and we see that, oh, we get the error. The catch block has run with our error, but we also have the extra being called, which is finally. So finally is great for those times that you need to run a piece of code no matter what after a promise. Perhaps you want to send an email to a user regardless of whether their request was successful or failed. Maybe you want to have a little notification icon. There are many ways to use finally, and now there's a way to make sure that something happens after a promise, whatever we tell it to. Now, the next one I want to talk about is a little bit more advanced. And in order to explain it, let's clean this up and talk about the for await of feature. Now, if you remember, we had this piece of code in our async await video. And there I showed you how we're able to use the async await feature of ES8 to make our promises more synchronous looking. Instead of having those promise chains of .then, .catch, we can use async await. Now, the cool thing about this new feature is that it allows us to loop through our async await calls if we have multiple of them, just like we are able to using the for of. So using the for of loop that allowed us to iterate over iterables, we're now able to iterate over the await promises that we're going to have. But instead of talking, let me show you in code. Now, let's say we'll use this as an example. We're going to create a new function, and this is going to be called getData2. Actually, let's remember what the for of loop looks like. If I had a function, let's call it loop through URLs that receives the URL parameter, and it will loop using the for of loop. We'll say URL of URLs, and the URLs is this array over here with 3 URLs. And this for of loop is simply going to loop through everything, and we can just log out the URL. If I copy and paste this, let's refresh here, hit enter, and just do loop through URLs now, and pass in the URLs parameter. I see that I'm just looping through these. So that's what for of was. So using that knowledge, we can now create a new function called getData2. And this new function will do exactly what this one does above, but using the for await of feature. Let's see how that would look. We will have an async function so that we can use the await keyword. And in here, we can have an array of promises. Because an array of promises is iterable and able to be looped by the for await of keywords. So these arrays of promises will simply be our urls.map that will loop. And let's make this a little bit bigger so we can see. That's better. We're going to loop over the URL, and it's going to return the fetch URL. So in here in the first line, all we're doing is creating an array of these fetch promises of each one of these requests. Next, we can use the for await of to loop through these promises. So all we would say is say for await, and in here we'll say let request of array of promises, which is an iterable, is going to loop through each of these promises, each of the requests, and we're going to extract that data from each of the requests by saying await request.json. Because remember, we use the await keyword in front of a promise. And as we know, we're using the await keyword here because we're looping over promises. And we need to await request.json, which again is a promise that receives our data. Remember, similar to how we did here before. And then we simply console.log, let's say data, to see what we get. If I clear this and let's just copy our new code, make this a little bit bigger, and make sure I don't have the semicolon, then I have it here. So let's copy the URLs. Let's refresh the page, copy the URLs, and then we'll also copy the function, paste it in here, hit enter, and let's just clear this. And if I do get data to now, and I run this, we see that, look at that. We've received first the users, which are right here. Let's make this a little bit bigger so we can see. We have the users. And the next up, we have, what do we have next? We have the posts. So 100 posts. And then the next up is the albums. Just like that. And this is the new ES 2018 feature. As you see here, it's the exact same thing as we did above. If I run our original function, get data, we see that we get the exact same results. We have albums, we have posts, we have users. The only thing that the for await of feature does, it allows us to loop through these multiple promises almost as if we're writing synchronous code, right? So to review, we have the finally function that we can run at the end of a promise, and we have the for await of that takes each item from an array of promises that returns to us in the correct order all the responses. All right, I think that's enough. It's time for you to play around with this. I'll see you in the next video. Bye-bye. Welcome back. I want to talk to you about a new ES 2020 feature that we're ready to learn about. You see, up until now, we've learned about promises. We know what they are. We know how to use things like promise.all, .then to receive promises, to get resolved promises, rejected promises. But there's a new feature in ES 2020 that adds to this feature set. So we've learned that in ES6, we got this promise.all. And promise.all, what it did was, well, let's test your knowledge because we learned about this. What will happen if I run this statement? So we have promise1, which is a new promise. And within this promise, we're going to wait with a set timeout 3 seconds, and then we're going to resolve that promise. So promise1 is going to be resolved in 3 seconds. The next promise, promise2, is a new promise that in 3 seconds will actually get rejected. So we have one promise that gets resolved and another one that gets rejected, both in 3 seconds. If I do promise.all and then a dot then to console log whatever we receive, do you know what will happen? Pause the video and think about it, and then let's test it out. Going to copy this, paste it, moment of truth. Promise is pending for 3 seconds, and then, uncut in promise, undefined. Now, why is that? We've learned that promise.all only resolves if both promises resolve here. So in order for us to have this work, we have to do a catch statement. So if I do dot catch, and in here, let's say console.log, something failed. And we'll log out the error as well. If I now do this again, let's refresh, paste this in, 3 seconds, 1, 2, 3, and then something failed. Because promise.all has to have all promises resolve and not throw any errors. But with the new ES 2020 feature, we now have something called all settled. And all settled, as the name suggests, is a little bit different. This time, if we run this, we wait 3 seconds, and then we have promises returning. 1 is fulfilled, 1 is rejected. So what did this do? Well, promise all settled doesn't care about resolve and reject. Unlike promise.all, which short circuits when any of the promises are rejected or settled, the promise all settled runs all promises regardless of whether they reject or not. So the promise only comes back when all promises that have been added to it are complete. So for example, if I change this to 6 seconds here, and I copy this, even though one of the promises rejects, let me refresh so that we have new variables. Even though the first promise that returns is rejected, it doesn't care. All settled just checks for 6 seconds until all the promises are returned. So it's a nice new extra feature for those customizations on your promises. Another fun one. I'll see you in the next one. Bye-bye. It's time to learn another exciting topic, and we're going to get into backend basics, but I wanted to show you what we've covered so far on the front end. We've started with this diagram of asking for whoisgoogle.com and going through the ISP, asking the domain name server for the IP address. We then ask the IP address to find the Google servers, and then the Google servers gives us our HTML, CSS, and JavaScript file, which we're able to get one through HTML, and then the link tags and the script tags to get the CSS and JavaScript. The browser reads the file for us, the HTML and CSS, and the V8 engine, or the JavaScript engine of the browser, uses it to read the JavaScript, and we manipulate the DOM using JavaScript. We also learned that the location of the server is important, how many trips we make, how many HTTP requests we make is important, the size of the files is important, and we learned some of those solutions such as content delivery networks, having script into just a bundle.js file, and also minimizing our files. And then we also learned about this new technology called AJAX, where we can just fetch users, talk to the server while the user is still browsing the website, and receive a JSON response to update the website in real time. And this picture that we started with looks a lot clearer than in that first video, doesn't it? We understand what a front-end developer does. We see the power of React. And we also know that these arrows simply mean HTTP requests, a language that both front-end and back-end can speak, and using AJAX and JSON, we're able to do it dynamically. Now, the back-end and the role of a back-end developer. They're the ones that are in charge of working with servers and databases. And a server is responsible for whatever you get in the browser. I can ask from the browser anything, such as go to google.com. But at the end of the day, the web server can just give me whatever it wants. If it's going to just send me to twitter.com instead of google.com, well, that's up to the server. Whatever we need, we just make the request and we hope that the server gives us what we asked for. And if you remember, a server is just a computer that's somewhere in the world just listening to this HTTP connection, asking to see if we have any files. The most basic of servers, and you might have used this before, maybe using HostGator, a hosting site, or even WordPress sites, and putting them on HostGator. It uses something called a LAMP stack. This was what was useful for the most basic of websites. That is, you just want a simple information website, maybe a simple WordPress website where nothing complex is happening. Nothing professional, really. What they used was a Linux server, which is the operating system. Just like I have Mac, Linux will be the operating system of the server. We have Apache server. Apache is a server, again, a program written by somebody that is really, really good at just accepting requests and sending out responses of files. We had MySQL, which is database. Maybe you had a comment section in your blog and you needed to store that data. That would be the database. And then we had the PHP, which was just a language that you can use to have a bit of logic in your servers. And the server, just like your computer, had a file system where all the files of your website are stored. And Apache just did that. Just listen to see if anybody entered funfunwebsite.com into the URL. If it got that request, it will just default give you index.html. If somebody entered funfunwebsite.com/about, it will just give you about.html. It was very simple, very easy server. That's what most hosting websites like HostGator use. And you might be asking, could I just download Apache server and just run my own server from your computer? Yeah, you absolutely can. But without having a server software, well, our computer is unreachable. Nobody over the internet can access our computer because our computer is not a server, has no code that tells it, hey, if I get a request, send this out. But as you saw in our previous videos, we can create fake servers to test our websites. Now, this was the old way of doing things. There wasn't much logic to it. You couldn't really expand on it. You can't have websites like Facebook or Amazon using this type of a system. Like I said, this was for very basic websites. Now, a new stack, something we call an application server, looks something more like this. Now, an application server is different than our previous example because unlike using Apache server that is very simple and just does request response, just give files there and back, with something like a Node server where you have Node.js running, well, you can write script and say, if I receive a request for a login, then check the user's username in the database. If it matches, then let me know and then send a response through JSON to the front-end application. And we can customize what these scripts say. So far, we've only been able to use JavaScript on the web. But now with Node.js, we can use it on a server, on a computer that isn't running a web browser. with Node.js, we can write JavaScript where if I posted something on Facebook, that post on Facebook, when I click post, will get sent to the Node server that's listening for requests. It will say that Andre just posted this message that is in JSON format. The Node.js and Express.js file on the server will read it and will say, we want to store this post in our database. And this database is going to store that post so that when I come back next time, it's still there. And then once that's done, it's going to respond with a success saying that my post is a success and now it displays in my timeline. I can edit the post, I can delete the post, and again, Node server can delete that post from the database and then send a response and remove it from the timeline. You just have the power to constantly be interacting with the front end. Over the next couple of videos, we're going to be building a project that incorporates all of this. We're going to create a Node server using Express. We're going to create our own database where we store user information. And we're going to be using Ajax and JSON to constantly create, sign in, update user information so we have an understanding of this full system. If you're building websites and web apps, well, you're not really building these. As a web developer, you're building something more similar to this. But you might be asking yourself, is this it? Is this the ultimate end to what a backend server infrastructure can do? Well, no, if you're Facebook or Twitter or Amazon, you would do something like this. And don't get too worried here. We can explain what's going on. You are just making copies of your computer. So think of each of these rectangles as a computer. And because Facebook gets a lot of people, it makes a copy of their server and put it maybe in Asia and one in Africa so that everybody from Asia can access this one and everybody from Africa can access this one instead of having everybody access one server and overload the system. Because they have the same server, is just copying these files and putting it on a server somewhere else. That's it. And that's what we call scaling. But they also still use the same database so that if from this server somebody updates the information, well, this person over here who uses this server, this user will still have access to the information that person using this server updated. And then finally, you have something called a load balancer. And this is similar to what Apache or Nginx would do, where it listens for an HTTP request and it notices that, this one over here in North America is really, really busy right now. I'm going to transfer this person to this server over here, and just balances the load of the servers. And you can keep growing this, having more and more servers as you have more and more users. And finally, you can even have multiple databases. Again, these squares each represent a computer. A computer that's running a database, a computer that's running a server, a computer that's running a load balancer. And you can have multiple databases, again, so that they don't get overwhelmed with all these requests, and each one maintains a copy of the other. And this is something that we'll talk more when we get to the node section and database section. But I wanted to show you the idea behind servers. To work with the backend, the main goal is to make sure that when we make an HTTP request from the front end, that we get a response back as fast as possible with correct data. And that is what backend development is. Making sure that we return those resources so that our front-end team can be confident that we are going to receive exactly what we need. So I want you to get excited because over the next sections, we're going to be focusing on the backend as well as the front end. We're going to build an app that uses all of these technologies in one place. So you know exactly how everything is connected. And you have an idea of how to go from something like this to one day having something like this. I'll see you in the next one. Bye-bye. API, or Application Programming Interface, is a messenger that takes a request and tells the system what to do. Huh? That doesn't mean much, does it? In this video, I'm going to explain to you exactly what an API is without all this confusing wording. I have over here a Skyscanner. If you've never used it, it's an aggregator website. I look for a flight from LA to New York, and it searches all the websites, all the airlines for the best deals for me. Now, how was it able to do that? It found all these flights from different websites, but Skyscanner doesn't really have this information. I mean, this information is somewhere in the database of each individual airline. But as an airline, you're interested in having this data on Skyscanner because people like myself that want to book a flight might not know to go to AmericanAirlines.com. So by having their information listed on a website like this, well, now they can increase their revenue. So how is Skyscanner able to do this without having this information themselves? Well, that's where APIs come in. If you remember, APIs is what allows strangers to speak to each other so that we aren't in a closed system. We can share data and work with each other. And APIs is what allows machines, computers, to communicate. This might sound familiar. It's kind of like how we had web browsers speaking with servers, right? Well, yeah, because API is a broad topic. It applies to the way machines communicate. If I open up my console here, well, I always mention that there's a window object, and the window object has fetch. And fetch is an API. It is given by the browser to use so that I can communicate with this machine, that the console can communicate with the browser. In the same way, although Skyscanner doesn't have access to the databases of American Airlines and Alaska Airlines, all the other airlines use APIs or give access to this information through APIs so that websites like Skyscanner can have the information as well and list it on their websites. The best way to think about it is kind of like a waiter. You're sitting at a table, about to order, and the waiter is the messenger that tells the kitchen what to do. The kitchen is providing the waiter, the restaurant, right? The restaurant is saying, hey, waiter, these are the menu items. Please go ask the customer what he or she wants and let us know so that we can prepare it. And this might sound similar to this, right? We're asking another machine for something using, let's say, a waiter, and this machine gives us a response if we talk to it in a certain way that it expects. And yeah, a server has APIs, ways that you can communicate with it, such as doing users/about. In the same way, we also have our code previously from when we build RoboFriends. React, which is a library built by Facebook, exposes an API, a way to communicate with the React package by doing React component and using JSX. They tell us how to communicate with it, and we're able to communicate with it. Let's work on this a little bit more. What about this? Is this an API? It's the back of a TV. Yeah, it's an API. A TV works in its own way, but it gives you access to a couple of things, such as an HDMI cable, so you can plug into it and communicate with it. such as displaying your laptop into the TV. And we've been using APIs in the RoboFriends demonstration as well. We already talked about React, but you remember the JSON placeholder, the users that we got? Well, if I go to their website, we see that it's a fake online REST API for testing and prototyping. It's an API, so it must be giving us information about something that it has. If we go down, we see that it has resources, and the API tells us we can access them using these methods. So by just writing comments here, I should be able to get 500 comments. And there you go. I get a response in JSON. And even with RoboHash, remember how we were able to get images of robots from this, robohash.org? That's an API. We can say robohash whatever, and because they've said that the way to access this API is to just type in random numbers after robohash.org, we're able to access it. And people build these APIs usually for business reasons, such as airline companies, right? And they have the incentive to comply to industry standards, such as having JSON responses. And that way it makes it easier for a developer like myself to grab bits and pieces from different places. For example, here I have the GitHub API. You can read up on it, but I can access information from GitHub. So I'm accessing the GitHub repo of Facebook. And it tells me how many followers it has, what bio it has. If I go to Apple, I can get the Apple username as well. And you can see that it's in JSON format because that is the standard. If we want to build something with GitHub, well, we can just send a request to this, get this data, and create our website based on this data. But it's not only JSON. If you remember, there's XML as well. This is a sample API that shows us a breakfast menu. And here we can request this data through HTTP and we get breakfast menu. So as you can see, APIs are not just websites. A TV's inputs and outputs, that's an API. An NPM package can be an API. Like I've said before, it's a way that people communicate or machines communicate and share information. Without it, we really wouldn't have what we have now with the World Wide Web. But how is this useful to us? Well, first off, we can build something like this quite easily. We can actually search API JetBlue, API American Airlines. And they'll have information on how we can access this data so we can build our own thing. This website, all it's doing is making an HTTP request to something like here, and then grabbing this data and just adding some CSS to it to make it look nice. And there are a ton of APIs online. You can search them, you can read up on them. Big companies like Facebook have APIs. Google has APIs, and you might know Google Maps. Anytime you see Google Maps on a website, it's using the Google API. We also have silly APIs like this one of my favorites. It's the Star Wars API. It shows you over here, if I do people 2, I get C3PO. If I do people 3, I get R2D2. I can also do planets. This is a free, nice to use API. So you can build a sample app using the Star Wars API, and all you need to do is just fetch this resource, get the JSON, convert it to a JavaScript object, and then style it and use it in your app whichever way you want. There's also some really important APIs that if you're building serious websites, are really useful. This is the Stripe API. If you want to incorporate payments into your website, well, this shows you exactly what to do. And you can add to your server in whichever language you want. In our case, we're interested in Node. And it tells you how you can add Stripe as a payment method on your server. It sounds scary, but it's all documented in here. It's step-by-step instructions of how to do it. Another one that I really like is the Twilio API. And Twilio allows sending of messages on phones. So using something simple like this, you can see there's not much to it other than using this client.messages.create that they provide. And we just say what we want the body of the text to be, to which number, from which number. If we want to include maybe a heart, then we can add that as well. And let's say when a user signs up for a service, well, we can send them a message by saying, hey, we've created a new user. They've provided us their phone number. Send them a text message. Now, you might be thinking, this is almost too good to be true. You have so much power now. You can just research APIs, and all the major websites have APIs, data that they give to you. Well, things like RoboHash and Star Wars API, they're silly and they're fun, and there's no real cost to them. But when you start building real applications and companies like Stripe and Twilio, where there's some real engineering effort behind creating these, well, they charge a service. And that's when you use something like an API key. And an API key looks like gibberish. It is a key, a private key, so that every time you access their API, they know that it's you. And because, let's say you have a plan for making 1,000 requests, they charge you because they can recognize you, saying that, oh, this is Andre's key. He's the one making the request from a server, and we're going to charge him for it. And don't worry, in our final project, we're going to be using a really, really cool machine learning API. And we're going to generate our API key and actually use it. Luckily for us, though, it's free. So it's going to be a lot of fun. But from this video, I want you to remember this. A server somewhere in the world for a company provides an API. In order for other people to use it, they usually tell you how to use it. And they have documentation on how to use it. But most of them comply with a standard like JSON to make it easier for developers like us to use. And at the end of the day, an API is a tool used for data communication. It's how a program, a software, or anything running code allows others to communicate with it. And it opens up a big possibility of making websites that do more than just list robots. You can now, with the same principles, build websites that incorporate different APIs to have the functionality of something like Skyscanner. I'll see you in the next one. Bye-bye.
All right, everybody. We're entering a really, really exciting part of the course because we're about to dive into our final project. Now, don't worry. You still have tons to learn. And we're going to use this final project to teach you things like the backend, working with servers, databases. So we still have a long time to go. But this is the next level of the course. What do I mean by that? Well, right here, we're going to enter something called the snapshot model of learning. If you don't know what that means, don't worry. It's because I totally made it up. But let me explain why this is an exciting section. Remember at the beginning of the course how I said, oh, our course is so good and we're going to teach you all these advanced topics that makes you stand out from everybody else that's learning web development. Well, this idea of snapshot model of learning is what's going to help you get there. And the name comes from this. If you have ever used a Mac, a MacBook has this feature called Time Machine,
where you can go back in time through your files folders and look back on the files that you had, the old files, the old videos, whatever you have on your computer, you can go back in time. And the name snapshot model comes from that, because I want to teach you to solve problems. Because a lot of people that want to become web developers, they learn by watching others like myself code. So you're watching me code, you're watching me build websites, but when you're out there on your own, when you don't have an answer right away, when you can't just Google something and find the exact same code that you need, what do? That's what real life is. Real life, people pay you money as a web developer to solve problems, to answers that aren't necessarily always going to be there. And the way I'm going to teach you in this next section as we build the final project is I'm going to give you roadblocks. And every once in a while, you're going to see a quick note in the course where maybe a library has changed. Maybe because you have a different version of React, a library doesn't work and you need to install another different version of a library. These roadblocks are intentional because it shows you a historical journey through an app. You see, when you are a developer, you don't just build an app and that's it. You have to maintain it. You have to constantly update libraries. You have to change things as libraries and tools evolve. So your job and your skill set isn't just build a website or build an app. It's maintain an app. And you need to learn how to do that. When you encounter a problem from what I show you in the video, what do? Do you turn around and say, hey, I don't know what to do and give up? Or do you say, okay, I see what Andre did in this video. He walked me through his thoughts, but it didn't work for me. Why didn't it work for me? And you need to solve your own problems. Now, I've made it easy because every time there's something that I show you in the video that, let's say, is outdated or the library doesn't work, I'll have a quick note that tells you, hey, heads up, you'll need to update this way. But this way, you get a snapshot of how things were before, and then how, as a developer, in real life scenario, you can update your code and maintain your apps. Now, we're going to be using this API, which I'm going to talk about. And when working with things like APIs, they're notorious for always changing their website, changing how they work. And you have to constantly stay up to date. And I'm going to show you how to do that throughout the course, throughout the final project. Websites like your community page or your dashboard is going to look different than my dashboard. You can see here, switch to legacy portal because they've just recently updated their portals. You'll have things like the way the website looks that is different than what I show you in the video. But remember, what I teach you is how to think like a programmer. I don't want to teach you to just copy what I do. I want you to solve your own problems. And this is intentional. And it's something that I actually teach in one of my courses. And it's called deliberate practice. In the next video, I've included a bonus video on what deliberate practice is and why we want to include it in the course. So let me leave you with this one last thing. As we start to build the final project, I call it the SmartBrain project, you're going to encounter a lot of problems along the way. Sometimes maybe you don't copy exactly what I do. Or maybe you encounter a roadblock because the API changed. What you're going to learn is the ability to solve those problems on your own. I give you a hand, I give you hints, I give you tips on how you can update something, how you can change something so the code works. But anytime you encounter a bit of struggle as you build this final project, remember that's you stretching your imagination, stretching your problem-solving skills, and improving. So this is why this is an exciting part of the course. Because we're not just going to build an app, our final project. We're also going to develop the most important skill of a web developer. And the most important skill of a web developer is the ability to solve problems when the answers aren't clearly there. Now, I hope I didn't scare you off. I promise you it's still going to be fun. You're still going to be able to go through the course. You'll just have a couple of roadblocks along the way to really stretch you and turn you into that advanced web developer. It's going to be a lot of fun, I promise. Let's go dive in. Welcome back. This is an important one and a topic that is a must for anybody that's looking to become a master, and that is deliberate practice. And deliberate practice, as we're going to discover, is going to teach us that the learning process should be tough. Temporary frustrations when learning is a good thing. Now we finally get to talk about Anders Ericsson, which I've mentioned a few times already. He wrote a book called Peak, which is one of the most important books when it comes to learning. And in his book, this idea of deliberate practice gets mentioned quite often. Now, Anders mentions that rock climbers, chess players, and all of these masters can usually visualize things, visualize all their moves ahead of time. They're able to create experiences in their mind, make accurate predictions, and keep a lot of information in their mind. The way they're able to do such things isn't just natural talent, but it's deliberate practice. So what is deliberate practice? Well, deliberate practice usually happens like this. You start to learn a topic, and initially you have rapid progress. That is, things are good at first. You're learning so much at the beginning that you see yourself progressing more and more each day. But then eventually, we always hit what we call a perceived limit, where we start to plateau. And because we don't get that immediate progress that we saw in the past when we were just beginners, we start to get a little bit of frustration where we don't see ourselves improving. We've plateaued. This is where deliberate practice comes in. We want to be just in this area where we're finding a bit of frustration. And for us to improve, we need to have deliberate practice. That is, we're right on the edge of our limits and we're trying to push through to suddenly get a breakthrough and go back to that rapid progress. And then repeat that cycle where we hit a limit, a flat area, and then we practice at this edge, at this uncomfortable edge of our limits, and then move past that. Now, in order to have deliberate practice, we need, according to Anders Ericsson, we need specific goals. We need intense focus. We need immediate feedback. And we need that frequent discomfort by being at the edge of our abilities. And this idea of deliberate practice goes hand in hand with the idea of passive and active learning. It refers to the specific type of practice that is actually what we call purposeful. While regular practice might include things like mindless repetition, deliberate practice actually requires us to be focused, getting that immediate feedback and having that specific goal to know where we want to be. As Anders Ericsson describes it, deliberate practice takes place outside one's comfort zone and requires a student to constantly try things that are just beyond his or her current abilities. Thus, it demands near maximal effort, which is generally not enjoyable. That's right. Unfortunately, deliberate practice is not meant to be fun. It's that practice that is a struggle. It's that area where you feel like you're not good enough. It's pushing yourself to your limits. So, how do we get to the state of deliberate practice? Well, one, we need to make sure that we have periods of undistracted focus. We need that focus mode of thinking for deliberate practice. Next, we need to push ourselves to the edge of your ability. You want to make sure that you're cycling between comfort and discomfort, where you're trying something and learning something and pushing your limits where you find a task too difficult, too hard for you to do. Next, to seek immediate feedback and mentorship. So get help from somebody. Let's say you're learning how to code. Well, try to build your own project and find that it's super difficult. Then you start reaching out to your peers, to your mentor, to your teacher, and seeing if they can help you out with your problem. At the end of the day, there's a reason that you have people that you admire. Famous people like Elon Musk, or Jeff Bezos, Roger Federer, or any type of master. All of them do deliberate practice. And deliberate practice is uncomfortable. If you want to achieve great things in your life, this is simply something you need to do. You can't just achieve things by luck, by not trying. The good news is that the better you get at something, the more enjoyable it becomes. Now, I want us to remember the dip here, because we talked about this idea of obstacles, but also this idea of dip, where we encounter sometimes things that might not help us toward our future goal. Maybe we have unrealistic goals where we actually should turn around and not pursue to become that professional basketball player. Now, there are genetical influences when it comes to performance. Yes, some people are born with better genes than others. Yes, some people have better opportunities than others. Sometimes you're dealt a hand of cards, and that's what you have to play with. But each of us have our own deck of cards. Each one has a hand that has been dealt. But deliberate practice can actually help us maximize our potential. Each of us have different potentials, but by doing deliberate practice, you maximize your hand. You maximize the cards that have been dealt to you. It turns our potential into our reality. Now, to end this video, you might be wondering, what is this image of? This is kendo, or the way of the sword. It's a Japanese martial art, and it has an interesting lesson to teach us about deliberate practice. For that, I'll see you in the next lecture. This is the most exciting part of the course, and I'm really excited to work on this project with you. We're going to be creating our final app, something that we can put in our portfolios and impress our future employers. We're going to use everything we've learned up to this point, and then some later on, to create a full app that has a front end using React. It uses an image recognition API. It has its own server using Node and Express. And then finally, its database as well. We're going to be creating something where you can sign in. We will have a fully responsive website. As you can see, it looks pretty nice. But the cool part is, other than all these fancy animations and the sign out ability that we have, when we enter an image and press detect, it will actually detect faces in the images and put a box around it. Let's try another one. If I select this face, all we need is a URL to an image. And look at that, it detects the face for us. So yes, you're going to build this. I'm going to help you out. And by the end of this, we'll have a fully finished project. And don't worry, for those that just love watching, I'll provide the project files for you at the end of this course. Are you excited? Let's get started. All right, it's time to get started on this. The very first thing I like doing is imagining what we're going to build and trying to separate out the components of our application. So I did a quick wireframe here of what we want our project to look like. We want to have some sort of a logo. We want to have a user's name displayed with their rank. And this rank is going to correspond to how many face detections they've done compared to all the other users. So we're going to want some sort of a sign in and sign out feature. So this is the home page, but if they click sign out, they'll be signed out, and in order to sign in, there'll be a sign-in form. We have a URL input here where we can enter a URL for an image. If we click detect, then it'll display the image with the face detection on hopefully the face. And we obviously want it to be responsive. But looking at this, if I was going to divide this into components, I see that there's a navigation component. There's maybe a user info, maybe rank component. There's a logo component of some sort. There's an input form component, there's an image component. And possibly within that, another component that does the image detection. Okay, so I think the first step that we can do is to start building out these components using Create React App, and the sign in and registration form is maybe something that we can work on afterwards. All right, so let's minimize this. So I've actually just ran Create React App. I called this project Face Recognition Brain. You can do the same as well, but as you can see, I haven't changed anything. If I do npm start, I have the skeleton of what Create React App gives us. All right, to start off, I'm going to start removing some of the things that I don't need. I know that I don't need their logo, so I'm going to delete that. Okay, and then if we go to app.js, and we can just remove the logo. Okay, and we can just remove everything that's inside here. So we're left with just a div with the class name app. And let's just build out some components, even though we haven't created them. Let's just build them out so we have them in our heads. We have a navigation component. That's where we have the sign out. We have a logo component that we'll create. We also have perhaps an image link form. That's our input form. And then finally, we have our face recognition, which will be the image with the face recognition on it. Looking at these 4 components, I think we can build them fairly fast. So let's start to do that. I'm going to actually comment out, I'm going to wrap these in a curly bracket so that it's a JavaScript expression, and then comment them out in the standard JavaScript way. So we can start off with navigation. As we know, because this project is going to get a little big, we're going to just create a new folder. We'll call it components. And within these components, we'll create a new folder and we'll call it navigation. And this navigation folder will have anything related to our navigation component. So that is CSS, JavaScript. In our case, it's just JavaScript for now, so we'll just do navigation.js. All right, well, we have our file all set up now. So in here, we do the standard import React from React. And it's going to be a simple component with no state. So again, we can just do a pure function. And it won't accept any parameters for now. We'll just simply return, just do something like a nav. And this navigation, because we're working on our home screen for now, we're just going to have a p tag that says sign out. And we obviously want to export default navigation, save that. Let's go back here and import that now. So we'll do import navigation from current directory. We want to access the components folder, navigation, then navigation.js. We don't need to put the JS at the end. Save that. Oh, and I have capital components, should be lowercase. And it should be S. Let's go back. We have a nice little sign out. Don't worry, it's going to start looking much better than that. We want this to actually display on the right-hand side. So a nice, simple way of doing that, we can just add a style attribute for now. And again, we're passing it an object, and we'll just say display will be flex and justify. And remember, because this is a JavaScript object, we can't do this. It's camel case. So content in React, you just use camel case anytime you need to use a dash. So justify content will be flex And so it's at the end to the right. Save this, and it's to the right. We need a bit of padding, but for now, that's fine. And you know what? Looking at this, I have a feeling we're going to need some CSS. So I'm going to install tachyons here so that we don't have to worry too much about CSS, and I can just give you the tachyons properties because, again, CSS is something that is very dependent on the specific project. And because we've already covered it, we don't want to spend too much time on it. So using tachyons, I'm just going to use their, I got to install it. Let's clear this. And this way, when we go to app.js, we can just, or in our index.js, we can just import tachyons. Perfect. So using tachyons, I'm going to start styling this. And you can just pause the video and copy and paste this if you want on your project, or grab the project files afterwards. So based on size, I'll do that. It's going to be a link. It's going to dim when I click on it. It'll be black. It's going to be underlined. Padding of 3. And pointer when we hover over it. Kind of reads nicely with tachyons. I'm a big fan of them. Let's do npm start. All right, look at that. That's a lot better already. And you know what? When we look at this white screen, it's kind of discouraging. It feels like we haven't done much. So let's add a nice background so that, again, we're making a bit of progress and we're not looking at a blank screen. Even though styling is not the most important in an app, I do like having a bit of progress when we start a project just for that confidence boost. So in index.css, I'm going to add a background to family, and this is a gradient that I really, really like, so I'm just going to copy and paste it here. You can find your own gradient and decide what is good for you. I'm going to save that. See, we're just using linear gradient. Look at that. That's already much better to look at. All right, so navigation, from what I can see, it's pretty much all we want for now. We don't need to add any functionality. We're just building the skeleton. So let's move to building the input. So the input, we called it the image link form. Oh, actually, let's do the logo first because I see it here. I'm going to put the comments out over here. Again, we are going to do the same thing. So I'm just going to copy and paste this. And we'll just say logo from components, logo, and logo.js. We're just going to create a new folder again. And within that, we'll have a new file, logo.js. And by the way, if you're getting sick and tired of constantly clicking JavaScript, then making sure that Babel is the default instead of the regular JavaScript so you can see JSX. Well, if you go to Views in Sublime and then go to Syntax, you can do open all with current extension as Babel JavaScript. And this way, every time you open a JavaScript file, this will be the default extension. All right, with the logo, you know what? To make things fast, I'm just going to copy the navigation, paste it in here, and I'm just going to change navigation to logo. And obviously, we want to return something different. So we'll say this one will have a div. And we'll give it a class name, again, using tachyons. Some margins that are nice, and that's margin top to 0. And then for the logo, we have nothing yet, but I want to show you this cool library that I found, which is React Tilt. And it actually allows you to create something like this. They can hover and tilt around. Again, beauty of React and NPM is that you can use these packages to make your project look a little bit nicer. So I'm just going to copy this command npm install -- save react tilt. And in case you're wondering what the -- save is, before in the earlier versions of NPM, if you wanted to have the package installed on package.json and the dependencies, you had to do -- save. Now it does it by default, so you don't have to do the -- save anymore. And you can see that React tilt and tachyons is in our package. All right, let's start that back. And if we go to the documentation here, it actually gives you exactly what you need. You just import tilt from React tilt. So we'll do that. So we have the tilt component now. And we just copy and paste this tilt component that they've created for us. Again, the power in being a web developer and just overall in general, it's nice to be able to use things that people have built and also be able to share things that you've created. So you can create your own React component that other people can use, and it makes things, as I said before, more reusable. So looking at this, everything is good. I'm going to change the height and width, maybe a little bit smaller. And for now, we'll have this alien figure, although we're probably going to change it to our own logo. But I'm going to save this, and we get an error about emojis, but it's fine for now. If I go back, all right, it's looking a little bit off. Let's see what's going on here. So if we go to logo, let's just add some tachyons. I see the border radius 2 and shadow 2. So this way I can see more clearly where it is. Okay. All right, so it's working, but our colors are a bit off. It looks like we need to add some background for this, but look at that. It's already working nicely. So I'm going to create a new file, logo.css, and we're going to make the background. It's already using the tilt class name, so we can just piggyback on that to say tilt. And I'm going to use the same background as we have in our index.css file, just because I think it looks nice. I'm going to copy that, put the same background in here, and then the only thing we need to do is just import logo.css from the current directory. Let's check that out. Look at that. That looks great. So one of the cool things you can do with tilt is that you can add it a few options based on what you want it to do. So you can read through this yourself, but I kind of wanted this to be more exaggerated a bit. And we can do that by just changing the max to something a little bit higher. If I save that, all right, that looks nice actually. All right, the next thing we want to do is we want to change this alien emoji. We want to have an actual logo. So let's grab a free logo that we can find online. So let's just find a royalty-free icon, and I want it to have a brain as an icon. So let's see if we can find something here. All right, this might be good. Let's do brain and see if we can find any cool icons. Oh, there you go. This might be a nice one. Let's do PNG, and we'll 100 pixels a little. Actually, that works. We can have different files, but we'll just do PNG, 100 pixels. We will download it. Nice, that looks great. And we'll just move it to our project folder, which is on our desktop. And we can just actually open it up and put it into the folder that we want. In our case, it will be the logo component. So let's move that in there, and we'll call it brain.png. Perfect. I'm going to close that. And now that we have brain.png in there, we can just import. We can just call it brain from the brain.png. And that will be the default name given to it. So we can actually just create an image tag in here. We're going to remove the little alien and we'll just do image. And this image will have a source, obviously. And that source will just be our brain. So let's see if that works. Make sure we close the tags here. Save. We're also getting an error saying that we should have an alt tag. So let's just do that. Alt equals logo. Save that. Look at that. There you go. We need our brain a little bit lower, so I'm going to do that quickly with some CSS. We're going to do padding of 3. And just because I've done this before and I know we need a bit of padding, I'll just add a style on the image that says padding top of 5 pixels. I'm going to make that smaller just so you can see it better. Let's save, see how that looks. There you go. Looking nice. We got ourselves a nice logo. But you can see that we're moving through this fairly quickly. It's nice using React, and as long as you figure out your styles, it's nice to be able to use all these different components to build out your website. So let's go back to app.js and see what else we have. We need the image link form. So again, let's remove the comments and bring up the image link form. We'll create, once again, a new component that is the image link form. We'll use our good old copy and paste. And we won't be needing the tilt or the logo. We're going to have an image link form. Image link form. All right, so let's think about what we need in here. We definitely want to have a paragraph that we'll give it a class name. So it has size f3. And within here, we will just say, and I like, instead of using text this way, because it is JavaScript, I like wrapping it in curly brackets and then doing the quotes, and we'll say this magic, if I can spell, brain will detect faces in your pictures. Give it a try. All right, so we have the paragraph. We also want to have another div where we have an input and a button, perhaps. So we'll just do div. We'll have an input of type. It'll just be text. This is where we'll be entering our URL. Closing that bracket, and then finally we'll have a button that will say detect. And again, we can add a few class names to this just to make it look nicer using tachyons. I'll do, let's say, size of 4, padding of 2. Width is going to be 70%. It's going to be centered. And because I said width 70%, I can do something along the lines of this. I can say width is 30%, so total of 100% for that. Will grow when you hover over it. F4, it'll be a link. And this is, like I said before, a few tachyon commands that you can look up. It's more for stylistic reasons, so we don't really need to worry too much about it. But most of them should be pretty self-explanatory. Background, light, purple. Let's save that and see if that works. All right, awesome. We want these to actually be in one line together. A good way to do that is, again, using the div, the parent div that's wrapping them. And we can just give it a class name. We're going to do display flex and justify content center. We can just create a class on the app.css because I feel like we're going to use that a lot. And we'll just say center is display flex and justify content will be center. You're going to use that a lot, so like I said, it's better to just have it there. Oh, and I think I put a comma in there instead of a semicolon. There you go. If I do center here now, there you go. That looks much better. 70% width with 30% width, but we kind of need something to wrap it here and make it a little bit smaller. So we'll add another div. And this div will have class name of some tachyon magic, which will be PA4, border radius 3, and shadow, which is one of my favorite properties because it gives it a nice shadow. All right, it looks a little bit off. We need to fix a couple of things. And you know what? I think for this one, we're going to need a few more CSS properties. So I'm going to create a new file in our image link form. .css. And within here, we can just create a form class. And we'll give it a width of 700 pixels. If I save that, and I'll give it the center property here as well. All right, that looks better. Now, for the background, again, I don't want it to be the exact same as this. Hopefully, we can use a nice pattern. And I have one of my favorite pattern galleries here where you can pick CSS patterns. So the one that I really like is the honeycomb. And we can just copy and paste this, which Paul Salentini created for us. Thank you, Paul. And just add it in here. Let's save that and go back to our project. And we actually should be adding form in here. Oh, and we don't see any differences because we need to import our file. All right, perfect. Again, we should add display flex to here so everything's on one line, so we can just use the center class name. And there you go. Look at that. We have our pattern. We have our button that grows. And I do want the mouse to actually be like this, a pointer. And I know that for any buttons that I create on here, that's the default behavior that I want. So I can actually go all the way to the top of index.css file and just say that buttons are going to have cursor of pointer so that it affects every button on the page. There you go. That's much better. All right, we're building this pretty fast. I'm impressed. We're doing a good job. So we have the input, and the last thing is the image. But I think we need some functionality before we can actually display the image. We forgot to do the rank, which we want something at the top. So let's do that. Let's add a rank component. And this rank component will give us our username and our rank compared to all the other users that have submitted pictures. We can simply copy and paste, and you can see that there's a lot of repetition here, but we're building things really, really fast because we have a common way of creating these components, which is really, really nice. Copy the ranks. And by doing Command-Control-G, you can actually select all the instances of image link form and change it with logo. Again, pretty awesome feature of Sublime Text. Oh, and instead of rank, this should say, or instead of logo, this should say rank. And within here, we'll just create a nice little component. By the way, if you're wondering how I'm adding these styles so fast, trust me, it took me way too long to figure out what looks good and what doesn't. I'm just avoiding you the pain of watching me figure out what styles look best and going back and forth with the Google Chrome developer tools. Like I said, styling is just so specific to each app that once you get to your specific app, it'll be very dependent on your specific needs. So as long as you know the basics, you'll be able to evolve and change the style of the app whichever way you want. So again, in here, we'll just have, for now, this is going to be dynamic, but for now, we just need some text. We'll just say, Andre, your current rank is, and below it, we'll do the same thing, maybe a little bit bigger this time around. We'll do F1, which is a little bit bigger, and it'll say number 5 for now. Save that. Yeah, let me put that back there. Save. And all right, it's starting to look better. I think the last thing we want to do before we go into the next video and add some functionality is this font is pretty generic, so we want to change that a little bit. So I'm going to change the font in index.css because, well, this is going to affect our entire app. And you can pick your own, but I like Courier New. In case the web browser or the computer that it's on doesn't have that, I'll add some backup. And yeah, this font I am a big fan of. Let's check it out. Look at that. Very nice. Built that pretty fast. All right, you know what? The very last thing I will do, even though I said this was the last thing, is one of my favorite things is this Particles.js library. And you'll actually see it in a lot of websites being used. Particles.js, yeah, it lets you do these sort of things. So you can have a background that's interactive. And you can change how many particles you have and do all these cool things. And I think it makes your web apps look really, really nice. So we're going to use this. They actually have a React version that we can use. So we can just say particles React NPM. And there's a few you can pick from. But this is the one that I've used before, so we'll stick to this one. And again, we can just copy and paste the NPM install. And just so I don't have to keep stopping and starting this, if you do Command D with terminal, you get a new window. But if you want it to be below, if you do Command Shift D, you'll get a window right below it. So in here, I can just do npm install. So now that that's downloaded, if we go down to here, we can see exactly how we can use it. So we can just copy and paste these particles component. We'll add it because it's the background right below the main div element. And as you can see, there's a couple of options here. And there's a few things that you don't really need in here, so I'm going to remove those. And for the parameters, I don't like having our render method be so ugly. So I like taking out the parameters and creating a constant called, let's call it particles options. And outside of here, we can just create that variable just to keep things clean and have this object configurable. So if we save this, let's see how that looks. Oh, I'll get an error because I haven't imported the particles library yet. So again, going back here, I can just copy and paste the import syntax, save it. I'm going to close this for now. Let's go back to our app. You see over here that it's overwritten on top of everything, and everything else is below it. This needs a bit of configuration, and it's a little bit tricky, but we can add something like a new class name, and we'll call it particles. And we'll create this particles class in our CSS. You know what? All this over here we don't use, so I'm going to delete just to keep things clean. And we'll say particles. And this is a new CSS syntax that you might not have seen. It's called fixed. So everything stays, even if you scroll, everything stays exactly where it is. And you can actually get these properties on the particles website. So if you want to read up more on it, you can check it out. But it makes sure that everything is full screen, the background's fixed. And finally, to make sure that everything is underneath the rest of our app, we do something called z-index. And z-index you're allowed to use when you use position fixed or position absolute. And it tells you what layer you want the image to be on. In our case, we're adding -1 because we're saying that this should be below pretty much anything else on our website. If we go back, all right, and you can see here that the patterns are a little bit weird. And I've played around with it already to figure out what particle options I enjoy. And you can customize this and play around with it yourself. The main thing I want to do is have the number of particles to definitely have a lot more. So I'm going to say value 30 and density. We'll have a few options. That should make our app look a lot nicer. Look at that. Again, all these options, you can read up on them on particles.js and the NPM package itself. You can make it interactive as this if you want, but there's definitely a lot of options for you. All right, this is pretty incredible, right? We did that pretty fast, and the cool thing is that everything is responsive. Look at that. So as I move this, we can display this app on our phone as well, and all these mobile devices. Very cool. So we took care of the view and the basic components for now. In the next video, we're actually going to start adding some functionality over here. I'll see you in the next one. Bye-bye.
Woohoo!
we're at a very exciting point in the course because we're going to incorporate a machine learning AI model into our app. It's going to be super fun, super interesting, and we're going to learn a lot and make our app do awesome things. So in order for us to get started, I need to introduce you to the Clarify API, which we're going to use. Now, the beauty with this API is that it allows us to customize things a lot in our app and do some really neat things. Also, it's free. So if we go to the pricing option, we see that for the community, for the first 1,000 operations, it's completely free. So we get to use an awesome model and an awesome API for free. So what we're going to do to get us started